form herbarium should be available. That is another thing. I am very much impressed by your lecture.
Thank you, sir.
Many of our students now came to know that how they can do digitization, and probably some of them may come to your organization and get training and do digitization. I request my co-chair if he wants to say something.
First of all, I am very much acknowledged to sir for you beautifully portray before us the beauty of digitization. I have a doubt regarding the color of the specimen. Mostly the herbarium specimen may be having a brown, dusty brown color, but some allied taxa will be appearing more darker. So whether while you editing the specimens, whether these you are giving...
Sir, if you are using the bar color code,
okay,
then editing is not an issue. What is the purpose of using color code? This is a good question. Suppose you are clicking, suppose now you click images, it never gives the natural color. It never gives. Okay. Then what happens that if you are have put the color codes with the images, while looking at your end on computer, you're supposed to edit to match with physical one and then digital one. But it is not possible when we have lacks of specimen. Okay. So Kodak color code is standard, universally standard. Okay. So suppose you are looking after images and you want to publish somewhere or you want to do something, you can edit at your own end. But I don't say that you go edit and do something. Whatever the getting you, just give. Second, also limitations come during the metadata. Some people or some of the bosses want that you go and start doing research on the metadata. Okay. Nobody is going to rely researcher on your interpretation. What he wants to see the images himself or herself. Okay. So don't go for much on metadata. Your only focus will be to show the images or a specimen what he or she wants. Okay. Whatever the accepted name, people are smart enough. They have the online databases. What the name they have given or given in annotated slip. Okay. Ultimately, they are going to see the images. Do that. Then you can increase your speed of metadata entering. Otherwise, you start doing research on each name, it will take 2-3 days. And also same the editing. Don't go for that. What is the natural? Give. People are smart. They will do himself or herself.
Thank you, sir. Thank you.
Okay. Thank you.
We extend our gratitude to Dr. Bharati for that insightful keynote. Your lecture clearly demonstrated the power of technology in large-scale biological preservation. Thank you, sir. May I invite Dr. S.R. Yadav and Dr. Shinoj K. to present a token of appreciation to Dr. Kumar Avinash Bharati. Thank you, sir. Now I request Dr. A.K. Pandey to felicitate Dr. S.R. Yadav and Dr. Shinoj K., who graciously chaired this session. Thank you all. Now, I would like to invite Dr. Shweta Subramaniam, the organizing secretary of the upcoming IAAT conference, which is to be held at Bilaspur, to share a few words with the audience. Ma'am, please.
A very warm good morning to the august gathering present here. So, with the approval from the executive committee, we gladly accept to host the 36th annual conference of the Indian Association for Angiosperm Taxonomy at Guru Ghasidas Vishwavidyalaya, a central university located in Bilaspur, Chhattisgarh. I am delighted and I take this opportunity to extend a respectful invitation to all the dignitaries, to the stalwarts who are present here, to the academic gathering present here, to my friends, my seniors and juniors. You all are invited to Guru Ghasidas Vishwavidyalaya to make this event a huge success. I already know that the bar has been set, so I've requested the organizing secretary, Dr. Manudev, to book his tickets 10 days prior to the next conference to maintain the bar. Thank you so much. Thank you.
Thank you, ma'am. We have few announcements. The t-shirts are open for sale and those who wish to purchase them can directly come to the registration desk, pay and collect them on a first come, first served basis. Those who are yet to submit their presentations are requested to contact the audiovisual desk immediately as the parallel sessions will commence soon. I repeat, those who are yet to submit their presentations are requested to contact the audiovisual desk immediately as the parallel sessions will commence soon. I'm also informing the dignitaries who are chairing other technical sessions are requested to report at their respective venues. Thank you. We now move on to technical session 11, which will focus on theme 3, floristic diversity and biogeography. This session begins with our invited lecture. Let us welcome Dr. G. Gnanasekaran, who will share an insightful historical perspective on the flora of Madras in the late 17th and 18th centuries. Following this, we will hear from our presenters in the theme 3 oral presentations. Now I invite Dr. Matthew Dan, retired Senior Principal Scientist, Jawaharlal Nehru Tropical Botanic Garden and Research Institute, Dr. S.S. Hamid, Scientist E, Acharya Jagadish Chandra Bose Indian Botanical Garden, Botanical Survey of India, Howrah, and Dr. Sandeep Kisan Gavade, Assistant Professor, Department of Botany, Sri Swami Vivekanand Shikshan Shanta Tataji Rao Kadam Arts, Science and Commerce College, Maharashtra, to preside over this session.
Good morning, everyone. So now we are moving to the concluding day of the very elaborate and prestigious 35th Annual Conference of IAT. And in this session, the special invited lecture will be given by Dr. G. Gnanasekaran. As you know, an emerging scientist and taxonomist of India, Gnanasekaran has already established his field. It's my pleasure to introduce Dr. Gnanasekaran. As a plant taxonomist specializing in systematics, phylogeny, and biogeography of Acanthaceae, he is well known, and he earned his PhD from the BSI Bharathiar University in 2015 and currently serves as Senior Assistant Professor in Madras Christian College, Chennai. He attained several honors and awards, INSA Medal for Young Scientists in 2019, Yusuf Hamid International Exchange Award, Royal Society London in 2023, and in 2025, he was elected as Fellow of Linnean Society of London. Dr. Gnanasekharan has published extensively over 50 research papers in Scopus and Web of Science indexed high-quality journals, and he contributed to the Flora of India volumes and described several new species and nomenclatural combinations in Acanthaceae. He has several ongoing projects, especially by SERB and Royal Society London, and explore various taxonomy and evolutionary history of Lepidognathus and the historical flora of Madras. He is also serving as the Executive Council member of IIT, and with these words, I am so happy to invite Dr. Gnanasekharan to deliver his invited talk.
Thank you, sir, for your kind introduction. Good morning, everyone present here. Before I begin my talk, I would like to thank the organizing secretary, Dr. Manudev, of the 35th IAAT Annual Conference, and the Executive Council of the IAAT for providing this opportunity for me to be here today and talk on the flora of Madras in the late 17th and early 18th centuries. This research is funded by the Royal Society of London under the scheme Yusuf Hamid International Exchange Award. And I'm going to talk the entire this presentation primarily based on the collections or the plant specimens that were collected from Madras, primarily by the surgeons who worked for the English East India Company. And all those specimens are presently deposited at the Natural History Museum, London, as well as the University of Oxford Herbarium. So this talk is going to be primarily based on those historical collections which are located at the Natural History Museum as well as the University of Oxford. And on the other hand, these collections are very significant primarily because I'm going to talk on the time and the period when Van Reed was busy in documenting the plants of the Malabar in this particular region. And we are also going to talk about the different contributors and the makers of these collections and the primary major outcomes of this particular ongoing research project, which is not yet finalized, but then, yeah, we are continue to work on this particular research. And the collaborators of this particular research projects are Dr. Rani Om Prakash, Senior Curator, Flowering Plants of the Natural History Museum, London, Dr. Mark A. Karain, Principal Curator of Algae, Fungi and Plants, Natural History Museum, London, and Professor Stephen Harris from the University of Oxford. So 3 different institutions are involved in this particular research. One is the Natural History Museum, London, the Madras Christian College, which I represent, and the University of Oxford. The major focus, or before we commenced this particular research, we set some of our goals and the plans and the research questions for this particular research. And I would like to really highlight some of those plans as well as the research questions that made us to apply for a grant and to study on this particular area of research or the collections. Principally locating those historical collections that were collected from Madras by the employees of the English East India Company or the merchants who worked during that particular time from Madras, from the collections that are deposited or that are housed at the Sloane's Herbarium. And the Natural History Museum, there is an exclusive herbarium, we call it as a Sloane's Herbarium, which encompasses the historical specimens, and they're all pre-Linnean. So that's something is very important and significant. And I'm going to talk on what exactly those pre-Linnean collections provides an insightful informations for our understanding on the flora of the time, pre-Linnaean. So we compiled the different folios in which the collections from Madras which are founded in the historical collections, primarily based on the Sloane's, from the Sloane Herbarium, based on the publications by Dandy, who was the director of the Natural History Museum during 1958, around that time. So he published a book on the catalogs of the historical collections that are found at the Sloane Herbarium. So use that particular book as a reference and try to pull out the historical specimens or the specimens that have been or that were collected from Madras. And secondly, we continue to digitize all those collections. I mean the collections from the Madras, and primarily to transcribe the informations which are associated or accompanying those specimens on the herbarium sheet, as well as to use those collections for identifying. So during my first visit in 2024, primarily I was involved in digitizing those collections, nearly over 3,400 specimens from the Sloane Herbarium. Those digital images and the transcribed label informations were ingested into the NHM portal, therefore making it available for public. So this particular part of the area of, this particular research, this particular objective is not yet been undertaken, but then I think the digitizing the specimens is over, and we have also, I think, in the process of transcribing the informations which are accompanying with those specimens. And followed by, we use those specimens primarily to fix the identifications of the plants, and while fixing the identifications, we have used the floras that were published from Madras, primarily the Mayurnathan, which is one of the exclusive publication that was published for the flora of Madras and its immediate neighborhood. And then Edward Bonds, who worked as a professor of chemistry at Madras Christian College, but then his contributions to the botany was tremendous. And he had described nearly about 16 different new species to science. And he was a professor of chemistry. And Dr. Livingston and Henry revised the flora of Madras and its immediate neighborhood of the Mayurnathan in the year 1994, basically based on the collections that are available at the Botanical Survey of India, and then I think based also on the earlier literatures. Why? I think to bring out a kind of an annotated checklist of the flora of Madras during late 17th and early 18th century. So this was our objective, and to bring out that particular annotated checklist, we've used these collections as a base and to build a kind of an annotated checklist. In fact, it's a kind of the data which we try to reconstruct the flora of Madras during the late 17th and then the early 18th centuries. So this is another very important objectives of the research. And to complement those historical collections and the specimens, we try to carry out the field trips. And one of my students, Patricia, was sitting here in the hall. She's involved in this particular research project with me to identify and then to complement all those historical collections with the live photographs and then the present collection. So these are, the other objectives of this particular research. And more importantly, the research questions are, like, we try to do a kind of a diachronic analysis, like comparing the past with the present and the present data. The present flora of Madras, the present flora of Chennai is compared with the informations or with the annotated checklist that we have prepared based on the collections that are housed at Natural History Museum and Oxford to understand what are the floristic changes that has taken place over the time, nearly 3 centuries. I think I'm talking about the time of 1690 and 1710, which is pre-Linnaean time. So we try to compare the flora of Madras of that time, 300 years old flora, with the present and the modern flora. And the second very important, the research question was to compare the local names that was associated or used during 300 years before or during that centuries, or how many of them are remain same today and how many of them have gone extinct. And I think these are some of the real focus and the comparative account that we try to do in this particular project. So these were our research real questions. And also we hypothesized that the names of the species that had use values I mean, for example, a plant that was used as a food or used as a medicine. So the plant species that had use values during the late 17th and early 18th centuries and that remain in use today will probably show a greater consistency in terms of their local names primarily, because the plants was used then and also now, so the informations were transferred from generations of people and it is continued. So this is a kind of an hypothesis, and I think we are, in fact, I think looking at the data that what we have accumulated or what we have generated from those specimens exactly complements with this particular hypothesis. And the last part of this particular research is to really bring out who were the contributors or who were the collectors. And I'm going to show some data on the contributors and the collectors, and we have differentiated under these two different umbrella major terms, one group of sets of people as the contributors who have collected them and who were employed by some of the eminent botanists who were sitting at UK or Europe, primarily UK. So they have employed them, they have given very enough instructions to them how to make the collections and what to collect and how to send and preserve. These people have collected them and then sent all those collections to those big taxonomists, probably the botanist or the naturalist. And I'm going to talk on few aspects of the contributors and the makers of the early herbaria of Madras. And remember, I'm talking about the collections that was made prior to the Linnaean. During that time, there were no concept of binomial nomenclature. I mean, they were not practiced. And all those specimens, I could see a lot of polynomials. So all those probably I think I'm going to show through some of the photographs in the coming slides. So I commenced my research. I visited twice, UK, London, and I spent over 80 days. And during my first visit, I spent most of my time in documenting the collections by digitizing them or by transcribing the data. And then during my second visit, wherever it is really required, I've studied the specimens and examined the specimens and tried to fix the identifications of the plants. And this is the room where all those historical collections are deposited or preserved, and they call it as Sloan Herbarium or Historical Collections Room. And this has nearly more than 120,000 specimens, and those specimens are kept in a leather-bounded volumes, like 265 leather-bounded volumes. And that is very challenging because I think in the previous talk, today we use the herbarium sheets as a loose sheets, as a single sheets. But look at those specimens which were like, mounted like a kind of a book, bounded books. So digitizing them was one of the very challenging problem, but it was a very challenging task. So therefore, we had to use the camera and set the things. I think some of the photographs which what the previous speakers were showing, exactly a similar sort of the setup that we have prepared, and then we digitized all those collections. And in addition to those historical collections and the specimens, the Sloan Herbarium also has about over 8,000 vegetable substances, which includes the seeds, fruits, and then the small piece of barks, and maybe some leaves. Primarily the materials which were used as a medicine with respect to the materia medica. So all those collections are ousted, and I think recently there was a publication by Scott et al. Describing the informations about the places and the collectors and what is exactly available in this historical collection room have been published. And Pickering et al. Again published a detailed account on the vegetable substances that are found or that are stored in this historical collections rooms. So similar to it, I spent some days also in University of Oxford Herbarium, and where I had the opportunity to meet a stalwart who contributed a lot for the family Acanthaceae, and I've set my mind to contribute and do some good work for the family Acanthaceae of the country. I still remember when I met Dr. Sanjappa sir when I was a botanical assistant at Coimbatore, and then he was the director of BSI. Probably I think he retired. And when I met him, he asked me, he told me one thing very clear, that take up some groups and a particular family, focus on the family, and try to do your work and contribute a kind of a lifetime, contributions. So as part of my PhD, I worked on the genus Andrographis, and now that we have worked on the genus Lepidognathus of India, which was funded by the SERB. So studied the collections at Oxford, primarily the herbariums of William Sherard, and then the Charles Dubois, who was a treasurer of the English East India Company, so he had all the power to pull the specimens from Chennai, and then he maintained his own herbarium. And all those herbariums were later on donated and then handed over to the University of Oxford. And nearly about 3,000 collections of the plants that were collected from Madras are found at Oxford University Herbarium. So that was a wonderful opportunity for me to explore and then to study the details of, for this particular research project. The first outcome of this particular research was to bring out who were the contributors or the collectors and the makers. So let me just quickly move on with some of the key findings. So we estimated nearly over 10,000 herbarium specimens from throughout India, though we started to work only for Madras, but then I think our interest made us probably to, extend our study to document and then to digitize the historical specimens that have come from India. So we estimated nearly about 10,000 collections, and majority of those collections are of course found are located or housed at Natural History Museum and then the University of Oxford. And most of these collections, this is something is very unique and surprising to know that those collections, the majority of those collections from those 10,000s fall exactly in these 2 decades, from 1690 to 1710. So that was the time when there was a rigorous plant collectors, or the instruction probably were given, and there were a majority of those collections have come from or representing these 2 decades. And after 1710, probably the number of collections which are available was very, very less, and we couldn't see any specimens after 1724 from Madras. Of course, after Linnaean time, and then after a kind of a research that people have taken up to do for the taxonomy, collected and sent the collections to Kew and all, that's all different story. So what I'm talking about here is the pre-Linnaean specimens collections. So we finally identified about 26 different individuals who were responsible, 26 different collectors who made the collections of those plants from Chennai, from erstwhile Madras, and sent those collections to the sent those collections to the English East India Company, and later on that was moved to the Royal Society, and then finally landed up at British Museum. So this is how the collections were moved from one place to another. And 2 different makers, or 2 different these stalwarts who were maintaining their own collections, wherein you see the collections of the Madras. So we call them as makers. So I think we have defined the definition for who are the contributors and the makers. Probably I think that's going to be on the next slide. So Europeans, one of the very important observations that what we have made during the study is that these Europeans had to definitely negotiate with the local people to collect the ethnic informations, to collect the local use informations, and to collect the local names of the plants. And there were, which means the data that what is available for us today to study in terms of those historical collections is a co-created knowledge by both Europeans with the local people. One of the challenging part when it comes to the identifications or fixing up the specimen, whether the specimen has really been collected from Madras, was because there were lack of provenance details. There were no informations about that they have collected from, let's say, Nungambakkam in Madras, or let's say, some locations in Madras. What it all says is that those specimens were sent from St. George Fort, except probably the Samuel Brown collections, which I'm going to exclusively talk on a bit later with a few slides. And these herbariums are pre-Linnaean, which I have been using this term because those collections were collected and assembled and named before the binomial systems of nomenclature were so widely accepted. Therefore, the polynomials, it was a time when people were busy in probably talking the names with the polynomials. So that's the time. And the definitions which we have arrived at for contributors are the individuals who contributed the specimens, or individuals who have collected the specimens from India and sent to the East India Company. Similarly, the makers, the individuals who incorporated those collections into their herbarium. So James Petiver, Plicknett, Hans Sloane, they were all the people who are maintaining their collections. Already, they had their own herbariums, their own personal herbariums. And into those collections, they have also incorporated these collections into their herbarium. So therefore, from each of those 12 makers' herbariums, we could find out the collections of the Madras sent by those 26 contributors. And those contributors are primarily Samuel Brown, he was a surgeon, Edward Bulkeley, who succeeded him as a surgeon for the English East India Company at Madras, and Daniel Dubois, who was a brother of Charles Dubois, and Mary Dubois, who was a wife of Daniel Dubois. So I think these were the people who have been involved. And I think Mary, and we found of the 26 contributors, 2 women contributions. So probably the very early women contributors, the plant collectors from India, I think one is Mary Dubois. From where those collections have come, those estimated 10,000 collections. So these are the different locations, the points, East Coast and West Coast. I think you see a lot of collections, and with at least with the specimens where we could see the collection locality details precisely. There are specimens wherein they mention simply Bengal, and simply, for example, Surat, Karwar, or Madras. So there are some collections wherein you see exactly the locality details, the name of the broader geographical locations probably. So we have just pulled out those informations and tried to, georeference and then to show you from where those collections have come. And purposely we avoided to incorporate the boundaries, the political boundary of the country, because the then Bengal included the Dhaka and Bangladesh and many different regions. So therefore, purposely we have avoided to, while making the map, we discussed, and then we try to avoid it to represent the collections of late 17th and early centuries times map. Probably this is the map that is for those collections and not for the present time. So the other important, the other map which I have actually showed here are the different collection localities where the Samuel Brown, who collected the specimens, he was so meticulous, and he has made the collections, he made nearly about 316 collections, plants from these different localities. He was a surgeon at the Madras St. George Fort, and collected 316 specimens with lots of information, with the precision data of the ethnobotanical data, and with the precise locality data from where he has collected. And those collections were made in 1696, with the precise locality details, like what you see in the modern day specimen, along with the ethnic informations. And he had sent all those collections to English East India Company, and James Petiver, who was an apothecary, who was working, a famous botanist, worked on and then, identified all those specimens, and they jointly published series of publications in the official journal of the Royal Society, the Philosophical Transactions. And recently, Dr. Ronnie Om Prakash, a senior curator of the Natural History Museum, worked on all those specimens and fixed the modern day identifications, and then connected all the vernacular details and collected all the ethnic use values with those species. And they have published it with the title Samuel Brown's Late 17th Century Indian Herbarium, Identifications and Early Modern Taxonomic Practices. So I just would like to differentiate, I think let me take another 5 minutes probably. Yeah. So quickly I would like to show the real differences between the historical collection and then the modern collections. I think in the modern collection, today if you make a collection, you collect a plant of a particular species and mount them with the details on the herbarium labels. But look at on the other side, a sheet that carries more than 10 species, 10 different species, without any local informations, without any details of the locality, without any, much of the informations. And it's all, and today if you call, if you evaluate the specimens, you will call it as a mixture of specimens have been mounted in a single specimen or on a single sheet. So it's very, on the other hand, because there was no data on the botanical informations, because there was no data on the localities, identifications of these things were really literally challenging part. So what exactly then you see in those historical collections? botanical informations like the polynomials, brief descriptions, reference to an earlier literatures, sometimes the character details, sometimes the locality details. And the secondly, vernacular names in most cases, or in at least some cases, you see the local names. Here I can see the word Tamil name Nannari, N-A-N-A-R-Y, Nannari, it is just written, transcribed. And similarly, you can see, the vernacular names. Either it is scripted or in a Tamil or probably in a Telugu language. Definitely it's a co-created knowledge with the help of the local people. And other very important informations that you see on these historical collections are the use values, which were written either handwritten or probably printed labels. So what exactly we have done, we just created a master list for the present day flora of Chennai, and we try to use this particular master list along with the other floras and then the revisionary things and try to identify and fix the plants of the historical collections, and also complement those historical collections with the live photographs and the live specimens. Principally, we moved to the collection localities where Samuel Brown traveled and other adjacent localities probably in Chennai, and tried to complement those historical specimens with the live materials. I just would like to take up only one case study here to probably explain how difficult, sometimes challenging it was for us to identify the plants. The Stequilla species will have a palmately compound leaf, but on the historical specimens, you see a single leaflet along with the inflorescence that was mounted. So the moment when I looked at that single leaflet, I just felt that I've seen it, but then what is it, Then slowly, I try to look at the specimens in detail and then look at the flowers, and finally we could fix its identity as Stequilla foetida. So these are some of the real challenges that, we have come across while fixing the identifications of the plants. The third outcome of the research project was the documenting the vernacular names, so for which we have created a database on the vernacular names that were documented in the recent times. Why? To compare the data with the information that is available in the historical specimens, and those Tamil names were either scripted on a palm leaf in a Tamil script or probably a Telugu script, and those informations primarily were used to understand how many of those names are even conserved today. For example, Nannari is a good example. It was 300 years before they have written the name Nannari for Hemidesmus indicus, and even today we call it as Nannari. So that name was conserved over 300 years. But there are a lot of, and another classical example for extinction of a local name, for example, Eriocolon quinquingulare, for which they have used the local name called Muttai Korai. Muttai means egg, and Korai represents the cypresses. So the head and the local name, vernacular name, what was named for Eriocolon was Muttai Korai, and in none of the today's modern floras, you don't see the name Muttai Korai, so which means the name is lost. So this is the final outcome. Probably I think we are trying to work towards that, to bring out a kind of a species specific or at least generic specific, genus specific kind of a data, wherein the historical informations and then the modern day and the data and everything. So these are some of the extension activities as part of the research that we have done, which I'm not probably, I think, going to talk about it. And we had an exhibition at Madras Christian College where Dr. Mark and Dr. Rani visited, nearly about 200 over plus specimens of the historical species representations displayed for the public. And when I was at UK, we had a kind of a tour for the project, and we have briefly explained on what exactly that we do as part of this particular research. Thank you.
We were listening a wonderful lecture on a glimpse of a 2-century history of Madras flora by Dr. Gnanasekharan. I am handing over the mic to my co-chair, Dr. Hamid, for extending vote of thanks.
A very good morning to all, including the Director Botanical Survey of India, ECD. Gnanasekharan was our scholar at the Southern Regional Center, Coimbatore, and he worked as a botanical assistant. And he has wonderfully illustrated, he has given a wonderful lecture on the Madras for the earlier Madras flora. And we don't have much time because we have a lot of around 25 presentations further, we don't have much time. Of course, if anybody is having a few questions can ask and finish off here this. No question, no. Okay. Then thank you.
Thank you. Yeah.
So now we have to move on to the technical sessions on floristic diversity and biogeography. As indicated, there were 25 oral presentations, and there will be no tea break, and those who are in need of tea, they themselves can move on for a cup of tea, and please return back to the auditorium. As the organizers indicate, a couple of announcements will be there.
Yes, sir. We will now begin the exciting oral presentations for Theme 3, Floristic Diversity and Biogeography. I request the first presenter, Eliama Jomi, to please approach the mic point for check-in. And a note to all subsequent presenters, to maintain our schedule, please ensure that the next presenter in the sequence is seated in the front rows. You are to approach the mic point and ready to check in as the current presentation is concluding. This will allow us to transition efficiently without delay. I repeat, a note to all subsequent presenters, to maintain our schedule, please ensure that the next presenter in the sequence is seated in the front rows. You are to approach the mic point and ready to check in as the current presentation is concluding. This will allow us to transition efficiently without delay. Our deepest thanks to Dr. G. Gnanasekaran for that truly enlightening invited lecture. Your detailed exploration of the flora of Madras from the 17th and 18th centuries offered an invaluable historical context to our understanding of floristic diversity. Thank you, sir. Now I invite Dr. Father Biju Joseph, Principal, St. Joseph College, Devagiri, to felicitate Dr. G. Gnanasekaran. Sir, please.
Starting sir 8-minute presentation, 2-minute discussion. Announce
We will now begin the oral presentations for Theme 3, Floristic Diversity and Biogeography.
Once again, welcome you all. Now we are moving to a series of presentations. There will be 22 presentations, so we have to stick on to the time. Kind attention to all the persons who are presenting. Please stick on to the time, 5 minutes maximum. So the first presenter is Eliama Jomi. Please.
Very good morning to everyone. Myself, Eliama Jomi. I'm a research scholar of NIPST, which is in Mahatma Gandhi University, Kottayam, which is in Kerala. So, the topic I'm going to discuss today is about grasses of Mangaladevi Hills, which is in Western Ghats. The grasslands of Kerala can be classified as high altitude grasslands and the low level grasslands based on the altitude. And as the Mangaladevi Hills, it is a high altitude grasslands which is situated in Periyar Tiger Reserve, which is in Idukki district of Kerala. And the altitude is, as per it is the high altitude grassland, it is having an altitude of 1,337 meters above sea level. And as you can see in this map, we can see that the Mangaladevi Hills boundaries with both Tamil Nadu and the Kerala, as it touches both Idukki district of Kerala and the Theni district of Tamil Nadu. You can also see that the hill is exactly located as Sri Mangaladevi Kannagi temple because of the presence of this temple which is on the top of this mountain, by which it is known. And in every year in the Chitra Paurnami festival there is a celebration which is done on the hills. And as you can see, the hill is almost more of the grasslands. And as the vegetation of the area, we can see that the 95% of this Mangaladevi Hill is about the grasslands, and there is also evergreen forests which is on the isolated patches, which is appeared as isolated patches. And also, as for the shortage of time, let's get into the result of this topic. It is said that the grass diversity, we have collected about 152 grass species and identified, and out of which 20 of them were endemic species. So which are the endemic species that is present in this grasslands? Which are, first one is Arundinella ciliata, which is endemic to peninsular India. The second one is Arundinella mesophila, which is endemic to South India. And the third one identified was Arundinella purpurea, which is also endemic to South India. And two species of Chrysopogon were also identified from this area. The first one is Chrysopogon asper, which is endemic to peninsular India. The second one is Chrysopogon Hekele, which is also endemic to peninsular India. Both of them were associated with the Temera species, but they are not found as endemic, which was collected from that particular Mangaladevi Hills. The next one is Chrysopogon travancorensis, which is also endemic to the southwestern Ghats, which is exclusively endemic to Tamil Nadu and Kerala. The next one is Dicanthium folcaceae. Two species of Dicanthium were found from this area, which is, first one is endemic to the southern western Ghats, and the second one is Dicanthium oliganthum, which is also endemic to southern western Ghats. Dicanthium is exclusively seen in the moist rocky areas in the grasslands. The next one is Dimeria decanensis. Three species of Dimeria were identified from the place. The first one is endemic to southern western Ghats, and it is exclusively seen on the rocky grasslands. The second one is Dimeria lovesoni, which is endemic to South India. And the third Dimeria species is Dimeria moonei, which is also endemic to southern western Ghats. Next is Garnosia arundinacea, which is found in the forest margins and it is endemic to southern western Ghats. Then Garnosia elata, which is exclusively seen on the rocky cuttings in the grasslands, and they are endemic to peninsular India. The next one is Glyphoclova forticulata, which is also endemic to peninsular India, and it is distributed among the rocky grasslands of Mangaladevi Hills. Then Isagne berniorum, two species of Isagne were found endemic from the area, and the first one is endemic to southern Western Ghats, and the second one is Isagne setosa, which is endemic to Western Ghats. Next is Ischimum neelagiricum. Last but not least, it is also found in the Shola grasslands, which is on the way to the grasslands, and it is endemic to southern Western Ghats. As we can see that the south grasslands, the southern grasslands of India, is found that it is not only presented by the grasses alone, but it is also presented with the other dicots and orchids like Anaphalis, Habenaria essecum, Ereucolon, Justicia vernonia, and the Bloomei. So they are, first one is Anectochilus elatus, which is an orchidaceous species and it is found there. Next is Arundina graminifolia, which is also found there. Then Brachycorthis ayantha, which is geographically distributed in the place which was not endemic, but it is also seen there. Then Xylogyne mosaic was found. Then Habenaria periarensis was found, and also this is a recently discovered species. Next is Habenaria longicorniculata, which is endemic to Western Ghats, Habenaria perioditiana, which is endemic to South India, Impatiens capiflora, which is endemic to Western Ghats, Impatiens viscosa, which is endemic to southern Western Ghats, and it is found in the margins of Shola forest and grasslands. Then Anaphalis travancoricum, which is a herb found. Then the Begonia malabarica, which is not endemic, but it is profoundly found in the place. Next, Sonorella rotundifolia, which is herb and it is endemic to the southern Western Ghats. Last but not least, the Strobilanthes kundiana is also found in the place which is endemic to southern Western Ghats. These are the herbs and the dicots which can be seen along with the grasses in the place. As we can see that the grasses in the southwestern Ghats or the southern grasslands cannot be found alone, and always it is found in, with the presence of orchids and herbs. We can see that the grasslands are the integral part of our ecosystem because it provides many ecosystem services to the place, to our place, because it becomes a habitat to many herbivorous plants because it provides the grasses and also herbs which are endemic to the place, which are palatable to many endemic animals also habituating in the place. And this herbivorous animals also maintains all the carnivorous animals which are dependent on them. So that we can say that it contributes the forage value of an ecosystem rich with wildlife. Also, from my concept, it says that we have 44 rivers in Kerala, and most of the rivers are originated from the mountains. As from Pala, we have Meenachal River, which is originated from the Vagaman grasslands. And also we have seen that the presence of non-grassy herbs, which shows high biodiversity potential because most of them were endemic and some of them also were threatened species. And 1/3 of the herbs in all the protected areas are from the grasslands. And the threat to grassland is that if we have the habitat destruction and deforestation, which reduces the grassland areas. And also another thing is that the major part of grasslands are already gone for plantations and other non-forestry development, which can also say as a threat to the grasslands. Thank you for your patience. Thank you very much.
Thank you, Eliema,
Thank you,
for
sir.
the presentation. Now I am moving to my co-chair.
It was a very wonderful presentation
My
with
pleasure,
attractive
sir.
slides. But one point is that you mentioned the grasses title.
Yes.
Why don't you stick on that? Because you are showing other things also. Is much reflected, you know that.
Are you referring to the herbs, sir?
But then title would have been like that. You know, only grasses, then explaining everything. In future, you please take care of that.
Okay.
That is the only one. Thank
Okay.
you. Thank you.
Okay, I will let you.
Nice presentation.
Thank you,
I
sir.
have a very simple question. From where, by using what literature you have identified these grasses?
I have used flora of Kerala grasses from Srigumar and the flora of Tamil Nadu from Altaf and Nair flora of grasses. Then I have also used Botanical Survey of India's Flora of India, volume 31 and 32.
Okay. Any questions?
You have done very good presentation, but as Dr. Hamid told, some of the identity, particularly the dicot plants, you have to counter check. For us, you told about anabolis, but it may be Nephalium. Like that is in your photograph, but please counter check. Otherwise, your presentation is very wonderful. Keep it up.
Okay, thank you, sir.
Hope no more questions. And now we are moving to the next presentation, an overview of sedges of Konkan region of Maharashtra state by Chandur A.N.
Good morning to all. My presentation topic is an overview of sages of Konkan region of Maharashtra. My study area is Konkan region of Maharashtra, which includes 7 districts, that is Sindhudurg, Ratnagiri, Raigad, Palghar, Thane, Mumbai and Mumbai suburban. This is habitat of sages. Members of family Cyperaceae are mostly growing in aquatic to marshy habitat, where they are the major component of estuaries, waste places, and seasonal water bodies. Some of the members grow in steep rock, crevices, grassland, paddy field, dry and gravelly soil. This is on plateau, this is on estuary, and here Ghat region. Cyperaceae is a cosmopolitan and 7th largest family in Angiosperm and 3rd largest family in monocot after Orchidaceae and Poaceae. The species of this family are distributed widely in marshy places, pond and wetland. The family has 2 subfamilies, about 95 genera and 5,687 species reported around the world. In India, the family is represented 32 genera and 610 species according to APG4 classification. In Maharashtra, the family represents 15 genera and 214 species. During floristic survey of Konkan region of Maharashtra, family Cyperaceae represent 15 genera and 91 taxa are reported in present work based on actual field work and herbarium consultation. In Cyperaceae, generally found in marshy habitat due to non-attractive, minute and small flower. That's why researchers neglected by this family. The present study includes detailed morphological account of sages of Konkan region with special emphasis on nutlet characters. Here, these are the characters of family Cyperaceae. Nutlet and surface of nutlets are special importance in taxonomy of sages. Here, the example of genus Eleucharis. You see here the surface of nutlet, then bristles of nutlet. With the help of these ACMs, we can identify each and every species of sages. First tribe Abilgardi, which includes 10 genera in world and in India found 4 genera. Out of that, Bulbostylis, Abilgardia and Fimbristylis found in study area. This Abilgardia with 10 species, 2 species found in India and Abilgardia ovata found in study area, we can easily identify by its lower most involucral bracts gum-like, not always trigonous stipitate, gloom arrangedly disticus. Then second, bulbostylis. Here in India, 7 species and 2 species are reported from study area. We can easily identify bulbostylis by its nutlet with button-like thickening of style base and leaf-shaped apex with long white hairs. You see here the structure. Then third genus, Pimbristylis. Here in India, 128 species, and out of that, 25 species we have collected from study area. We can easily identify by Pimbristylis by its lowermost involucral bract. This is a Pimbristylis habitat and nut photograph. Then Scoinoplecty. Here again 2 genera, Actinoscirpus and Scoinoplectus. Here Actinoscirpus, in study area only 1 species, and total world only 2 taxa. This is a beautiful, earlier it was in Scirpus, now it is Actinoscirpus grossus, variety Kaisur, we collected from Raigad area of Palibag. Then this is a Scoinoplectus, only 1 species collected, that is Scoinoplectus subulatus. Then this is Diplacrum. We have collected 2 species of Diplacrum, that is Diplacrum caricinum and Diplacrum poculi. Then here Bulboscoinus, here 2 species of Bulboscoinus taxa collected, that is Bulboscoinus maritimus subspecies maritimus and Bulboscoinus maritimus subspecies affinis. Here this is the photoplates of Bulboscoinus which collected from study area. Then another this Cyperi, tribe Cyperaceae, here 4 genera is there and only Cyperus is found in study area. These all genera are merged into Cyperaceae recent, according to recent classification. Here 27 taxa of Cyperaceae we collected from study area. This is the photographs of species of Cyperaceae. Here this these are Cyperaceae. Here Cyperus species which recently collected, and it does not match with any known species, and probably it may be the novelty. Here you see this allied species and this recently collected from study area species. Then Purina. Here this is the diversity of Purina. 3 species collected from study area. Then Scoinopectalia, 7 species is collected from Scoino. Here we see the nut. With the help of nut, we can easily identify each and every species of genus Scoinopectalia. Then this is the Scleria. We have collected 5 species of Scleria. Then Eleucharis. Here this is a new record for India. Then recently 2 species new to science collected from study area. This another 2 taxa which work is in progress, and it may be the taxa, new taxa. Here you see this Carici, and here only the species Carex. Rhynchospora, 2 species of Rhynchospora collected, and during study area we have collected 16 endemic species. Here this is my conclusion which already discussed in presentation. Thank you. I am very much thankful to my guru, Professor S.R. Yadav. He created interest in Cyperaceae to me. Thank you, everyone.
Okay, Chandur, thank you for a very nice presentation with excellent photographs and good number of endemics you have mentioned. And now it's open for discussion.
It's a wonderful presentation, especially Yadavs have probably guided you nicely, very nicely. It's such a wonderful photograph. Actually, the Actinoscirpus, how many species are there that area, the study area?
Only 1 species.
Why it is strictly endemic over there? Strictly endemic over there?
No, it is not endemic. This Kaisori is found in Asian region, and this Actinoscirpus grossus, it is throughout in here.
So you find only 1?
Here, 1 variety.
Okay.
Very nice presentation, sir.
Okay, thank you.
Any questions from the audience? Please make it faster.
You mentioned about the term nutlets, right? In literature, there three terms are used in several by different authors. That is akin, nuts, and nutlets for these fruit or seed of cyperaceae. So, what's the difference between this akin, nut, and nutlets?
Actually, previously nut is used, then akin some last 10 years back, we searched different literature, akin term is used, and recently, as per EPG classification, we use nutlet term, and I think nutlet is the correct term in present classification.
Why the term nutlet is correct? That's my question. Why it's not an akin and it's a nutlet? That's my question.
Akin generally we use in this.
So could you make that clarification during the lunch time, please? Because we are in shortage of time. So now we have to move on to the next presentation. New recorded and discovered Angiosperm taxa in the present century from Rajasthan. A review. Parath.
Good morning to all of you. My presentation is a review. I have tried to compile all the work done in Rajasthan in reporting new taxa distributionally and new taxa discovered in 25 years of the 21st century. Rajasthan is located in northwestern part of country, and nearly 100% of the state falls in arid and semi-arid zone, with a small tract of Bharatpur and Dholpur districts which fall under Gangetic plains. Aravallian ranges intersect the state into two unequal parts. Many microhabitats like perennial and seasonal rivers, hill stations, sand dunes, wetlands, and other are also confined to the state. Actually, Rajasthan is quite rich in biodiversity because of its variable climatic and geographical conditions. Around 2,000 flowering plants are there. South and southeast Rajasthan has less desert effect, more water bodies, which favor rich floral components. Forests of South Rajasthan, especially Mount Abu, which falls in, which is located in southwest, and other protected areas like Phulwari Kinal, Phulwari Wildlife Sanctuary, Sita Mata Wildlife Sanctuaries, Kumbhalgarh Wildlife Sanctuaries, they are rich in floral components with orchids, a number of terrestrial orchids, with the tuberous plants, lianas, etc. So I collected information from all sources as I could. Methodology from all sources. Result and discussions में 92 angiospermic species and infraspecies which are newly recorded distributionally or discovered from Rajasthan in the first quarter of the century from 2001 to 2025. And these taxa represent a wide range of life forms in 82 genera belonging to 53 families. These are the species. Chronologically, I mentioned here from 2001, Nervilia aragona, a terrestrial orchid, Butea monosperma, variety lutea, with cream flower. It has a small distributional range, so it is at the threat at the verge of extinction because of its restricted distribution and small population. Commiphora gileadens, no record previously. Then Habenaria longicorniculata, from South Rajasthan, Physalis maxima. Now it is a variety. Now it is a variety of Physalis pruinosa, variety pruinosa. Then Nymphia rubra. It is found in Banswara district of South Rajasthan, mixed with Nymphia pubescens. It has red parts, red leaves, red petioles, red flower, and flower stalk. So it is a large. I'll then only for some important. Poa supina, Enteropogon, Senna uniflora, Tamarix specironoides, variety Macrocarpa. Now it is Tamarix Macrocarpa. Actually, Tamarix is represented by Tamarix ephyla there in Rajasthan. Then Morinda. Some others important are Electra chitricotensis, which is now Electra parasitica, subspecies chitricotensis, Paracia, Strelitzia. Then some other important are Premna resinosa, which was previously reported from Gujarat. Then Geodorum, Litsia, Maida lakdi. Borasus, Dioscorea, and Musa rosacea. Euphorbia jodhpurensis is a new taxa found from Jodhpur district. Then Caligonum, Solenum, and some other important are
okay, madam, make it fast.
Datura, Peristylus, Tribulus ocrin. Tribulus terrestris is common in desert habitat there. Then Opuntia cylindrica, Tithonia, Portulaca bharat is the new report, is the new discovery from Rajasthan. That's all. Alloy trinervis, Euphorbia jodhpurensis, Oropetium. These are the new taxa which have been reported from Rajasthan. This is a graph which show the records and discoveries from Rajasthan year-wise. Next, some changes which are in plant online. These are some status of species may be congruent with and conclusion. There is a remarkable angiosperm diversity in Rajasthan. New species and infraspecies discovered and recorded in the last 25 years reveals the rich and unexplored floristic potential of Rajasthan, the state. These findings serve as crucial baseline for future taxonomic studies. It is suggested, as our senior experts alert us for this, while recording new taxa, researchers should be careful about findings of modern taxonomy.
Okay, thank you, madam,
That's all.
for elaborate review on for 25 years on Rajasthan flora.
Nice presentation. Thank you so much.
Okay, thanks.
Any points to discuss? Okay, thank you, madam. So now we are moving to the Next presentation, morphological characterization and genetic diversity assessment of Abrus precatoris, accessions from Kerala, India by Hafia S.
A very warm good morning to one and all. Today I'm going to present a topic entitled on morphological characterization and genetic diversity assessment of Abrus precatoris, accessions from Kerala, India. Abrus precatoris is belong to the family Fabaceae. It is commonly known as Indian licorice, jagged bean, rosary pea, or crab eyes. In Malayalam vernacular, it is known as kunni. It is originated from Southeast Asia and is native to India. It is a woody twining flowering plant. It is used in Indian traditional system of medicine such as Ayurveda, Unani, Siddha, and also used in homeopathy. It is used to treat ailments such as hair loss, skin diseases, and neurological diseases. The leaves has been used against cough, and leaves and root of this plant is an ingredient of many hair oils. For example, Nilabringadi, and is have a neuromuscular effect, neuroprotective, abortifacient, anti-epileptic, anti-diabetic effect. And moving to the objectives, collection and identification of the genotype of Abrus precatoris occurring in Kerala, and assessment of intraspecific variability available in the gene pool of the species based on morphological characters. And come to the methodology, field survey to locate and collect the accessions of Abrus from various diverse ecogeographical regions of Kerala. And observation on habitat, associated flora and other aspects were gathered in the passport data sheet. Establishment of accessions in the field gene bank, conservation of the accessions, qualitative and quantitative study of the morphological characters of the 50 accessions. Detailed morphological characterization considering data on 15 characters comprising 25 qualitative and 33 quantitative characters were recorded and analyzed using Waltzman minimum variance hierarchical cluster analysis. The variability with respect to 25 qualitative characters are assessed based on the number of characters states. The similarity metrics were prepared by calculating programmed random occurrence distance between pairs of accessions, and a dendrogram was constructed illustrating the interrelationship between and among the accessions. Then come to the result. 50 accessions of Abrus precatoris were collected from various ecogeographical regions of Kerala, and its morphological characters were studied. From 58 morphological characters, 25 qualitative and 33 quantitative traits were analyzed. And these are some of the photographs of the different varieties of Abrus precatoris. These are the characters of 25 qualitative characters and character states. Qualitative characters reveal substantial variation in flower color, standard petal color, seed shape, and seed coat color, and highland color. Purple flower 84% and red seed coat 84% predominant among these accessions. These are the tables of measure of central tendency and dispersion of 33 qualitative characters of the 50 accessions. Qualitative traits demonstrate considerable diversity with the leaf area ranging from 77.66 to 360.33 centimeter, and seed number per fruit varying from 5.33 to 14 range. This is the dendrogram showing 8 clusters of accessions by hierarchical cluster analysis at a 30.5% of similarity level. This is the composition of the cluster of the 50 accession based on the hierarchical cluster analysis. And the result of the hierarchical clustering of the 50 accession is present in the dendrogram. Diverse clustering was constructed based on the record of the observations. This formed mainly two clusters, which are highlighted into two colors. Hierarchical cluster analysis at a 30.5% similarity level grouped the 50 accessions into 8 distinct clusters with a size ranging from 1 to 14 members. Clusters 2 is largest with 14 accessions, with a cluster 2 and 4, 3 and 4, each containing single accessions indicating unique morphological characters. And coming to the discussion, the present investigation employing Weissman minimum variance cluster analysis successfully reveals substantial morphological diversity among 50 accessions of Abras collected from different geographical regions of Kerala. And these are my conclusions. Thank you.
Okay, thank you, Hafia. Haifa. For the nice presentation on the diversity of genetic diversity of Abras. Any questions from the audience?
This kind of whatever you have studied is very well known. Not only in Kerala, you are talking about Kerala only.
Okay,
if you
sir.
take the whole country,
Okay, sir.
this diversity in color of the seed coat, flowers, even number of leaflets, and all these things very well known. I don't know what is your intention of studying this.
Sir,
Ultimately, what do you want to use this data for?
Sir, this is the only a part of my PhD work. I'm also done by work in phytochemistry, molecular level.
Even molecular, I think phytochemistry has been studied quite well. And I don't know whether you are not referred to this George Watt's records.
For conservation, for...
Not conservation, for the users and for the diversity that is shown in this particular species.
It's a high medicinal value, sir.
I know, we know, everybody knows about it. It's famously used as a jeweler's weight because of the constant weight of the seed.
Yeah. Weight.
No, what do you want to use this for? Your data, ultimately, what do you want to use for? Molecular study, yes. What for?
Any variation is there?
Variations are there, recorded,
okay.
well known. Even in Wealth of India, it has been recorded.
Yeah.
No, you should use this data and your research.
For further studies, sir, for further, I told that I'm going to, for further study in my molecular level too. For the...
No, what do you want to achieve? I want. Study is okay.
Yeah.
It is well known.
Yes, sir. The root of this plant have a glycyrrhizin, and based on that.
Fine. Okay. You should think of these things
Okay,
at least, because Indian licorice, it is used widely used leaves.
Leaves is used for making medicines such as hair oil.
More than the medicine in the daily use, do you know that?
Yes, sir. For in Kerala,
for chewing pan,
yeah, sir.
the leaves are put.
So in Kerala, we use post delivery treatment. We use a food like chini mav. We use the leaf to make chini mav.
Okay. Thank you, Happy. All the best. So now we are moving to the next presentation. Taxonomy study of the family Fabaceae from Vidarbha region of Maharashtra by Jagannath V.
Hello. Pointer? Okay, thank you. Very good afternoon, one and all. And the presentation on Fabaceae in front of a legend of India who work on Fabaceae, and for me, father of Fabaceae of India. It's very much dear. And sir, please bless me. Thank you very much. My purpose to present this work to document my native region, Vidarbha, for Fabaceae. So Vidarbha is very neglected region in Maharashtra state concerned with the taxonomy, because so many people gather here to discuss the taxonomy from their various regions, especially from Kerala, South, and the Kolhapur groups. Dr. Yadav sir, we meet so many times, so many peoples from Kerala. They know me, and I just try to represent my region Vidarbha for Fabaceae. So, taxonomic study of Vidarbha region regarding Fabaceae, I just document the data regarding how much species available in the Vidarbha region. This is what the introductory, and I am a teacher. So, the peoples who are working here, they are teachers, researchers, taxonomists, and scientists. We deal Fabaceae with the students previously, like the Sigil Pinnaceae, Mimosidae, and the Papilionidae. Now there is so many molecular work and sequencing, and nowadays there is these 6 subfamilies. So people or students, those who are dealing with the Fabaceae, they know all these things. It is a bigger family throughout the world, third largest family. Thank you very much, Sanjay sir. You have explored all the Indian Fabaceae members. Included genus in the subfamilies of Fabaceae. Likewise, Sigilpinidae extremely major in role to conclude the Fabaceae, approximately 163 genus. Then Cerosidae 14, Datoridae, then 56 Deltoidae, and Papilionidae, that is 524 genus. Total 795 genera. Overall world is still today have the record of Fabaceae. In India, it is represented by 174 genera with 1,110 species and 256 intraspecies taxa. That is the milestone work done by Sanjapa sir. About 83 genera, 3 to 6 species, 2 subspecies, 57 varieties, and 1 form of Fabaceae occurs in Maharashtra state. It is the statement in the BSI Flora. Again, that work included the Sanjapa sir work and so many new young research work, new additions, new reports, new documentation, all these. Working area where I work, this is Vidarbha, which include 11 districts. That is the complete scenario of Vidarbha. It is typical in climatic condition, topography. We feel huge temperature, approximately 48 degrees Celsius in summer season. In winter season, approximately less temperature, near about 8 to 7 degrees Celsius. Vidarbha is situated, everyone know almost. Major genus of Vidarbha, Alicicarpus, Acacia, Albizia, Cinnamon, Bahunia, Caxia, Sigilpinia, Crotalaria, and these are the dominating genera in Vidarbha region: Crotalaria, Indigofera, Alicicarpus, Desmodium. These are the genus which are dominantly found in our area, Vidarbha region. Tephrosia species, then next Butea species, Butea monosperma, then this one is the Butea monosperma variety Lutea, and one more species, that is Butea superba. Majorly occurs in the forest of our region. This species, this variety is very much rare and occasionally occurs in our area. Actinomone have the Americana, Asimon americana, then another one is Aspera indica. These are the species. Crotalaria, major genus of the Vidarbha region, approximately 28 species are recorded up to this work. 28 species I have collected, prepared the herbariums and deposited in my college department botany. Crotalaria species, the Clitoria species. Indigofera, 22 species have been recorded.
Please make it fast.
Okay.
Time is short.
These are the some species. Jacarandia mausae from Vidarbha region. Tree habitat Cassia pistula. Then Glycerdia sapium. Discoristis cinera. Then Perocarpus desmanthus species. Single one. Then the Vigna. Present study 64 genus, 234 species, 2 subspecies and 20 varieties of Fabaceae occurs in Vidarbha region. This is the percentile, and then tree have the 13% space, shrub 37, herb 40% and climbers 10%. Thank you. And my work is going on till.
Thank you, Jagannath.
Yes.
For a presentation on the diversity in Fabaceae.
Yes.
Any? Yes, Jacaranda. Bignoniaceae.
Bignoniaceae.
Yes, sir. Oh, sorry, sir.
It's not you. Delete it.
Okay, sir. Thank you.
So, hope no more questions. So, very best wishes, Dr. Jagannath.
Okay, sir.
But,
Thank you.
So, now we are moving to the next presentation by Kavya K. Nair, Systematic Studies on the Genus Eleocharis in Kerala, India. Kavya.
Respected dignitaries, I am Kavya K. Nair from Christian College, Katakada. Today I am here to present the topic entitled Systematic Studies on the Genus Eleocharis in Kerala, India. Eleocharis is the largest genus within the tribe Scirpae belonging to subfamily Cyperidae family Cyperaceae. It is a cosmopolitan genus comprising approximately 300 species distributed worldwide, and the genus is represented in India, that is 28 species. Members of the genus are taxonomically complex due to reduced floral structures and complicated inflorescence. Species are classified with overlapping characters. Gender restrictions are imperfectly defined and intergeneric connections are not well understood. Objectives of the study include to examine detailed morphological features with special emphasis on spikelets morphology, to employ scanning electron microscopic studies to analyze the surface characteristics of echins, and to analyze the phytolith assemblages within the genus Eleocharis. Methodology followed include field exploration trips were conducted to different ecological regions within the study area and plant specimens were collected. The collected specimens were identified, speciesly enumerated, and accompanied herbarium consultation for reference and comparison. A detailed study on inflorescence architecture, scanning electron microscopic studies to analyze microstructural details, as well as a silica analysis of the collected specimens were done. Moving on to the study area, that is Kerala, with its key geographical, ecological and boundary characterization are given. Moving on to result, a total of 14 taxa under the genus were collected. A detailed tabular representation of the district-wise distribution along with habitat of the collected species are given, in which 2 of them are new additions to the district floras. That is, Eleocharis acutangula itself is an addition to the flora of Pathanamthitta as well as flora of Alappuzha. Similarly, Eleocharis dalsa is an addition to the flora of Kollam and flora of Pathanamthitta. Important findings of this study include 2 new records from this study area, that is, Eleocharis acutangula subspecies Neotropica. We have collected these specimens from Kollam district of Kerala, which was known earlier only from northern Western Ghat region, thus forming a new addition to the flora of Kerala state as well. Then Eleocharis neglecta, which is a new record for South India. Eleucharis neglecta closely resembles Eleucharis dulcis in appearance. We have collected this species from Chirangir region of Thiruvananthapuram district, which was known earlier only from Konkan region of Maharashtra. Diversity of series under genus Eleucharis. Mutata is a dominant series comprising 7 species, followed by Multicaulus having 4, Maculaceae having 2, and Tenuisimae comprising a single taxon. Spikelet morphology of different series in genus Eleucharis. In series Mutatae, single elongated spike with many glooms arranged spirally were observed. In series Multicaulus with single terminal globose spikes, and in Maculaceae with single overt spike with many glooms arranged spirally, and in Tenuisimae having a single overt spike with very few glooms, but the basal glooms are being distichous. Structure of synflorescence in genus Eleucharis. Synflorescence is a floriferous shoot produced from an apical bud of the embryonal axis, which is a result from the activity of meristem. Typically, inflorescence with non-foliate scape and terminal inflorescence is observed in the genus. Inflorescence is a single spike with many or few glooms bearing a hermaphrodite flower. Net morphology using scanning electron microscopic analysis. Achenes are the unique characters for taxonomic identification of the members of the genus Eleucharis. So, achene morphology of collected species were elucidated by analyzing the achenes under light microscope along with their scanning electron microscopic images in order to evaluate their importance in taxonomic identification. These are the scanning electron microscopic images of the collected achenes. Importance of scanning electron microscopic studies. Within the genus Eleucharis, the series Mutata comprises species that are nearly indistinguishable in external appearance. Eleucharis neglecta that closely resembles Eleucharis in appearance, in which scanning electron microscopic studies reveal their differences, which demarcate the existence of new species Eleucharis neglecta, which was earlier discarded or misidentified as Eleucharis dulcis. This is how we have resolved the taxonomic ambiguities. These are the micro and macromorphological characters of achenes. Phytolith studies on genus Eleucharis. Phytolith are amorphous silicon dioxide incrustations that occurs in between the cells and tissues of the plant. In the genus Eleucharis, 12 species were studied to identify the phytolith morphotypes present in them. 24 morphotypes were identified from the specimen, and this among 6 types are unique for the genera. Analysis of achene phytolith. In Eleucharis, Chenoplectus and Furina, silica skeletons are composed of rectangle sinuate or ciliate cells in parallel rows. In Eleucharis and Furina species produced unique phytolith composed of elongated cells arranged in parallel rows horizontally, but in Chenoplectus, the cells are vertically elongated. These are the medicinally and economically important sedges. Moving on to conclusion, a total of 14 taxa under the genus were collected from this study area. Eleucharis acute-angular subspecies Neotropica is a new record for southern western Ghats. Eleucharis neglecta, a new record for South India. Mutata is a dominant series followed by Multicaulus, Maculaceae, and Tenuisimae. Inflorescence is a single spike, with its inflorescence being a non-foliate scape and terminal inflorescence. Scanning electron microscopic result revealed that epidermal pattern of achene was found to be consistent conservative within the species. Phytolith analysis of the collected species in which 6 among them are unique for the genus. Again, phytolith analysis revealed the existence of difference among genus as well as within the species. 28% of the collected species are economically important, while 14% are medicinally significant. These are the references. Thank you.
Okay, thank you, Kavya.
Thank you, sir.
And it was a nice presentation, and it very well revealed the role of microscopy in the taxonomy of the genus.
Thank you, sir.
Eleucharis. Please carry on with the good work.
Thanks.
And any questions? Any questions from the audience? Okay, best wishes, Kavya.
Thank you, sir.
So now we are moving to the next presentation, Polymorphism in some endemic APACA members from Western Ghats, India, by Kumar Vinod.
Next one. Good morning, respected all. I would like to present one of the madness or mad topic. It always mad to taxonomist, that is polymorphism in some endemic APACA members from Western Ghats. Because of such a topic, it gives less publication, more consuming time, as well as the more energy. It requires the more energy. So I'll just briefly introduce the family Apiaceae. It is represented by 466 genera and 3,826 species. Among that, 70 genera and 250 species represented in India. And identification of the Apiaceae is very, very difficult because of it requires all plant parts, and in single visit it is very, very difficult to collect the all parts. It requires at least 2 to 3 visits in single population. And the fruit as well as the mericarp, it valuable for the identification. However, it shows the more variation, and that is puzzle for us. And here I would like to present few species which shows the variation as well as the polymorphism. So in Apiaceae, leaf, that is single leaf to compound leaf, that played an important role for the identification. Then simple umbel to compound umbel, bracts, bracteoles, as well as the calyx, indumate, as well as the minute or obsolete. That is also played an important role for the identification. And most important, that is the fruit characters. The fruit characters like, as well as the ori character, it played an important role for the identification, that having the lateral compressed or dorsiventrally compressed fruit. That based on that, we can divide it into the whole Apiaceae into the 2 groups. And within anatomical characters of the mericarp, so the commissural viti, vallicular viti, ribs, types of the ribs, that also played an important role for the identification. So these 6 genera, they are the endemic to our India. Rather than pinda, all are monotypic in nature. And just I have given some leaflet photo, and each photo that is vary from each other. If we see the first row, first photo and last photo, it shows the more similarity, but it is the googly for us. So the Syringia, it having the range of variation in their leaflet. Then Pinda, that is different. First and last leaflet, that is a different, although it shows the similarities. Karnataka also shows the variations, and Polyzygus, that shows the lot of variation, and those variation, that is a population specific. So Polyzygus, that is monotypic, and that is only distributed Maharashtra and Karnataka, and it having the variation in height as well as their tuber, that having the branch tuber, you can say that is rhizome, or the non-branch tuber. Srirangi also shows the intra-population variation in their leaf as well as their height. The genus Pinda, among that, the Pinda concatensis is more distributed species, and it shows the lot of variation in their leaf, their types of the hairs on branches as well as on leaf. Regularly, the lower photo, it shows the common leaflets, but the upper one, it shows the variable inter as well as the intra-population wise. The last photo, it having the specific population, and we can publish as a new species, but it is not like that. It is nothing but the variation within a species. So here we can see the umbel that shows the different rays, different umbellate. And if we see the marginal flower in the Pinda, it played an important role for the generic characteristic, and it having the range of variation, their size and shape. The lower one, recently described as a new species of the Pinda, that is Pinda mukherjiana. It might have the nothing but the variation of the Pinda concatensis. Require to more study for that. And here also, although I told the schizocarpic, the fruit characters played an important role, but in Pinda it shows the variation. Even if we see the commissural viti, you can see the Commissural with the dark bands, that is also vary from 2, 3, 4 or 6. This is the one of the mad species because of it shows the population specific variation, that is Tetratenium grande. That shows the lot of variation in their height in plant, 1 feet to 8 feet. You can see here the how much it having the height, and it is a very great puzzle for us. And another thing, their fruit, and this species it clean boulders because of the water having the photos, fruit photos size and shape, that is population specific. So it is a very difficult species to understand their behavior. So already I told the polymorphism, I have just shown the few photographs because of the time limit. So polymorphism it showing in some genera like Polysygous syringia, Tetratenium, Pinda, and the variation that is found in inter as well as the intra-population. And for understanding each species, we require some kinds of the experiment, that is a taxonomical experiment. We have to grow the population-wise plants in a similar climatic condition for the understanding their behavior, delimitations of the genera, as well as the delimitation of the species.
Okay, thank you, Kumar.
This is my acknowledgement. Thank you.
So you have made a very good presentation explaining the diversity and polymorphism in endemic Apiaceae. So any questions from the audience? Anything to discuss?
It is a wonderful presentation. So what is your, your suggestion regarding the solving the polymorphism to delimit the species?
Actually, it required the taxonomic experiment. Along with that, it required the cytology also.
Okay.
Basic cytology. We are doing side by side. Specifically, I told that Tetratenium grande, we have collected so far 27 population. Among that, I have grown in my home 11 population, and all population shows some variation in their chromosome. Although it shows the common chromosome number, that is 2n is equal to 44. Okay. But the slightly having the differences. So it requires to check out their edaphic factors also. Okay. So we can understand their behavior as well as the delimitations of the species.
Okay, thank you. Now we have to move on to the next presentation. I have a humble request to the audience. You can talk to each other, but please reduce the volume while you are talking because it's creating a lot of disturbance. And next speaker is Madhumita NR on examining the origin and phylogeny of endemic Humboldtia of the Western Ghats.
Good morning, everybody. Today I'll be presenting my work on examining the evolutionary origin and molecular phylogeny of endemic Humboldtia genus in Western Ghats, India. Humboldtia is one of the few endemic woody plant genera found in Western Ghats. Nevertheless, I'll have to mention some of the revisionary work done by Dr. Sanjapa sir in this genus and other dignitaries who have contributed in the taxonomy part, and one species is named after sir. And so it belongs to the family Fabaceae in subfamily Deuteroidea and tribe Amrithiae. It has 8 accepted species and 2 varieties, with one being endemic to the Sri Lanka and other species being endemic to the Western Ghats. However, there have been a phylogenetic study done previously on the entire tribe of Deuteroidea by Estrella in 2007. Coming to some of the, why is Humboldtia special? If I had to mention that, it's endemic. And then some of the taxonomic characters, it has a foliaceous stipules. It has evenly numbered leaves, leaf arrangement, and it has a winged rachis. Some of the species show cauliflorescent fluorescence, and they show very distinct port characters. And some of the species, like Brunonus, they have extrafloral nectaries on the leaf surface, and they have a specialized structure called domatia, which harbors arthropods, soil arthropods, and other annelid species. And however, in the present study, we have included some of the newly described species into our phylogenetic tree. And the second aim would be to estimate the divergence time and origin of Humboldt and to examine the speciation patterns happening inside the Humboldt genus. So these are the materials method. We did a thorough sampling across the Western Ghats, and we generated the molecular data using 1 nuclear marker and 3 plastid markers. And we did a phylogenetic tree reconstruction. Divergence time was estimated using 1 fossil and 2 secondary calibrations, and the ancestral state reconstruction was done using biogeopias. So coming to the result part, the Western Ghats Humboldtia is retrieved as a monophyletic group here. And the widespread species, that is Humboldtia brunonus, is sister to the southern Western Ghats clade. However, the relationship within the southern Western Ghats clade is not that clear. And this is a distribution map. So the Humboldtia brunonus is restricted to the central Western Ghats, that is above the Palghat Gap, which is a 30-kilometer wide separation between central and southern Western Ghats. And you have this other species, Valiana, Sanjapa, Bulloni, Ponmudiana, Decorens, Unijuga, and Trijuga, which are distributed equally above and below the Shenkota Gap. And coming to the divergence time estimation, post building the phylogenetic tree, we estimated that the stem age of Humboldtia, along with the other sister groups, somehow originated around 44 million years ago, somewhere in the mid-Miocene period. And the ancestral range of Humboldtia and its sister species is said to have a wider geographic range, that is Neotropics, Africa, and Peninsular India. And Humboldtia is genus, as a genus, should have originated in Asia and might have undergone speciation events in the later period of time. And this is in accordance with the geological events as well, and it's overlapping with that. So around 55 to 35 million years ago, India was drifting towards the Laurentian plate, and it's supposed that there might have been some geological connections like a stepping stone bridges connecting all the 3 landmarks. And if we zoom into the Western Ghats region, which is my prime study, so Humboldtia is, as explained before, is originated somewhere around 17 million years ago, according to the biogeobious ancestral state reconstruction, which is close to Miocene period. So for our biogeographic studies, we divided the Western Ghats region into 3 states: above Palghat Gap, below Palghat Gap, above Shenkota Gap, and the C denoting below Shenkota Gap. So the ancestral state of Humboldtia is supposed to be widespread, with Humboldtia brunonus majorly distributed along the central Western Ghats, and the rest of the species restricted to the southern Western Ghats below the Palghat Gap. And if you come to the biogeographic part, there are many biogeography models, but we used DEC plus J model, and here what we find is that Humboldtia brunonus separated from the southern Western Ghats due to climatic vicariance, and the rest of the Humboldtia species below the Palghat Gap, they might have undergone sympatric and subset sympatry. What I mean is that if you look at the Unijuga and Trijuga over there, so they have the same ancestral states, and they have occupied the same zone in the later period of time, which I mean is the sympatric speciation event. And if you come to the other part, like Humboldtia valiana has taken the ancestral state AB. And if you see the sister species Decorens, it has taken a part of the ancestral area, and that's what I mentioned here as subset sympatry. And these speciation events might be due to Miocene aridifications and monsoon intensification, which happened somewhere in 15 million years ago and 10 million years ago. So why is this why is there a variation in the southern Western Ghats species? We dealt more into the other aspects, like we did a skull model, convex hull, taking precipitation seasonality along the y-axis and elevation along the x-axis, and we found that it has a separation over the elevational basis. Coming to the conclusion, the results show that Humboldtia is a monophyletic group and originated 17 million years ago, and the phylogenetic tree is showing wide range to narrow range distribution. And the relationship within the southern Western Ghats species is not certain and needs to be examined further, which we speculate is maybe due to other ecological factors acting, playing a major role in that. And work ahead, we'll be trying to build an ancestral trait reconstruction to understand what is the trait that is responsible for the different variation that we see in Humboldtia species, at least with southern Western Ghats. And we have not included the Sri Lankan species with this lorifolia, and we are planning to include that, and we'll examine the population genetic study, and I would thank my lab members and my guide.
Okay, Madhumitra, it was a very good presentation. Is this your PhD work?
I'm a project JRF at CCMB, sir.
Okay, this phylogeny work is on the project base.
Yes.
Okay, a lot of things are there. I think Sanjay sir.
Because this is still in the preliminary stage, in the middle stage. Yeah. Anyway, I was surprised to see Humboldtia Ponmudiana and Humboldtia walliana, Humboldtia walliana and Humboldtia decorans coming in the same clade. I am surprised because it should have been more close to Humboldtia Ponmudiana, because it is from that species it has been segregated.
Yes, so that's what we'll be trying to do in the further analysis.
There is some problem, I feel. You have to relook at it, that particular relationship.
Okay, yes.
That's very important. Otherwise, it is good, and you include Sri Lankan larifolia,
yes,
so that you get a real. And one more thing I want to mention is, I don't know, Anup will be able to tell. He has also revised Anup Balan, the genus. You see, the Humboldtia brunonis, which is present in the north of Palghat Gap, is also, there are some populations in the south of Palghat Gap also.
Okay.
There are some collections. If you want, I can share those collections with you, so that you can look for fresh collections.
Sure. Thank you.
Some collection reports are from the Ernakulam area, Central Kerala area also.
Okay, okay.
Recent reports are there.
Okay.
You should include a lorifolia. Without lorifolia, it will not be complete. It's a type species of Humboldtia.
Yes, sir. We were not able to get the
Specimen, yes.
You request the director of Peridenia Botanical Garden. They have at least about 4 or 5 trees of that.
Okay. Sure, sir. Thank you.
Okay, thank you.
Just a minute, sir. Have you collected all these species on your own or your group?
No, so one of my colleagues, he had gone to field and collected the specimens.
Number one. Number two, I know you are trying to answer some scientific questions, but these all Humboldtia species are endangered, most of them, right? What efforts have been done by your group to bring them? I mean, that, in addition to that, they can do help to the people, whether you have tried to bring them in botanical gardens or any institutional gardens, so that, you know, they come at one place.
Yes.
In addition to your work, I suggest, request that we should collect seeds, germinate, and bring them under human care. Okay?
Sure, sir. Thank you.
So, thank you. And the next presentation is Pachysandra axillaris, subspecies axillaris of Bacchaceae, a new genus record for the flora of India, presenting by Nikhil Krishna.
That's fine. That's all right.
A very good morning to all. So welcome to my presentation entitled Pachysandra axillaris, subspecies axillaris, a new genus record for the flora of India. So the family, the taxa belongs to the family Buxaceae. It is a well-known as the boxwood family, and this family was before treated under Euphobiaceae, and in 1859, Bailon segregated Buxus, Sarcococca, Pachysandra from Euphobiaceae, and he established the family Buxaceae. It's a small family with 130 taxa, and the general characters include the inflorescence consists of male and female flowers, and the Stylocerus is the only genus having the dioecious members, and the male flowers are composed of 4 to 6 tepals and 6 stamens. Female flowers of Buxaceae with up to 20 bracts or tepals. There is a conflict in between the treating whether the tepal or the petal in that group. And altogether they have 6 genera recognized under this family. And the largest genus Buxus is with 101 species, is widely distributed in all the continents except Australia, and the smallest genera are geographically restricted. For example, Didymelus is in Africa, Haptanthus in Central America, Sarcococca in Eastern Asia, then Stylocerus in South America, and Pachysandra in Asia and North America. So these are objectives and materials methods followed. Then coming to the genus Pachysandra, it is a small family, a small genus in the family Buxaceae, and mostly exploited as a the carpet plant in the gardens. And we have Robbins did the latest available revision of the genus, and he recognized 4 taxa under this genus. And the general characters include this genus is like mostly small erect or decumbent prostrate herb or shrub, or the small subshrubs also reported, and the leaves are simple evergreen and extupulate plants, and peculiarly the leaves also is having the dentation that is starting from half of the leaf size, and the flowers are unisexual that I have already mentioned. Then female flowers are bracteate and 4 to 6 tepals and 2 or 3 carpellate flowers, and locules having a single ovule. So you can see the members of this plant used as the carpet plants. So this is the key to the species of the genus Pachysandra. And coming to the Pachysandra axillaris, subspecies axillaris, it is published in 1899 from China, and it is mostly flowering and fruiting during November to March, and it is growing in the moist shady habitats and at an elevation 1200 to 1600. So this is a also monoecious plant. The general characters I am skipping, and you can see the leaf character also. And the inflorescence are axillary, bisexual male flowers, 8 to 18 female flowers, 1 or 2. So the pointer is not working actually. That second photo you can see all the inflorescence bunch having only 1 female flower we can observe. It may be 2 also in some occasions. Then so this is the distribution of the genus Pachysandra according to the last revision. So you can see the distribution in southwest China and Japan, and one species that is Pachysandra procumbens from North America, that is Virginia, Florida, that region. So this is a distribution disjunct. So few plants or species are in one continent, and it is another one member is reported from America, another continent also. So this is a distribution of Pachysandra in India. We have recently collected a population belongs to this genus Pachysandra from Manipur, from Senapati district. So that we identified as Pachysandra axillaris, subspecies axillaris. So to the conclusion, the Pakistan axillaris, subspecies axillaris has not been reported previously from India, and this discovery represents a new generic report for the flora of India, and thereby extending the non-distribution range of this genus westward from China into the Indian subcontinent. That's all. Thank you.
Thank you, Nikhil. It was a good presentation, especially to introduce a new taxa which is unknown to most of us. So it was a nice presentation. Any points to discuss? Any queries or questions? So okay, Nikhil.
Okay,
Please
thank
carry
you.
on. Good luck. And now the next speaker is Nilesh on Tribe May Day of Poesy in India, an overview.
Good afternoon, everyone. My name is Nilesh Madhav, working as a research student at HBTR Saravike Science College in Nashik. Today I'm going to present on Tribe Madi in India, an overview. Tribe Madi is a very economical group. The Tribe Madi comprises about 12 species and 3 varieties in India. It has the potential to serve as a rich food source and the medicinal properties. The name Madi originates from the Maya, one of the oldest civilizations in the human history from the Mexico. They worship the nature and natural entities. It is a small tribe consisting of a New World genera Zia, Tripsacum, and Old World genera like Coex, Trilobacne, and Polytoca. Recently, after the molecular evidences by the Soren et al., the Andropogony is subclassified into the subtribe like Chionacini, Tripsacini, and Coicini. These are the materials and methods I have used in my study. In the world, there are about 35 species and 6 varieties are present in the tribe. And in India, 12 species and 3 varieties are reported. This is the map for the tribe Madi. Here we can see the majority of the distributions are found in the Southeast Asian countries. This is the female speculates of the older type. Only by looking at the female speculate, we can identify all the genera. Wild and cultivated genera are there: Coex, Trilobacne, Polytoca, Tripsacum, and Zia. This is the key for the tribe Madi. This is the typical flower of the tribe Madi, where male and female speculates are on the different positions or the different parts of the same plant. This is the inflorescence types in the tribe Madi. Genus Coex, there are about 2 species and 3 varieties are reported from India as Coex lacrimosa as a type. Female speculate is enclosed in a stony covering formed by the modified hardened leaf sheath is the key character for the identification of the genus. This is the key for the Indian Coex. This is a typical inflorescence where many male speculates and few female speculates, also called as the utricles, involucral salt beads. This is a female involucral diversity in the genus Coex from India. This is the Coex aquatica, Coex lacrimosa variety lacrimosa, Coex lacrimosa variety stenocarpa, Coex lacrimosa variety mayun, which is edible in the Northeast India. This is Coex lacrimosa variety pulerum, which is lectotypified and recorded after 116 years from India. This is Trilobacne. It is a monotypic genus with single species Trilobacne cookie. Another genus is Polytoca. There are about 4 species in the India: Polytoca gagintia, digitata, semiteris, and wallichiana. This is the key for the genus Polytoca. 3 species we have collected: Polytoca semiteris, wallichiana, and gagintia. This is the cultivated genera Tripsacum and Zia. This is the key for the genus Zia. We have conserved the species via the germplasm for the cytological studies. We have collected the seeds, harvested, and prepared for the cytology. Cytological paper was published in the Cytology in 2023. This is the first report of the Coex done by the Leonardo da Vinci, which is the first record for the Western Europe by Leonardo. We can use the ethnobotanically uses in Khasi tribe. They prepare beverages and eaten raw. This is the Naga tribe, the photographs of their New Year festivals. This is the mourning necklace worn by the widows from the Papua New Guinea. The necklace is made from the Coex seeds only. This is the scope for the India. Majority of the food products are produced in the China, Japan, and Korea. So we have major scope for this in the India. We designated 12 typifications and 1 new type for the genus. And Coex Lacrimosa pullarum was reported for the first time for the flora of Indonesia. And 2 new novel taxa are in the process. These are the publications, selected references. Thank you.
Okay, Nilesh, that was a quite interesting presentation with a wide range of potential of this group, including the economic botany and ethnobotany.
Yes.
It was very informative, and
of course, it was an informative presentation you have given, very nice slides. So I would like to know what are the difference in the varieties of the Coex lacrima jobi?
What is the varieties?
Can you show us that
Yes,
how
sir.
different? Or you just explain, no problems.
There are 3 varieties found. This is a typical Lacrima jobi variety, Lacrima jobi. Then this is the Lacrima jobi variety pullarum, which is broader than the long and without beak.
Okay.
This is a Lacrima jobi variety Stenocarpa.
It's a double fruit, that one?
Yes, sir. This is female spikelets.
Okay.
This is fruits only. What is, sir? The hardened structure is there, no? It is modified leaf sheath in the coax. This is Stenocarpa. It is a much longer seeds. In this is the Mayun. The outer layer is very soft. So it is cultivated in the Khasi and Jaintia hills. It is used for the food there. And this is Aquatica. Aquatica is a perennial species. The stem of the Aquatica grows about 100 meters, and floating stem is there. And in the nodes, there are tillers are there, and then the fruiting is there. Baki, all the species are annual. This is perennial species, Aquatica.
Thank you.
Just one point I wanted to make.
Yes, sir.
Second slide, from the beginning, the sculptures.
Yes, sir. From the Maya regions.
No, not that. This one. The previous one. This. Where did you get this?
This is the paper we have given from the Google, sir. This is the Maya tribe from the Mexico, where the Huanhanpo, there is a god which is called as the Mayan maize god. This is the origin of the maize.
No, actually. This is from Somnath temple near Mysore.
Okay, sir.
So this sculpture, and I personally feel this is misidentified.
Okay, sir.
As maize, because this is a 12th century sculpture.
I have read literature, sir.
There what I am telling is, even those people who have interpreted it, I think Ganesha's paper is it. So this is not, I feel that it is not maize.
Okay, sir.
Because maize was never existing in India at that point of time.
Okay, sir.
So this must be only Jasminum sambuc, buds which have been put together, like a floral bouquet.
This reference I taken from the literature, where
Yeah.
they
That's
mentioned
what I
that
wanted
this is
to
the
point
maize
out.
only.
This is definitely not maize.
Okay, sir.
Okay.
so hope no more questions. So thank you on the night presentation. And next presentation on endemic plants of Haveri district, Karnataka, by Ingiraj.
Next. Good afternoon, everyone. Myself, Ningraj Maknur from RTS Degree College, Ranebennur, Karnataka. My presentation topic is endemic plants of Haveri district, Karnataka, India. These are the contents of my presentation. The plant diversity in overall globally is depleting due to the urbanization and industrialization and other anthropogenic pressure. So there is a urgent necessity to document the floristic diversity of the world, so that Convention on Biological Diversity adopted the global strategies for the plant conservation along with the 16 targets. Out of that, first targets stated to document an online flora of all known plants of the world. India is, as we know, one of the megadiverse point of the world, with its varied biogeographical area and climatic variations. India has a total of 22,368 angiospermic plants as documented in the year 2024. It is published by the Plant Discoveries of Botanical Survey of India. At the Karnataka diversity stands at 6,771 angiosperms. Out of that, 1,499 are endemic taxa. The endemic species are, as we know, that is restricted to a particular geographical area, which are concentrated in a particular regions, which are known as biologically interesting spots. We are called as biological hotspots. In India, we have 4 biodiversity hotspots. Objectives of my study is to document the floristic diversity of the Haveri district and to identify the plants with available literature and to enlist the endemic plants of Haveri district and to prepare the herbariums for future references. This is the study area which is located in the central part of Karnataka. It comprises of 8 talukas, which interestingly having the 4 rivers in its geographical area. This is the methods I have followed to collect the plants from different regions of Haveri district and to identify with the available literature, and we have gone for the IUCN conservation status by online databases, and herbariums are deposited in the Karnataka Science College, Dharwad. Our study resulted, entire Haveri district resulted 877 species belong to 124 families. Out of that, 46 species are endemic to the district. The checklist of endemic taxa, it includes the 46 species. Here we are seeing the Siropegia bhati. One of the type collector is here, Professor Yadav sir. Here they have discovered the new species, Siropegia bhati, from Malebenur Ghat of Davangere district in Karnataka. This is the checklist. Out of that, we have majority of the species comes under the Acanthaceae family, about 6 species from Acanthaceae and so on. The habit-wise distribution of endemic taxa shows herbaceous flora is dominant. Then, according to regions, we are classified the endemic species. Most of these species are endemic to the Western Ghat region. These are some photographs of my collection. Here we have Siropegia bhati. In figure H, Siropegia bhati, it is purely endemic to the Karnataka. We have located in first type locality and next to in our district. And Curcuma karnatakensis, the Discoriste vagans, it is also narrowly endemic to Karnataka region. In our collection, we have came through a state edition that belongs to the family Orchidaceae, Geodorum laxiflorum. The genus reported with the former species Geodorum densiflorum, and the Geodorum laxiflorum is addition to the flora of Karnataka. This is the herbarium of that collection, and we have reported it in the Nelumbo journal. And this is the Siropegia bhati, next collection to the type locality from Haveri district. So it is the type collection. It comes under the critically endangered category with less population. In the type locality, there is anthropogenic pressure and road construction issues. We have found the extended distribution location. These are the conclusions. The Haveri district is rich in floristic diversity and endemic taxa, as we reported. It is need to conserve the natural forest, and we need to provide the proper fencing and restoration programs and awareness to the public. And along with the collaboration with forest department, we need to conserve the forest and these endemic species of the district. These are some references of my work. Thank you for this opportunity.
Okay, thank you,
Honorable
Ningaraj, for giving a vivid glance about the diversity in the area. So now it's open for discussion, please.
I just wanted to ask one question. How many endemic legume taxa you have collected?
Sir, 3 taxa, sir, legume taxa.
Can you tell me the names? Can you tell to the audience names of that taxa?
Sir, by list I can say, sir. I am not remaining, no.
Okay, okay.
So any more questions or queries? I hope no more questions regarding, okay, thank you. Ningaraj.
Thank you, sir.
Now we are moving to the next presenter, Priyanka. The topic is floristic diversity of the Van Wildlife Sanctuary, a core of Melghat Tiger Reserve.
Thank you. Very good afternoon to all of you. Today I am presenting a floristic diversity of one wildlife sanctuary, a core of Melghat Tiger Reserve. Actually, this study was the annual action plan project of Botanical Survey of India, which this survey I have conducted during 2016 to 2019. So, one wildlife sanctuary is the critical tiger habitat and core of the Melghat Tiger Reserve. This this wildlife sanctuary spread over the area of 211 square kilometer. Actually, this wildlife sanctuary is the typical example of dry deciduous forest, where Tectona grandis, Terminalia elliptica, Terminalia bellerica, Boswellia serrata, then Angiosperm latifolia, these are the dominant species of this area. And this is the flagship species of the Melghat Tiger Reserve. So that is why of one wildlife sanctuary tiger, and I have captured the photograph. So this is the first one is the Mahadev Cave Temple. It is located in the Dhargad area, which comes under the one wildlife sanctuary. It is a unique geographical structure which comes under the one wildlife sanctuary area, and it attracts the massive pilgrimage during the Shravan Mas. And lower one is the Vari Dam, which is constructed on the Van river at Van area. So these are few glimpses of the one wildlife sanctuary. Actually, if I can say, during my survey I have observed, this wildlife sanctuary shows the more density of the plants more than the diversity. And in rainy season or monsoon season, this wildlife sanctuary appears as a heaven. But exactly in contrasting in summer season, as temperatures rises more than 45, it experiences real hell in that wildlife sanctuary area. So coming to actual floristic survey, total altogether I have conducted 7 field surveys in the sanctuary area in different seasons. I have documented altogether 496 angiospermic plants and 5 pteridiobatic taxa. Out of these 496 taxa, angiospermic taxa, 2 belongs to magnolias, 23 belongs to monocots, and 401 taxa belongs to the eudicots. The flora is dominated by the families such as Fabaceae, which is represented by 87 taxa, Poaceae by 45 taxa, Asteraceae by 30 taxa, Acanthaceae by 26 taxa, Malvaceae by 20 taxa, and so on. The dominant genera are Ipomea, represented by 11 taxa, Cyprus by 10 taxa, Alicicarpus and Indigofera by 8 taxa, and Crotalaria by 7 taxa, and Desmodium by 6 taxa. So these are the 8 species we have newly recorded for new record for the flora of male guard. These are the species. And out of that, Alicicarpus sapelianus and Ipomia clarki is the endemic to the, are the endemic species. These are endemic to India, we can say, not only the wildlife sanctuary area. So these are few glimpses of the plants recorded in the wildlife sanctuary area. So during the study, we have recorded some medicinal plants, ethnobotanically important plants, wild edible plants, and endemic plants also. So as I told, 40 endemic plants we have recorded from the wildlife sanctuary area, and which is endemic to India. And whatever medicinal plant and ethnobotanical plant data we have collected, that we have collected from the local tribes, which are Korku and the Rati tribes. And most of that plants they are using to prepare curries, and I have personally tasted that. So this is the village. This is the only village was present inside the wildlife sanctuary area during the study period. And after that, that village was rehabilitated in the outskirt areas. So these are the few pictures of the local people, which are totally depend on the forest to collect their livelihood. These people, and they are badly habituated to tobacco and ganja also, that is a cannabis. These are few artifacts prepared by that people. And as I told, they are totally dependent on the forest. Every house people, they are collecting these flowers from the area, and every house they have one distillery. And whenever we went to their houses to collect the data, every time they offered us to, they are preparing one special kind of liquor in Maharashtra, it is called as the Desi Daru. Every time they offered me, I have tasted also, not Daru, but this flowers, it is very tasty. And these are few observations I feel. So important, I will tell you, this spread of invasive alien species mostly along the river belt. Second is burning of litter fall. Actually, forest people have so many equipments to stop the forest fire, because this is forest fire prone area. But instead of removing that litter, they are burning it. And I have observed in first field tour, I have collected few species from that areas. Kilometer to get this area, they are burning. So in next field visit, I have not recorded same plant from the same area. So these are few glimpses. I have, out of interest, I have collected some mushrooms also from that area. Thank you.
Okay, thank you, Priyanka madam. And it was an elaborate presentation on multidisciplinary approach of the wildlife sanctuary. It's good. So I think you have made some economic aspects of the plants also.
Yes, sir.
Yeah.
It's a nice presentation from Botanical Survey of India. So which species of Madhuka it is being?
Madhuka longifolia, variety longifolia only.
Nice.
Any questions from the audience?
I think no.
Okay, thank you.
Okay, thank you, sir.
So the next presentation is genus Denetus, revision for India, and one new record for the Gujarat by from Rasik Sojitra. Welcome.
Good morning everyone, welcome to my presentation. So my presentation is on the revision of the genus Denetus in India with a new record for the Gujarat. So in the introduction, in India, family Convolvulaceae comprise over 1,814 species across the 57 genera, and in India it is around 24 genera and 164 species, while in genus Denetus work from Step Pulse in 2006, it is stated that in Asia, 8 species are revised, and my work is on the new record for the Gujarat, Dynatus racemosus. Previous Indian records of the Dynatus racemosus originate from Darjeeling, Himalaya, Kinnur and Himachal Pradesh. Although the Purana paniculata is previously recorded from Gujarat, which is reclassified under Paranopsis paniculata. While the genus Purana generally comprise twining herbs, and Dynatus denotated, which is distinguished by non-accretion, differently shaped calyx and corolla. According to recent report by POO, the genus Dynatus comprises 8 species distributed globally, which is 6 species addressed in this revision of India. So in maturation method, we have gone through a critical examination, review of literature, various states, flora and theses, articles, checklist. So the Dynatus racemosus, which is a newly record for India, it is distributed in India, Karnataka, in Tamil Nadu, Assam, Uttarakhand, Maharashtra, West Bengal, and as well as Bangladesh, China, Indonesia, Myanmar, Pakistan, Thailand, Vietnam, and species examined in Gujarat, Dang district, Saputara hill region. So this is the photographs of Dynatus racemosus. This is another Dynatus decorus, which is distributed in India, Nagaland. This is the Dynatus grandiflorus, which is distributed in India, West Bengal, Sikkim, and as well as Nepal. Dynatus denotatus, distributed in India, Assam and Nagaland. Dynatus truncatus, which is distributed in India, Meghalaya only. And Dynatus malabaricus, which is distributed in India, Maharashtra, Himachal Pradesh, Karnataka, as well as Tamil Nadu. This is the distribution map of genus Dynatus in India, which is we can see most of the species recorded from Maharashtra as well as northeast. This is the key to species of genus Dynatus, species Dynatus in India, which is 6 species. This is the reference I've used. Thank you.
Okay. Thank you so much for your presentation, Rasik. It's actually an ornamental plant too, isn't it?
Sorry?
Whether any horticultural potential for this?
I can't understand, sir. What?
Whether it can be grown as a garden plant?
I don't know, sir.
Have you not seen that plant?
It is generally grow around road, thick edge area.
So it's my suggestion, when anybody is suggesting a particular genus or a species, it is mentioned to give the family name in the abstract. So that's a good practice. In some of the abstracts, I couldn't find any family names. Okay,
thank you, sir. I will consider it. Thank you, sir.
Okay.
As you told, there are six species found in India.
Yes.
How many species are there in Maharashtra? How many species are there?
I don't recall, sir, actual number.
Okay.
It is given in map. I think two or three species there.
Because you told many of the species are there in Maharashtra.
It is in locality. Suppose I had Dynatus racemosus, it is reported in more locality.
Thank you. Any questions in the audience? Okay, Rasik.
Thank you.
So the next presentation is on spur diversity of wild balsams in the southern Western Ghats, India, by Reshma Raju.
Okay, ഇതെങ്ങനെയാ പോയിന്റിങ് ഇത് മാറ്റി
Namaste. I am Reshma Raju, research scholar coming from Department of Botany, St. Thomas College, Para. Here I present spur diversity of wild balsams in southern Western Ghats, India. What are balsams? The genus Impatiens, commonly known as balsams, which is phytogeographically unique genus, one of the largest genera of Angiosperm in India, showing adaptative radiation. Which architect designed the shape? The nature. The uniqueness of impatiens is its floral morphology. Impatiens have a complex but interesting floral parts. The flower is zygomorphic. It has a uppermost standard petal, a set of lateral sepals, and a set of wing petals, otherwise known as lateral united petals. Which the wing petal is sometimes divided into two, the basal lobe and distal lobe. Sometimes it may lobed into three, basal lobe, distal lobe, and middle lobe. Then the lower sepal is modified into a special structure, lip, and there is a spur. Thus, the andrecium and gynoecium collectively form a column-like structure at the center of the flower. What is spur in balsam? A tail-like structure emerging from the lip or the lower sepal is known as spur. It is connected to the pollinator. The spur characters may play a main role in delimiting the taxa. Another peculiar structure is a dorsal auricle, which is emerging from the wing petal, and it is hidden in the vacant space in the spur. And this dorsal auricle contribute extra support to the wing petals to balancing. What is left to know? Spur diversity and its taxonomic significance, the role of spur in the floral composition of impatiens. In this slide, we can see the diversity of spur shape in South Indian balsams. We can see the shape, the color, the texture, the pubescence, the length, everything is varying from species to species. Spur can be taken as a stable character because each taxon possesses its own unique spur. Here we can see that the length varying in different species. This is Impatiens travancourica. It is a spurless or very minute spur-like structure is there. This is Impatiens herbicola. A bulged portion is there. It cannot be considered as a spur. It is only a bulged portion. From there are so many spurred taxa is here. And this is Impatiens capiflora with 5 or 6 centimeter length. It is tubular. The Impatiens violacea is succate. Every features of spur is different from species to species. So it can be considered to delimit the taxa. South Indian impatiens classified into 7 sections by V. Bhaskar. We can move to the each section. Sections capitulae include spurless as well as spur taxa. The spur shape varying from tubular, cylindrical or succate. Spur length 5 mm to 5 centimeter. In section epiphytica, the shape is maybe succate and simpiform, laterally compressed, etc. The color varies from red, purple, green and green combinations. The length varying from 1.5 to 3 centimeter. In section Anway, there are spurless as well as spur taxa is present. The length vary from 0 to 5 centimeter. The shapes including tubular, succate, slender, inflated, hook-shaped, etc. The pubescence on the spur is an important character for delimiting in this section. Section Microcephalae. Spurless as well as spurred taxa is there. The length up to 5 centimeter. The shapes including slender, hooked, etc. In section Tomendosae, all taxa is spurred one. Length varies from 1.5 centimeter to 5 centimeter. Shape including short, stout, incurved, slender spur. Section Subambulate, spurless as well as spur taxa is present. The length is 3.025 centimeter, and the shape includes conical, thick, tubiform, short, constricted, short, straight, etc. In section Racemose, spur taxa, the all species are spur taxa. Spur length varying from 5 millimeter to 4 centimeter. Tubular, the shapes include tubular, slender, trumpet. Taxonomic significance of spur. Earlier taxonomies coined spur epithets, spur-related epithets, impatiens clavata, impatiens clavicornu, impatiens uncinata. The taxonomic characters, the presence or absence of spur, spur length, spur shapes, spur colors, spur trichomes are important in the delimiting taxa. The role of spur, the spur help plant to balancing and keep buoyancy and attracting to the pollinator. Balancing in the sense when pollinator landing on the surface, there should be a balance, and this balancing provided by spur. The spur and colors and patches of lips attract pollinators. Thank you for the patience to listen on impatience.
Thank you, Reshma. It was a very nice presentation with colorful slides and all. So now it's open for discussion.
It's a wonderful presentation with colorful. So the spur, based on spur, you have identified all these things, classified, isn't it?
While dissecting the specimen and identifying the specimen, spur plays an important role. It helps a lot.
Any questions? Audience, please. Okay, you are very cooperative. And now the next speaker is Rohit M. on endemism and distributional insights into Loranthaceae and Viscaceae of Peninsular India.
Good afternoon, everyone. Myself, Rohitam. Here I am going to present a paper on the topic, Endemism and Distributional Insights into Loranthaceae and Viscaceae of Peninsular India. Coming to a general introduction, the family Loranthaceae and Viscaceae are generally known as mistletoe families, and the members are shrubs, aerial hemiparasite on trees with attractive flowers, and they exhibit an array of morphological diversity, and they are having an ornithophilous manner of pollination and seed dispersal. Mistletoes are having great ecological roles. They are providing food for birds, butterflies, arboreal mammals, and nesting habitat for birds and ants. The term mistletoes come from an old English word called mistletoe, which means dung on a twig. These birds eat the pulp of this fruit, and the seeds will pass through their alimentary canal and come out as a drooping. So these drooping will attach to the branches, where it will germinate and develop its haustoria and become a new plant. In India, the family Loranthaceae consists of 8 genera and 60 taxa. Out of that, 27 species and 3 varieties under 8 genera occur in peninsular India. Like the same way, Viscaceae consists of 4 genera and 21 species across India. Out of that, 2 genera with 50 species occurring in peninsular India, which is around 68.2% of total Indian Viscaceae. This is the study area, which include 11 states of India. And coming to the objectives, first one, to carry out the taxonomic studies on the families Loranthaceae and Viscaceae and document their diversity in peninsular India. Second one, to map and analyze the distribution of species of Loranthaceae and Viscaceae in peninsular India. Third one, to examine the ecological role and factors influencing mistletoe diversity and endemism. This is the objectives methodology I have followed. Coming to the resultant discussion, this is the diversity of family Loranthaceae and Viscaceae in peninsular India. The family Loranthaceae consists of 8 genera: Dendrophthae, Elytranthe, Helicanthus, Helixandra, Macrosolent, Scurula, Taxilus and Tolipanthus. And the family Viscaceae consists of 2 genera in peninsular India, Corthalacella and Viscum. This is the diversity of Loranthaceae in peninsular India, total 30 taxa in 8 genera. And this is a pie diagram showing the combined pie diagram showing the endemics in peninsular India of 2 families. The family Viscaceae, the genera Viscum consists of 6 endemic species. The family Loranthaceae, Helixandra and Taxilus genus consists of 3 endemic species each. Then genus Dendrophthae consists of 2 endemic species. Then Elytranthe, Helicanthus, Macrosolent, Scurula and Tolipanthus having 1 endemic species each. Then this is the list of endemic species of Loranthaceae in peninsular India and its distribution. This is one of the endemic species, Scurula stocksy. It's a stenome endemic to Maharashtra, which was collected by stocks, JE stocks in from this Kongan area of Ratnagiri, Maharashtra. After that, Cook collected from this Samantawadi jungle. After that, Mishra and Singh conducted a study, and they can't able to collect this material, and they call it was vanished from that area. After that, 127 years later, Arun Chandor et al. Recollected and electrified this endemic species. Then this is the distribution of endemic species. So other endemic species: Dendrophthae mavicillafolia, Helicanthus elasticus, Helixandra intermedia, Helixandra lepidophylla. This is one of the endemic species, Helicanthus elastica, which is endemic to Kerala and Tamil Nadu. This is the distribution map of other endemic species in Loranthaceae: Helixandra obtusata, Macrosolent trigonus, Taxilus haenianus, then Taxilla recovers. This is one of the endemic species. Then coming to the family Viscaceae, the diversity of Viscaceae in peninsular India consists of 2 genera and 15 species. Then this is the endemic species in Viscaceae: Viscum bandipurens, which is endemic to Karnataka; Viscum malurianum, endemic to Karnataka; Viscum mysurens, endemic to Karnataka; Viscum sahyadrica, Maharashtra; then Viscum subracimosum, Karnataka and Tamil Nadu; Viscum trilobatum, Karnataka, Kerala and Tamil Nadu. This is the distribution map of one of the endemic, Viscum sahyadrica, which is a rare endemic, which is present only in Maharashtra and Karnataka. Then this is Viscum bandipurens, which is steno endemic to Bandipur National Park, Karnataka. These are 2 another endemic species, Viscum malurianum and Viscum mysurens, endemic to Karnataka, and which is known only from the type locality. And this is Viscum subracimosum, distribution map of subracimosum, which is endemic to Karnataka and Tamil Nadu. Then Viscum trilobatum, exclusively hyperparasite, which is endemic to Karnataka, Kerala and Tamil Nadu. Then the factors influencing the mistletoe diversity and endemism, altitude is one of the major factor. Most of the endemic species are restricted to mid to high elevation zones of the Western Ghats, indicating an altitude as a key factor for their distribution. Then habitat and host preference pattern. Endemic Loranthaceae were mostly associated with the dry deciduous forest and semi-evergreen forest, where widespread Viscum species are dominated by dry deciduous forest and orbit habitats, and often restricted to particular host species, which further limits their distribution. And bird-mediated seed dispersal is another factor. Species are more abundant where frugivorous birds are more occurring, and forest connectivity also support its dispersal. Then light and canopy is also another factor. Then geographical concentration of endemic species, Western Ghats serves an hotspot, and Tamil Nadu, Kerala and Karnataka serves as a center of endemism. Then these are some ecological roles I observed in the field. This is pale-billed flower pecker, major ornithophilous pollinator, and this is unforming nest and laying egg in the hostel region of Macrosolent. Then third one, monkeys eating the fruits of Scurula species, then ants forming nest on Dendrophthae species, etc. Then acknowledgement, and thank you.
That was an excellent presentation, Rohit.
Thank you, sir.
Congratulations. And including plant-animal interactions also
Yes.
you mentioned. I would like to know a point, since they are parasites, whether any specific host specificity is there
Yes,
with,
sir.
with any species?
Yes, sir. There are many species having host specificity. And coming to one of the endemics, Helicanthus elastic is known as mango mistletoe. That is preferring mango as a major host. And it is that is one, like, and Viscum species are more host specific. That only, sir.
Good, sir.
After Sanjay and Balakrishnan's work,
yes, sir.
How many species are described?
Sir?
How many species are new additions are there?
Sir, there are 4 to 5 new additions. Not from my. I have added that.
Yeah, Maharashtra there is one new species.
Yes, sir.
I could
That's
see.
Scorulus toxi. That's
Scorulus.
rediscovered by Arun and Chandor.
No, did you try to collect these species?
Sir,
again?
actually I started my work and I'm planning to go and collect. Last year I got the permission.
Yes. Because
Not
Viscum mysurens is one which is collected by Gamble.
Yes, sir.
After the type, nobody
Yes,
has
sir.
collected.
That is only collected from the type locality.
Yes.
So this study I will try to collect from that. Try to collect from this.
And also Viscum mysurens and
Yes, sir.
malurens.
Yes, sir.
These two also Viscum subracimosa.
Yes, sir. So no one else collected after the.
Yes.
Only available in the type locality.
You need to relocate.
Yes, sir. Definitely I will.
Particularly Viscum mysurens, which
Yes,
is from Arsikere in Karnataka.
Yes, sir. Yes, sir. Thank you, sir.
Thank you, Dr. Sanjappa, for the valid point. Any more questions? Okay, thank you, Rohit.
Okay, sir. Thank you.
The next speaker is Shekhar Shabazz. On floristic studies on Harichandragarh Range, Maharashtra.
Good afternoon, everyone. My name is Shekhar Subhash Shinde. I am a research scholar. I recently registered to the PhD. I am working on the floristic study on the Harichandragarh ranges, Maharashtra. The Harichandragarh range is located in the Bhima and the the Harichandragarh range. It is located in the Bhima and the Godavari region. Then Harichandragarh is well known as a hill fort located in the Maharashtra, Ahmednagar district. It is recognized for its spectacular environmental and the different terrain. It is located at the elevation of around the 1,424 meters within the highest summit, the Taramati peak. Having the standing the view of the adjacent mountain ranges such as Naneghat, Siddhagad and the Kasra region. The Harichandragarh are the mosaic of the tropical, dry and the deciduous forest and the grassland with the rugged of the topography. This habitat is ecologically significant, but faces the pressure of the expanding the agriculture, deforestation and the tourism. The survey work done in the research area. The vegetations of the Harichandragarh ranges are unexplored in the Dalzal time in 1861. According to Billori and the Hemendri 1996, they have the record that the 330 species belong to the 245 genera, representing the 87 family of the vascular plants. Then the coconut and the thorat, they are the economical importance on the diversity. They are the recorded. Then these are my objective: the study of the floristic diversity of the Harichandragarh ranges, the study and the study of the endemic species of the Harichandragarh ranges. Materials and methodology: the extensive field survey where they carried out during the 2024 or the 25. This is only the 6-month presentation. Covering all the seasons of the involving the systematic sampling of the vegetation in the multiple localities represented by the key habitat. Then the collection of the data, the natural habitat and the phenological on the basis of the observation in the different seasons. Due to the time limit, I have not added in the habitat photography either. The study area, for example, I presently on the Harichandragarh ranges. The Harichandragarh is a historically hills for the Akole Taluka of the Ahmednagar district, Maharashtra. The region has acted as important on the floristic ecological link between the Konkan and the Deccan Plateau. The fort is located at the nearby the Khireshwar, 8 km and the 15 miles for the Bhandardara. The Harijandra importance as a study sites organize originate from the mountains, topography, rich cultures and the past and the unique flora. Then this is the result of my study, 6 months. The herb is I found a herb 1180, it is 80% and shrub 12, climber 5, trees 23. This is the species diversity according to the pie chart show in this. These are the some endemic and the rare plants I have found in the Harijandra. For example, the Thalictum dalzili, these are endemic to the Western Ghat, the Gymnospuria rothiana, it is rare, and the Pimpina novalicina, Impigenia magnifica, then Irecolon irfolon, then Pogostemon, Iria reticosa, Porprex, reticosa, Mrodania. These are the some the anthropogenic activity or the anthropogenic pressure on the Harijandra ranges. For example, due to the road construction or the development, the road construction or the increasing the ecotourism, the species number are the decreasing by the time. This is not a statistical observation, it is only for the observation in that field. For example, they are the Gymnospuria rothiana. This is lots of plant, they are the cut down in the study area. This is the conclusion. The Harijandra ranges in the Western Ghat, it is observed rich zone. The study documented the 160 angiospermic species representing the 29, which have the rich diversity. Within the diversity, I have 18 plant species are recognized as endemic. It contains the diverse range of the plant species due to the extension of the different habitat and microhabitat. These habitats support unique ecosystem and the several ecological importance as the endemic species. In the recent year, it is observed that it's a specific population, it is a decrease in the thereby the depending ecosystem, anthropogenic activities such as the increasing the ecotourism, agriculture expanding and the commercial lodging, then the fuel load and the infrastructure development such as the road and the dam construction. So the present study suggests that due to the continuous heavy pressure of the anthropogenic activity, the Harijandra range as the ranges need to be the conserved. Thank you.
Okay, thank you, Shekhar. It was a nice presentation.
Yeah, it's nice, but I'm good.
Nice presentation. So there is one objective. You have mentioned that you are documenting endemic species.
Yes.
From Harijandra.
Yes.
So this work you have done within this 6 months.
6 months, sir.
So within 6 months.
I have collected 13 species endemic, but only 10 species from Harijandra.
Okay.
Huh.
So again, I'm asking with the kind permission of Sanjapa sir, how many endemic legumes did you collected some?
No, sir.
Because
actually there are, I have collected 300 species, 300 plant species on Harijandra.
Because sir, Nogra Dazal is there, Clemenja roll is there, then Clemenja grassley is also there.
Yes.
Yes, Mithia purpurea is
yes.
also there. So you have to collect.
Yes.
Any more points to discuss? Anybody? So if so, now the next speaker is Smita DG on floral diversity survey through the trekking path of Valvandul waterfalls, Trivandrum.
Good afternoon. Myself Smita DG. I am working as Assistant Professor, Department of Botany, University College, Tirunelveli. My topic for today's presentation is floristic diversity of dicot plants through the trekking paths of Valvandul waterfalls, Trivandrum. The floristic studies are promising important in recent years because these flora are disappearing at an alarming rate. Also, the identification of plants is very important because it provides information of plants in a particular area. My study area is Valvandol Waterfalls. It is located in the Pepara Wildlife Sanctuary, Trivandrum. It is a part of Agasthyamala Biosphere Reserve. It is a UNESCO designated site for rich biodiversity. It is located in Thiruvananthapuram district and 46 kilometers from Trivandrum. It is a tourist spot. Many people are visiting in that area. This is the study area. And we collected 40 species of dicotyledon plants and 4 herbs, 7 climbers, shrubs, 6 shrubs and 23 trees. Of these, there are 4 vulnerable species, 4 threatened species, 3 endangered species and 9 endemic plants. These are the plants I have collected. Curciligo orchioides, it is a vulnerable plant and Biophyta sensitivum. Then Starchitaphyta indica, hibiscus myconia, it is a weed plant. And it is Naragamia, it is an endemic plant. And these are climbing plants, Sisambellos, Rubia, these are climbing plants, Pothos. This is Endata is a woody, large woody liana. This is Charcostigma. It is also a large liana. This is Macaranga, it's a small tree. And this Caparis is a climbing shrub. It is endemic to Western Ghats. And this Eleocarpus, this is also endemic plant, Cinnamomum. Then Delinia, Bridelia, these are large trees. Already these are identified. Alstonia, it is endemic to India. The Delinia, Olea is endemic to Western Ghats. Cassia fistula, Largestromia, these are already identified plants endemic to Western Ghats. Hopia is also endemic to Western Ghats. Hypnocarpus, then Alstonia, Bombax, Malabaricum, Endada, it is already I have just given. Then Xanthophyllum arnochianum, this is endemic to Western Ghats. And Valsura gluta, this is a plant. This is also present in our national park in Trivandrum, Shendurini National Park, Gluta Travangoriga. Its Malayalam name is Chenduruni. This is also endemic to Western Ghats. Then Cestrira, Vatiria. Vatiria is a critically endangered plant and endemic to Western Ghats. Palaquiangata, Myristica malabariga. These are the plants collected. These plants play a crucial role in maintaining our ecological balance and conservation of these plants, essential for preserving our biodiversity. And Valvandol, it is a tourist point, so people are coming and seeing the natural habitat. So chances for destroying this flora is present. So that I did this work for documenting the flora.
Thank you, Smita.
Yeah, Smita, it is a nice presentation, but who has identified you the plants? The plants you have shown, whether it has already been identified or you identified?
The trees already, I have seen the labels on the trees.
So you confirmed it? You have not rechecked, huh?
No, just no.
So you have shown vulnerable, threatened. What are the vulnerable and threatened there?
These are IUCN status.
Which are the plants?
Hmm?
Which are the plants vulnerable and threatened there you have shown?
Yeah, I have.
You just say, what are the plants?
What are the plants? Name of the plants?
It should come to a tabular form. Huh?
Yeah, some name only.
Is it vulnerable?
Yeah, it is vulnerable.
Okay.
Curciligo orchioides.
It's a common. One where it is in IUCN? I'm confused.
Yes.
Okay, you check it. Okay.
Okay.
You recheck it.
Yes.
Before you present anything, you check it because you are a professor, you know.
Yes.
So, thank you so much.
Okay, thank you.
Madam, it is not a question. It is something, which comes from my mind, that we are documenting these trees, but exactly what we are doing for their conservation. This is a question. Now, if you are going, if you know the plants, have you collected seeds, raised saplings, and planted some of them in botanical gardens or in natural habitats, which is a really need. Only documentation will not do. In future, those who are working on trees, endemic trees, and especially Kerala is very rich in endemic trees, getting germplasm is an important issue for all of us, so that we can bring them in gardens where our students can do work on bioprospecting, conservation, awareness, and so on. So this is my request,
Yes, sir.
that if you can, even one species if you help, that is the best service to botany.
Yes, I
Thank
will
you.
do, sir. Thank you, sir.
Thank-
Ma'am, how long your track was in which you have collected the plants?
How long?
Tracking route. How kilometers in kilometers?
How many kilometers?
Yes, sir.
Actually, it is around 10 kilometers.
10 kilometers. So you have came across with any invasive species, because human interference is more and more in tracking routes.
Invasive, yeah. Myconia, that is
So you
invasive.
have not enlisted.
Yeah, given.
Okay.
Yeah, no, I did not list it.
Okay.
Yeah,
okay.
yeah.
Okay. Okay, ma'am. Thank you, ma'am.
Thank you, sir.
Thank you. Next presentation is on morphovariations and species endemism in the genus Ardisia of the Western Ghats by Smita M.
Very good afternoon to everyone. My topic of presentation is morphovariation and species endemism in the genus Ardisia of the Western Ghats. Ardisia is one of the largest genera of family Primulaceae, which is commonly known as primrose family. It is coming under the order Ericales in the clade Eudicot. Many species of the genus are having wild ornamental potential, where some of them are used as medicine and food. They are mainly distributed in subtropical regions of Asia and America in a habitat of mangrove ecosystem at sea level to shoalas at elevation about 2000 meters. According to the available literature and POVO 2025, there are nearly 740 taxa are distributed in the world, whereas India has a distributor of 47 taxa. In Western Ghats, 20 taxa are present, which include 19 species and 1 variety. Among these, 8 taxa are endemic to Western Ghats. The species Ardisia amblexicolis, Ardisia blatteri, and Ardisia songifolia are listed as endangered as per IUCN threat assessment. Move on to the taxonomy of the genus Ardisia. The genus is showing variable as well as stable taxa. A key challenge in Ardisia taxonomy is the morphological plasticity. The variations are observed in leaf shape and size, inflorescence structure, floral traits, and fruit size. This leads to the formation of morphovariants, and that make the species delimitation very difficult and complex. Let's look onto the variable population in Ardisia. These are the 4 species showing greater ecological amplitude, that is Ardisia crenata, Ardisia elliptica, Ardisia pauciflora, and Ardisia solanaceae. Let's look one by one. Ardisia crenata is a shrub distributed in evergreen forest of Southeast Asia. Because of the beautiful flower and fruit, it is used as ornamental. These are the variations observed in Ardisia crenata, that is calyx color, green and red, color of midvein, red and green, and the fruit sizes varies from 0.8 centimeter to 1.2 centimeter. Next is Ardisia elliptica. It's a mangrove associate seen in this, distributed in Southeast Asia. This is also having a great ornamental value. The variations observed include flower color, that is light pink and dark rose, number of flower per inflorescence 4 to 12, and the leaf size varies from 10 centimeter to 12 centimeter, and the petiole color is also varies from green to purple. Next species is Ardisia solanaceae. It's a shrub or small tree distributed in evergreen forest of Southeast Asia. It is also growing in garden, and this also have great medicinal property. The variations observed include the size of leaves, that is varies from 8 to 15 centimeter. The flower color varies from light pink to dark rose, and the inflorescence varies from 5 centimeter to 10 centimeter. Move on to the next species, Ardisia pauciflora. It's a shrub distributed in evergreen and shola forest of India. The variations observed include number of flower per inflorescence, 3 or 4, and the leaf size varies from 8 to 18 centimeter. Move on to the reason for morpho variations. First one is ecological factors. Environmental factors like altitude, light intensity, soil profile, and rainfall influence the morphology. This reflects how Ardisia is adapted to different ecological climates. Next reason is geographical isolation. Mountain ridges, valleys are some of the physical barriers, and the population become isolated and they adapted to different specific habitat. This may result in population level differentiation and formation of species complexes. Move on to the endemic species of Ardisia. First one is Ardisia agasthimalayana. It's a small shrub distributed in submontane sholas of Cheminji and Agasthyamala hills. Another one is Ardisia amblexicolis. It's a large shrub distributed in evergreen forest of Thiruvananthapuram and Wayanad district of Kerala. This is Ardisia anamalayana, distributed in Anamalai hills about 1,200 meters to 1,600 meters. Ardisia blatteri is a typical shola species distributed in Idukki district of Kerala and Theni district of Tamil Nadu. Ardisia Ramaswamy, only known from its type locality, that is Akkamalai hills of Tamil Nadu, in an altitude of 1,700 meters. Ardisia rhomboidea is characterized by rhomboid leaf shape and distributed in evergreen and shola forest of Idukki and Thiruvananthapuram district of Kerala and Anamalai hills of Tamil Nadu. Ardisia stoni is usually appears as a shrub and widely adapted to evergreen forest of Kerala and Tamil Nadu. Then Ardisia songifolia is a shrub distributed in evergreen forests and marshy areas of Kerala and Tamil Nadu. And the interesting thing is, endemic species are morphologically stable. They are restricted to specific geographical ranges which are having uniform ecological factors like altitude, temperature, humidity, and soil type. Move on to the conclusion. Ardisia in Western Ghats shows a spectrum from variable to stable taxa, and the morphological plasticity reflects its ecological adaptation, whereas endemic taxa reflect its evolutionary specialization. So understanding morphological variation will help correct species identification, conservation planning, and studying evolutionary adaptation. Going forward, we believe that follicular phylogenetics will help us to deepen our understanding on these evolutionary trends. That's all. Thank you.
So, Smita, that was an excellent presentation. Congratulations.
Thank you, sir.
And you have mentioned about some very rare and strictly endemic species.
Yes, sir.
So, any possibility of any conservation strategies for those species?
Yes, sir. Actually, some species are distributed in the patches in between plantations. So, when we are increasing the area of plantation, that will distract the habitat of that species. For example, Ardisia blatteri is commonly seen in the in between plantations, like a small tree. Some foresters are cutting the plants. Mainly, they are seen in the side of trekking paths. So they are cutting for paths. So such activities should be restricted for the conservation of these plants, sir.
Any exit conservation drives?
Yes, sir. We are trying for many, we are collecting some samples and trying to grow in our garden. The economically useful plants are growing, but others are not regenerating, sir.
Is the fruits are edible?
In case of Ardisia elliptica, it is edible. It is edible by human as well as birds. Ardisia solanaceae is also edible.
So which species you collected from Akkamalai area in Tamil Nadu?
Ardisia Ramaswamy, Ardisia anamalayana.
Have you seen the species there?
Yes, sir. Yes, sir.
Good.
One species is riparian element, sir, Ardisia solanaceae. Yes, sir.
That you didn't tell, that's why I'm asking. All RDCR normally it occurs in the water affinity area, riparian zone.
Yes, sir.
Any more questions or suggestions? Okay, Smita. Good. Okay, Smita. Now we have
Thank
to
you, sir. Thank you.
move on to the next speaker. Sukhraj Kaur on environmental filtering plays a stronger role than geographic isolation in shaping plant communities on tropical sky islands.
Good afternoon, everyone. I'm Sukhraj Kaur, PhD student at ISER Bhopal, and today I'm going to talk about species assemblages in isolated landscapes and understand the role of dispersal limitation versus environmental filtering in shaping plant communities in isolated terrestrial landscapes. Answering how do species assemble is important because it helps us understand the biodiversity patterns around the world. And studying the key predictors will allow us to predict the presence and persistence of species within a habitat. This is especially crucial with the rising threat to biodiversity due to climate change and habitat loss. One of the most biodiverse and also the most threatened habitats are the islands. And studies have long focused on understanding why do islands support such high diversity of species in a small geographic area. With many endemic and endangered taxa, with 75% recorded extinctions after the European expansion across the globe. According to island biogeography theory, it predicts that larger islands should support more number of taxa due to higher habitat heterogeneity and niche availability, whereas higher spatial isolation from the mainland or from each other should limit the dispersal of species between them. Importantly, dispersal limitation not only influences the number of species, but it will also influence the composition of taxa. Therefore, neighboring sites are expected to be more similar to each other, resulting in distance decay patterns in community similarity. However, little is known about how these predictors influence the species assemblage on terrestrial islands, such as high elevation rocky outcrops, where along with distance, elevation serves as an additional barrier to dispersal. In addition, harsh climatic conditions such as strong winds, solar radiation, and seasonal water availability is expected to exert strong selection pressure on the plant species that inhabit them. And when these landscapes happen to be arranged along a latitudinal gradient, along with distance, the systematic variations in environmental conditions is expected to sort species based on their climatic preferences and thus influence species assembly. So this creates a unique scenario where dispersal limitation is expected to randomly structure the communities due to dispersal limitation, while environmental filtering is expected to structure the community along climatic gradients as per niche theory. However, the effect of these two processes often overlap and the relative importance of the two remains unknown. So to address this, we investigated the herbaceous flora of high elevation laterite plateaus in the northern Western Ghats. Here you can see the sharp cliff of the plateau edge, which creates a topographic discontinuity from the surrounding forest habitat, as well as the microhabitat heterogeneity, which is created during the monsoon season, and the landscape dramatically transforms into a mat of herbaceous flora, which is rich in ephemeral plant species and endemic taxa to these rocky outcrops. We sampled 8 plateaus spanning this north to south gradient, sampling once a month during the flowering season from July to October using 56 transects of 20 by 2 meters per census, where we recorded the composition and the abundance of flowering species. We detected a strong elevational and environmental gradient in the northern Western Ghats, where elevation of the plateaus gradually decreased from the north to south, as well as plateaus separated along the north to south gradient based on their environmental conditions. as we can record from the blue, green and yellow gradient. And in our floral surveys across 8 plateaus, we recorded a total of 93 herbaceous species from 58 genera and 32 families. And nearly half of which were endemic to the Western Ghats, and 33% occurred only on a single plateau. The species richness varied from 30 to 52 species per site, and this pattern of species richness was consistent even when the number of individuals was standardized in rarefaction. Importantly, richness did not vary with plateau area or elevation. We observed that community similarity displayed weak to moderate similarity, and with the highest dissimilarity between the northernmost and southernmost site, and overall the communities displayed high dissimilarity, most of which is explained by turnover, which is suggesting that while these plateaus may appear similar, they are actually quite distinct and support distinct localized plant communities. And importantly, the observed dissimilarities were only weakly correlated with geographic distance, and this pattern was again confirmed by a GDM analysis, where we saw that most of the variation in the community structure is explained by the environmental variables like elevation, solar radiation, precipitation, and geographic distance contributed only minimally. Similarly, in the RDA, you can see that communities are getting structured in the north to south elevation environmental gradient, and also with seasonal variations across the months from July to October. And when we partition this variation in spatial and environmental factors, we saw that environment explained most of it, which emerged as the dominant driver of species turnover. And this suggests that underlying environmental gradients are the key drivers of differences among these communities rather than dispersal limitation. With that, I would like to conclude that richness was not influenced by the area, and even the elevation of the plateaus. Composition was weakly correlated with distance, but strongly influenced by elevation, and our findings support a niche-based model of community assembly, where species are sorting along climatic gradients linked to latitude and elevation. So as a result, our study highlights the need to conserve these fragile and threatened habitats throughout the climatic and topographic range for safeguarding regional biodiversity, as species assemblages and the composition they are shifting systematically along these gradients across the northern Western Ghats. These are the references used, and I would like to thank the organizers of the IIT conference and the respective funding agencies, my lab members, and the other several agencies that have allowed me to do this work. Thank you.
Okay, thank you, Sukraj. It was a very unique presentation, especially in this session.
Yeah.
So good luck for a wonderful journey throughout your career, and keep it up.
Yes, thank you.
So it was excellent, really.
Thank you, sir.
The phytogeography and how the vegetation may change.
Yes, seasonally, yeah.
Nice presentation.
So thank you so much.
It's a good presentation, in fact. The plateaus you said particularly northern Western Ghats.
Yes, high elevation laterite plateaus, yeah.
So did you compare the mid elevation and the coastal level?
So the microclimate, we've already known from other studies that the microclimatic conditions of the low elevation plateaus is already very different from the high elevation plateaus. So that is why the taxa composition changes very dramatically if we take the coastal laterites.
But I'm not worried about the change in the floral diversity of various plateaus. What are the common species? There are many common species to all these plateaus.
Yes, some of
whichever
the species.
may be the elevation.
Yes, so this plateaus range from 800 to 1400 meters above sea level, and across these plateaus we saw that 20 to 30% taxa is consistently present across this range, such as Eriocolon, and we have impatient stomach.
You said environmental filtering, no?
Yes.
So
what that means is that certain species are restricted only to the northern plateaus, and while certain species are restricted only to the middle ranges, and certain are only found in the southern plateaus that will not be found there. Like for example, Chlorophytum belgamensis will only be found in Mangili, and we will not find that anywhere else. And similarly, we have taxa that is only found in the, like for example, Senecio grami, that is only found in Raireshwar but is not found in the south. So that is creating a distinction there.
I don't know, because did you go to Junnar or Durgavadi plateau? Or?
No, sir.
No. Because
so Durgamvadi, we explored it, but because it was very disturbed, we did not select it as one of the sampling sites.
Of course, it
So,
is very highly disturbed.
Yes, yes.
Only up to that village. Beyond that, it is not disturbed, but the
Yes.
vegetation is little different from the disturbed area.
Yes, sir. Yes. So we tried to avoid the disturbed landscapes as much as possible. So we did not sample from that plateau.
No, that will be interesting if you compare
Yes.
the
Disturbed
florist-
versus, yeah.
disturbed plateaus as well as
Right.
the plateaus at different altitudes.
Right.
And their commonalities, and why these commonalities when we say that there is
Right.
a ecological barrier.
Yes, yes.
So why, how these species could have migrated to
Yeah,
these
it would tell us what are the more robust species
Yeah,
that are even
exactly.
persistent in disturbed landscapes.
Exactly,
Yes,
exactly.
yeah, yeah.
Okay, fine.
Thank you.
Thank you, Dr. Sanjiva, for the comments. And the next speaker is Sunit Singh.
I had a question. Oh, we are moving on to the next.
Yeah, yes.
It's very well summarized. I like the way the floristic work has been sort of, you've given a nice summary including all of that. But isn't that what you expected? I mean, is
Actually,
it not something?
yeah, that is one of the most common argument. But I would argue that because these landscapes are isolated for such a long period of time, what we would expect is that spatial isolation is driving the differences among the communities. Because some of the studies have also shown very reduced gene flow between the plateaus. And so we would expect the isolation also to be one of the key drivers. So this study is actually establishing that despite strong isolation, spatial autocorrelation is not the one that's driving the differences, but it is the strong environmental differences that are shaping it.
I agree. I mean, there have been multiple in the Chinese Hengduan Mountains and, where
Yes.
isolations have been shown
Strong
to be
predictors,
strong
yeah.
predictors.
Right.
And then you have these environmental, variation of the
Because
latitude.
we have a landscape like
No,
that.
I'm just trying to, bring it down to that many of these phylogenetic, there's a study on the Western Ghats about the phylogenetic diversity. Maybe the next step is to sort of pinpoint what are these, groups of species which
Right.
have this phylogenetic diversity. What is the functional association between? Because this is kind of, taking you to the same place right now
Differently, yeah,
with
yeah.
whatever we know about,
Yes, yeah.
and not taking us further.
Yeah,
Just
I
that
get
much.
it. We are adding a layer of evolutionary
madam.
Thank you.
relationship. Yeah, thank you so much.
Okay,
Yeah.
okay, thank you. And the next presentation is on high altitude flora of the Western Himalaya by Sunit Singh.
Hello. Okay. I think it's fine. Okay. It's forward one now. Okay. Good afternoon all. Myself Smith Singh from University of Jammu. The title of my presentation is High Altitude Flora of Western Himalaya, Their Macrohabitat Diversity, Adaptation and Ethnomedicinal Prevalence. Here is about the study area. According to Mani 1978, Western Himalaya includes the Union Territory of Jammu and Kashmir, then Himachal Pradesh and Uttarakhand. Here in this picture, there is the position of timberline, alpine zone and snow line of the study area. Here are the vegetation types in the higher altitude. The major vegetation types are, first one are the birch or birch forest, then second one birch or rhododendron forest, then rhododendron scrubs, then dwarf juniper scrubs, alpine meadows, and then high mountain macrohabitats. Here are the macrohabitats of higher altitude flora. Firstly, timberline, then meadows, rock-associated species, marshes, stream banks, block fields, scree, moraines, fell fields, and talus. This is about the timberline and the meadows. Here you can see a clear-cut location of the timberline. This picture is from the Roopkund area of Uttarakhand. And it is associated with the alpine meadows. Alpine meadows are generally called as bhugyal in Uttarakhand because the species of Carex aspanki and Carex clavispica is associated with the habitat, and they are locally known as bhugi in Uttarakhand. So that is why meadows are known as bhugyal in the region of Uttarakhand and Jammu and Kashmir. In this picture here I am depicting the macrohabitats. The first marshes is here, then stream banks, boulder fields, block fields, then moraines, fell fields, talus slopes, and the scree. This picture is from the Padar region of Jammu and Kashmir. And firstly, the marshy habitat, as we all know that due to the melting of glacier, the water trickled down and they were spread on the flat surface. And this habitat is specially good for the growth of poaceae and the member of cyperaceae. On the base of accumulation of rocks, there are two types of habitats are there. One is boulder field and another one is block field. Block fields are generally in between the 4200 meter up to 4600 meter. There the moisture content is very insufficient there, so they supports growth of tiny shade-loving plants only. But in case of boulder fields, they are generally in between the 3000 meter up to 3800 meter. Moisture is sufficient in this kind of macro habitat, so that is why they support growth of several plant species as shown in the picture. Stream banks. Because of the water generally moving in these stream banks, the latent energy is produced, and so that is why early snow melt and late arrival of frost and snow cover is there. So that's why the growing season is longer as compared to the other macro habitats. And then moraines. Due to the shattering of the rocks in the higher altitude, the debris get deposited on the sides, on the edges of the glaciers. So they provides a habitat for the flora, which are generally called as the woolly flora. Then this is picture from the again Uttarakhand alpine lake, which we can say ponds. Then the fell fields. Fell fields are generally called as polar deserts because they are devoid of thick vegetation. They are extremely low temperature during the night and high temperature during the daytime. As we all know that in present days there is upward shifting of flora, and we all know that the glacial flora have a particular niche or specialized niche to grow. But this upward shifting of flora is creating nuisance for the glacial flora only. But in certain time the glacial flora can't go beyond the snow line. So that is why in nearby future there will be mountain top extinction maybe for the glacial flora only. Here are the highest flowering plants of the world around the snow line. The firstly is Susoria nymphalites, 6400 meter, then Stellaria decumbens, 6135 meter, Armeria himalayensis, 5800 meter, and we have collected Susoria ganophilides from 5100 meter, then Alardia glabra from 4950 meter, Susoria gossipiflora up to 5100 meter, then Sexifraga jacomontana from 5000 meter. Beyond this 5100, it is not easy for us to go for the further research. And here are the numbers which are restricted to the particular type of the habitats. In this picture, I have shown all the habitats. Then the faunal element which are associated with the high altitude flora, which we have captured during our study visits. Then the floral pollinators. As we all know that the large number of the Hindu deities in the Western Himalaya are located in the upper reaches, and most of the flora is associated with that deities, like Dolomia macrocephala, Susoria simpsoniana, Susoria ovulata, Hippolyta longifolia, Susoria gossipiflora, and then Juniperus indica. These are the medicinal plants of the higher altitudes. Some of the medicinal plants. Here how we collect the data from these kind of higher altitude. These are our camping sites, how we do this. And here are the outcome. Firstly, the research articles. We have published 2 new species to the science, one published, one accepted. From this particular type of habitats only. For the published one is Helichrysum imodi, then Bistotia coraceae is new record for India, one new record for Western Himalaya, Comostoma ornigera, then 2 new records for the flora of Uttarakhand, one published, that is published, one is the Pedicularis lentifolia, variety albida, then Comostoma pedicularis is recently accepted. And here are the screenshots of our recent publication from the particular type of habitats only. And this is our published book, which was recently published, but not yet released. Thank you.
So Sunit, it was a very excellent presentation on alpine flora and very special biogeographical region.
Thank you, sir.
So congratulations.
Thank you, sir.
Go ahead with good work.
Thank you, sir.
Really nice, and it is entirely different flora. You have shown alpine flora. How difficult to explore that.
Yes, sir.
Keep it up. Congratulations.
Thank you, sir. Yes, yes, sir.
See, if If you look at flora of British India, the highest altitude plant recorded, from the particularly Western Himalayas.
Yes, sir.
In flora of British India, not the Czechoslovakian publication, which I am talking
No,
about,
sir,
where it is 6,400 meters.
Okay.
The highest altitude recorded species is Trifolium cernuvum.
Okay, sir.
I don't know, I didn't see any photograph in this.
Okay, sir. Okay.
That is
Respected professionals and esteemed researchers, I am honored to be present a part of my research work entitled as Genetic Variability, Correlation Analysis and Selection Index in Cardiospermum helicacabum, accessions from Kerala, Implications for Medicinal Plant Improvement, guided by Dr. Cynthia Christopher, Center at Christian College, Katakada. Introduction. Cardiospermum helicacabum, commonly known as balloon vine, belongs to family Sapindaceae. It's a herbaceous annual climber in the traditional systems such as Ayurveda, Siddha, Unani, and in homeopathy. These are the significance of this plant. It is one of the member in Dashapushpa. These are the pharmacological potentials. Objectives. Identification of genotypes of Cardiospermum helicacabum occurring in Kerala. Assessment of intraspecific variability available in the gene pool of the species based on morphological characters. Methodology. Field survey. 68 accessions of Cardiospermum helicacabum collected from different ecogeographical regions of Kerala. Collection of planting material. Observation of the habitat, associated flora, and were gathered in the passport data sheet. Establishment of plants in the field gene bank. Establishment of plants in the Christian College, Katakada. Characterization of 6 agrobotanical traits. They are leaf length, leaf breadth, leaf area, biomass yield, epigenin, and gallic acid. Estimation of genetic parameters are GCV, PCV, heritability, genetic gain, and trait correlation. Estimation of selection index. It is used as to select superior genotype. D-square analysis. Mahlagobus D-square analysis revealed as genetic diversity. These are for identification of superior elite genotype. These are the model of plant collection data sheet. Morphology of Cardiospermum helicacabum. Result. 68 accessions of Cardiospermum helicacabum were successfully collected. 15 qualitative traits and 20 quantitative traits are seen. From this study, 6 major agrobotanical characters were selected. It is the genotypic and phenotypic coefficient of efficient, heritability, genetic gain. Genotypic and phenotypic correlation coefficient. Selection index for superior elite genotype identification. This is the cluster based on Mahalanobis D-square analysis. Discussion. GCV and PCV insights. GCV values were higher than PCV for all traits, indicating strong genetic variability. Biomass yield showed the highest GCV, 56.22, suggesting high selection potential. Heritability insights. Biomass yield, leaf length, and leaf area showed high heritability, indicating strong genetic control and selection potential. Genetic gain and selection potential. Biomass yield showed the highest genetic gain, 1.12, followed by epigenin and gallic acid, indicating strong potential for targeted breeding. Trait correlation insights. Significant genotypic correlation on percentage level observed among leaf traits, biomass yield, epigenin, and gallic acid. Selection index and breeding potential. Selection index ranged from 10.48 accession 68 to 5.56 accession 37, showing wide variation in trait performance. 6 accession 31, 52, 68, 9, 53, 29 showed high indicating superior genetic merit. Conclusion. GCV values exceed PCV across all traits, confirm strong genetic variability and scope for selection. Biomass yield emerged as the most promising trait with the highest GCV heritability and genetic gain. Epigenin and gallic acid content showed moderate heritability and high PCV, indicating environmental influence. Significant genotypic and phenotypic correlations among key traits suggest coordinated expression and co-selection potential. Selection index analysis identified 6 allied accession 6831 with superior multi-trait performance. Mahalanobis D-square analysis revealed 12 genetically diverse clusters with accession 68 forming a unique solitary group. Intra-regional diversity and non-geographical clustering patterns highlight the role of micro-environmental factors. References? Thank you.
Okay, thank you, Vijita. So now the presentation is open for discussion. Any comments or any suggestions from the audience? Okay, Vijita. Please carry on with you.
Thank you, sir.
So we have finished the session with 21 presentations, and interestingly, the topic is that much variant with maximum variability and diversity in content. I congratulate all the persons who are presented. Most of them are very excellent presentations. So thank you very much for the patient listening, and move on to the conclusion.
With that, we conclude the oral presentations for the theme Floristic Diversity and Biogeography. I thank all participants for their wonderful presentations. May I now invite Dr. Kanad Das, Director, Botanical Survey of India, to felicitate Dr. Matthew Dan, Dr. S.S. Hamid, and Dr. Sandeep Kisan Gavade, who graciously chaired this session. Thank you, sir. We will now break for lunch, which is arranged at the dining area. We request the participants who are presenting for Theme 9 to return promptly, as Technical Session 12 will begin at the scheduled time. Thank you once again.
അപ്പൊ പൈസ ആരടക്കിയ അത് അനക്ക് പടക്കി അതിന് ഉപ്പാന്റെ അടുത്ത് പൈസ കൂടുതലൊന്നും ചിന്തിക്കണ്ട. നമ്മളിപ്പോ കറണ്ട്
കറണ്ട് ബില്ല് അടക്കണില്ല, ഗ്യാസിന് പൈസ കൊടുക്കണില്ല. ഇതിൻ്റെയൊക്കെ പകുതി പൈസ മതി ലോൺ തിരിച്ചടക്കാൻ വേണ്ടിയിട്ട്. പിന്നെ ബാക്കി പൈസ എന്താ ചെയ്യുന്നത്? നിന്റെ കല്യാണത്തിന് വേണ്ടിയിട്ട് ഞങ്ങൾ ഫിക്സഡ് ഡെപ്പോസിറ്റ് ആക്കി.
ഉമ്മ പറഞ്ഞു വിചാരിച്ചിട്ട് സീരിയസ് ആവണ്ട. ഞങ്ങളെ നാളത്തെ ജീവിതത്തിന് വേണ്ടി സമ്പാദിച്ചിട്ട പൈസ അല്ലേ
ഒരു ഓർബിറ്റുമായി.
ഓർബിറ്റ്
അറിയോ?
എനിക്കറിയാലോ, ഞാൻ സോഷ്യൽ മീഡിയയിലൊക്കെ കാണലുണ്ടല്ലോ.
എന്താ കാക്കോ, കുട്ടികൾക്ക് വരെ അറിയാം നമ്മൾ ഓർബിറ്റ്.
Orbit. Energize your future with solar power.
has been for me an amazing experience to be invited to visit, inaugurate, and tour the Devagiri College Library in its newly renovated incarnation. Student days have been to dozens of libraries around the world, but I've never had the pleasure and privilege of stepping into such a lovely library and being able to study. My congratulations to all the students who by luck or timing or desire or decision find themselves in Devagiri as this library comes into play.
അപ്പൊ പൈസ അടക്കിയ കൂടുതലൊന്നും ചിന്തിക്കണ്ട. നമ്മളിപ്പോ കറണ്ട് ബില്ല് അടക്കണില്ല, ഗ്യാസിന് പൈസ കൊടുക്കണില്ല, ഇതിന്റെ ഒക്കെ പകുതി പൈസ മതി ലോൺ തിരിച്ചടക്കാൻ വേണ്ടിട്ട്. പിന്നെ ബാക്കി പൈസ എന്താ ചെയ്യുന്നത്? നിന്റെ കല്യാണത്തിന് വേണ്ടിട്ട് ഞങ്ങൾ ഫിക്സഡ് ഡെപ്പോസിറ്റ് ആക്കി.
സീരിയസ് ആവണ്ട, ഞങ്ങളെ നാളത്തെ ജീവിതത്തിന് വേണ്ടി സമ്പാദിച്ചിട്ട പൈസ
ഒരു ഓർബിറ്റ് മതി. ഓർബിറ്റ് അറിയോ? എന്താ കാക്കോ, കുട്ടികൾക്ക് വരെ അറിയാം നമ്മൾ ഓർബിറ്റ്.
Orbit. Energize your future with solar power.
Welcome back. We are ready to explore Theme 9, Plant-Animal Interactions in Ecosystem Dynamics. And we will begin with an invited lecture by Dr. Shweta Subramaniam on extraflora nectaries and their strategic positioning. The lecture will be followed by oral presentations. May I request Professor K. Kotresha, Professor, Karnataka University, Dharwad, Dr. Aparna Vadve, IUCN SSC Western Ghats Plant Specialist Group, and Dr. Muhammad Nisar VA, Scientist, ICR Indian Institute of Spices Research, Kozhikode, to preside over the session.
Thank you, Madam. I invite Shweta, please come on the dais. Shweta Subramaniam, she is a assistant professor, Department of Botany, and Guru Govidas Vidyalaya, right, Bilaspur, and she is the next host for IIT. That you have to keep it in your mind. Okay. Then, of course, she completed her MSc and PhD from Delhi University, and she got the gold medal. Okay, she's a gold medalist, and working on systematic evolution of biogeography of genus Crotalaria. During that time, I hope she visited Sandur, because there is one species, Crotalaria sandurensis, right? So I know that. Then she published several papers in national and international journals, and she got 2 patents, right? So at this young age, she already acquired 2 patents, right? Then, and she had a grant of 10 lakh rupees for her research work, and further, I mean, addition to that, she is awarded IIT, of course, Anthony Mukherjee Medal, and also K.S. Manilal Award. And at present, of course, she is working on nectaries in plants with field observations, right? So little bit she deviated, of course, because of Crotalaria, she see that, and the bees and butterflies, they are visiting to the Crotalaria. There may be, her mind may be little bit deviated to that, and she is selected. Please, madam, please come on to dais, right? So this is her brief introduction about his caliber or candidature. Thank you. Madam, can you start, right?
Hello. Yeah. So, presentation. Thank you so much, sir, for the very nice introduction. I'm humbled. And I started my actually research career and my research passion with the systematics of the genus Crotalaria, wherein I collected almost 95% of the species diversity present in India. And further, to elucidate the evolutionary relationships, we dived into a bit of phylogenetics. And then further, we dived into anatomy and other realms of systematics, which helped in reclassification of the genus based on a biosystematic approach. So, yeah. So, I have got a lab a small lab in my Central University of Bilaspur, Chhattisgarh, wherein my scholars, I've got 4 scholars who have just recently joined, and they have just dived into this component of floral and extrafloral nectaries. We usually associate Darwin with finches, but seldom we know that Darwin was much fascinated by a plant called as bullhorn acacia, now in the genus Washelia, and he observed that there are these armies of ants which are nested inside the swollen thorn of this bullhorn acacia, and as soon as any insect comes and tries to attempt a phytophagy, these armies of ants immediately come out of those thorn and attack. So Darwin once told that this is an excretory structure, but after when he saw this plant-insect alliance, he said that this is one of the most astonishing and fascinating alliance he had ever seen. And today we know them as extrafloral nectaries. So moving on with the presentation, before I start my presentation, I would like to pay my respects to my guru, because of whom I'm standing here. What I'm today is because of him. So, okay, let us talk about floral and extrafloral nectaries. So, floral nectary is a component, both of them are actually sugary liquids, which have got very high sugar concentration. And floral nectaries basically play a major role in pollinating systems, pollinating mechanism. So they are sugar-rich viscous liquids which are produced by plants which are basically required for pollination. But on the other hand, there are these structures which are present apart from the flower and which are classically distributed all over the plant body. You take, for example, leaf tips, you take leaf margin, you take the midrib, you take secondary veins, you take petioles, you take fruits. Everywhere they are distributed, but they are species specific. So these structures are again sugary rich viscous fluid, but they are called as extrafloral nectaries because they are away from the flower. Linnaeus introduced this term. Linnaeus introduced this term in 1735, and Darwin in 1859 actually mentioned it as an excretory organ. But Del Pino, when he was working on some plants in 1888, he countered this and said, why the plant would trade off so much of energy, and why would it trade off its energy in wasting and producing a sugar-rich liquid? That will function as excretory system. So then came the era of floral and extrafloral nectaries, and the major evolutionary dilemma which my research team is investigating as of today is how can a plant position these extrafloral nectaries so that ants provide effective defense without compromising on the photosynthesis, without compromising on the nectar stability or pollination efficiency. So is it an evolutionary dilemma or is it an adaptive precision? That's the question we will be answering. So according to Angiosperm phylogeny group, as of 2009, we have got 3,000 species. The number has raised now. It is approximately 4,352. And Weber and Keeler in 2013, they accounted that 30% of the EFN bearing species are restricted to the legume family. Again, I started with legume and I'm continuing with legume, but the perspective is different. So we just started to move around in Chhattisgarh with my team, and we saw that the forms, the shape and the diversity of these extrafloral nectaries, it varies considerably. So we can have a pit shape, we can have button shape, cup shape, pore shape, slit and stalk, depending upon which place or the plant organ body it is present on. So we did a review of literature. We actually collected the literature starting from Darwin in 1859 till 2024 December. We collected all the, we read all the review papers and the original research papers which have been published in EFN, and we plotted a graph which shows that 928 species having EFN are restricted solely to Fabaceae, followed by Passifloraceae and Malvaceae. So maximum number of EFN inhabiting species are present in the legume family. Then we found out, we zeroed in on 22 positions of EFN over the entire plant kingdom, that there are 22 positions in the plant body where the EFNs can be found. So we plotted a graph for the same, and we found out that this petiole, the leaf petiole, followed by the lamina, occupied the highest percentage of EFN carrying species. Of course, followed by there are other organs also, but their prevalence is very less as compared to the petiole and the leaf lamina, adaxial and abaxial side. We then correlated, and we did what we did was we collected the universal sequences of all the angiosperms with and without extrafloral nectaries. We downloaded the MATK and RBCL sequences, and we reconstituted the entire angiosperm phylogeny based on MATK and RBCL. And we did a dated phylogeny, And over that dated phylogeny, we did an ancestral state reconstruction, which actually, in which we wanted to know that what was the trajectory of the evolution of the presence and absence of extrafloral nectaries. And to our surprise, we found that the Amboralaceae and the Anna group, Nymphaceae and Austrobalaceae, they didn't had extrafloral nectaries on those primitive clades. But the first origin point of the extrafloral nectaries was within the magnolid clade, and you will be surprised to know, and the maximum diversification of this extrafloral nectary, it happened in the rosids. But the ancestor to the rosid was again lacking these extrafloral nectaries, which shows that it's not a homologous trait, but it's a multiple gain and loss of this trait over independent lineages, pointing out to a convergent evolution. So when we see that, when we see the dated phylogeny, we also noted that the ant diversification, the insect diversification, and the rosid clay diversification, they all go hand in hand parallelly, pointing out to the dynamics between the tritrophic level of the plant-insect interaction at the pollinators and ant level. So these accumulation of the review of literature and the ancestral state reconstruction pointed out a solution to this evolutionary dilemma. So what was the solution? So EFNs, if the EFNs are present on the underside of the leaf, so the advantage is that it has got a continuous supply because it will be directly connected to the mid vein or the secondary or tertiary veins. But there will be a disadvantage. The disadvantage is that there will be a risk of dripping due to gravity. Second, if the EFNs are present on the underside of the leaf and the ants would go on the underside of the leaf, they'll get unnoticed by the herbivores. So to provide a solution to this evolutionary dilemma, plants evolved, and you see that all these structures which are present on the petiole EFN, they're all present in advanced clades of rosids. So the plant evolved a solution to this evolutionary dilemma by placing the EFNs on the petiole. So what are the advantages of the petiole? The first one is, if the EFN is present on the petiole, it will not impede the photosynthetic activity of the plant. Second, it will have a direct contact with the vasculature of the petiole. So continuous supply of sugar-rich liquid will be present. Third, it will be easily accessible to the plants, and it will be easily detected by the herbivores which will be present there. And fourth is that it will not impede the photosynthetic activity, and it will not dry up because it is in direct contact with the major petiole vasculature. That's the phloem. So once this paper is under revision in a journal called as Biological Reviews. So we are expecting a result soon. So one of my dissertation students, he picked a genus called as Helictris isora. It belongs to the family Sterculiaceae, and it's very common there in the central Indian part. So we saw that there are two different kinds of flowers in Helictris isora. One is green and one is red. We previously thought that there are two different kinds like we see in lantana. So we thought that, so my students, they went for an observational trip, and they stayed there overnight for 24-hour cycle of observation. And what they saw was that they bagged the flowers. They saw that morning 3 o'clock, the anthesis happens. When morning 3 o'clock, the anthesis happens, the flower color, the flower which bloomed was green in color with nectar completely filled. The nectar was completely filled in the morning when the flower color is green. So exactly after 12 hours at 3 p.m., the transition phase happens and the flower gradually, it changes its color to red. And finally, the next day, this flower completely withers off. So this was a transition in the floral color of Helictris isora. Actually, it was not two different kind of flowers which are present on the same plant, but it was the transition of the same flower in a diurnal pattern. So what we did was, we collected the nectar. We observed this plant for approximately, we did for 120 days, 4 months. What we found out was, I need to play this video. I want to play this video. This one, double click. No, not that one, that one, yes. So I'll just speak till then they find out the video. We saw that in the morning 3 o'clock, there was a sunbird. It's a rumped sunbird. We thought that it was going to pollinate the flower, but actually it came and it very nicely robbed the nectar. So these are actually called the nectar robbers. So these, what? Yeah, not this one, side robbing. Yes. Yeah. So you can just watch this video before I start. These sunbirds, they very nicely rob the nectar. So we thought the plant has traded off so much of energy in producing this full cup of nectar and it is getting robbed. So yeah, you can see. And none of the reproductive parts will touch its body, you see. And it very peculiarly, it comes to the green flower and robs and goes. None of its body part will touch. Not the anther, nothing. Very cleanly it robs the flower with its nectar, out of its nectar. Yeah. So what we did is, once the nectar was robbed, we bagged the flower. We wanted to see what the flower will do next. Immediately within 4 hours, the entire floral cup was again filled with nectar. And this time, the nectar volume and the nectar concentration concomitantly increased. So before the robbing experiment, the nectar volume was approximately 70 average, and the nectar concentration, I don't remember, so there's a graph. Concomitantly, the nectar volume increased to 110 microliter, which was statistically very significant increase. So what we were thinking, that actually this robbing, it provides or sends a negative feedback loop, but instead it is sending a positive feedback loop, following which the original pollinator, that is the purple sunbird, came and pollinated the plant. So then we thought, and once the flower changes to red, the nectar production stops. The floral nectar production stops. So we wanted to see if there are some anatomical changes which are happening in the floral nectar glands. So we then did a hand sectioning, and we saw that when the flower is green, we have got these schizogenous cavities lined by this glandular cells epithelial lining. And once the flower turns red, all these cells are filled with parenchymatous cell. So the nectar glands have stopped to work. Then the flower is not producing the nectar because the red color flower indicates that either it has been pollinated, so it is no more actually going to produce this floral nectar or the extra floral nectar. Then we wanted to analyze the extra floral nectar. In Helictrus isora, the extra floral nectar is present on the pedicel. It's the stalk of the flower. So it's a pedicelllar extra floral nectar. So in the pedicelllar extra floral nectar, we found that we did a hand section of the different developmental stages, and we found that it's a vasculature extra floral nectar, wherein the main connection of the pedicellar phloem gives the nutrients and the sugary substance to the extra floral nectar in its active stages. Once the flower stops producing the floral nectar, at the same time, the vascular connections are broken up in the later stages of the EFN production. So it ceases. So this is the pre-developing stage of vascular connection. This is the developing. These are all developed vascular connection, and at this stage, both the floral nectar and extra floral nectar work in parallel to produce these sugar-rich substances. As soon as the flower color changes to red, the floral production, nectar production also stops, and the extra floral nectar production also stops. So we studied the insect diversity and we got it identified from Zoological Survey of India. We did some qualitative tests on nectar composition, right? And then we actually got an average of the volumes before and after robbing and concentration before and after robbing. So you can see that the volume of the floral nectar before robbing is very less as compared to the volume after robbing. Same goes with the volume of the concentration of floral nectary before robbing and the concentration of floral nectary after robbing. So this was a statistical increase. This was a significant statistical increase in the nectar volume and nectar concentration before and after robbing. We then analyzed the composition of the insects as well, and we found that when the flower is green, these insect diversity is very high at the extrafloral nectary as compared when the flower is red. So the extrafloral nectary is actually there to divert those insects away from the floral nectaries. So it's a kind of what is called as a decoy nectar hypothesis, where the EFNs are produced so that the insects and the other ants, they don't interfere with the pollination mechanism of the flower, and they don't actually deprive the flower of its nectar, floral nectary. So these are the graphs over an average of over 120 days, wherein they saw that this floral nectary is present, and this is the pedicelllar extrafloral nectary, which are very active during those during the stages when the flower is green and it is ready for pollination. But as soon as the flower turns red and the EFN also stops producing this extrafloral nectary, the volume and the concentration concomitantly decreases in both the cases. So the conclusion is that the plants have positioned the EFN depending upon the ecological or the functional pressure which they have to address. So in this case, the pedicelllar EFN is present just to actually deviate the ants away from the floral nectars to keep the floral nectar intact. So in second case, we took a plant example of Lucena leucocephala, wherein we compared this plant over two sites. So these are the positions of the EFNs which are present. We compared the plants in two sites. One site we have got 10 trees, and the other side we had got 10 trees. We have zeroed in two sites. And in one of the sites, we did an intentional grazing in a time-dependent manner. So we had a temporal distinction. And in other site, we didn't allow the herbivores to actually come and graze the plant, those 10 trees. So we have got one is that the grazing site and the other is the non-grazing site. In the grazing site, and we did an observation for 6 months, regular observations of 24 hours, because the time taken for the nectar cup to fill is actually 3 hours. So we did an anatomical section of, hand anatomical section of the extrafloral nectary. So this is the extrafloral nectary of Lucena leucocephala. This is the petiolar nectary. So here the nectary is not present on the pedicel, but here the nectary is present in the petiole. So there is a different ecological and functional pressure which the plant has to cater to. So we see that in this, so we see in this area, this is the cross section of this is the longitudinal section of the EFN, and this is the cross section of the petiole. So we see that there are three phases. We have got a secretory phase, we have got a subsecretory zone, and we have got an intersection zone. And these zones become active only when the side rachis phloem gets in continuation with the extrafloral nectary to make them active. So we did a developmental anatomical stages, and it's the same as we saw in Helictris. So at the time when the EFN is active, the phloem connections are active. Once the leaf is abscised, the phloem connections to the petiole are disrupted. What we saw in this grazing and non-grazing site was when we grazed, we did an intentional grazing in 3 different time intervals, one in the morning and 2 time intervals in the evening. We saw that immediately after the grazing, the volume and the concentration of the EFN, it concomitantly increased. So the first graph shows that the EFN volume, average EFN volume collected over a period of 6 months. Average EFN concentration collected over a period of 6 months, and this is the insect diversity. So this is actually a classical example of a secondary defense mechanism which the plant is showing. We know about jasmonades, but this is one in hand which the plant has, wherein the plant is undergoing this immediate action, wherein when the phytophagy happens, when the intentional grazing happens, these extrafloral nectaries are produced and they increase in the volume and concentration so that more insects can come and start drinking the nectar, which will deter the herbivore. So this is an immediate indirect defense mechanism which the plant shows. And we for the first time proved it, and this paper is now accepted in the journal NBIS. So these are some of the insect diversity and plant-insect interactions we saw in Lucena. We created a heat map to show the relevance. We did a correlation and regression matrix to show that whether the difference between the grazing and non-grazing side and the difference between the intentional grazing time and the non-intentional grazing time are significantly different or not. And we found out that they are significantly different from each other, indicating that there is a biological phenomena underlying it. So this is a correlation map, and we did an ANOVA to prove the same, and we found out that there is a significant difference across both the time intervals. So these are the conclusions which I've already told, and that's all from my side. And this is my PhD dissertation team who visited BSI, and that's all. Thank you.
Thank you, madam. Thank you for well within time you completed. It's open for discussion. Anybody is having 1 or 2 questions you can ask because of paucity of time.
Actually, I have seen lots of glandular hairs on the jatropha stem, sepals, but these nectaries and others, they are not present inside the flower. And I found lots of insects, insect carcasses, they were present on the glandular hairs. So how do you explain the evolution of these insectivorous plant like Drosera and the evolution of nectary through these lines? Is there any correlation?
Of course, as far as extrafloral nectaries are concerned, it shows a very convergent pattern of evolution because it's a repeated gain and loss of the same character again and again without being accompanied by an ancestral state of presence of extrafloral nectary. But as far as the glandular trichomes are concerned, they are not vascularized DFNs. Trichomes are present and they are actually epidermal in nature. So those glandular hairs are supplied by the cells which are present underneath them. Vascularized DFNs have an advantage of having a continuous supply. As far as the evolutionary scenario is concerned of them, the glandular hairs and extrafloral nectaries can be present on the same plant. It's present. For example, you can take the case of Gossypium. So in Gossypium, you have got hairs as well and you have got the nectaries as well. So, and maybe we have not studied the evolutionary pattern of both of them. Maybe we will look into it and then I'll get back. So that's all.
So one question from my side. Since you are seeing the petal color changes, is it not because of the pollination, pre-pollination, post-pollination? Most of the flowers, they change the color.
It is that. It is because of that only.
Not only honey.
Not only?
Honey, your nectar.
Nectar.
Yeah.
No, that is because of the pollination. The pollination has happened. That is why the honey is not being produced.
Okay.
It's the other way.
No more questions? Okay. Thank you, madam. Thank you for your nice presentation.
Thank you, sir.
Right? And befitting in time and other things.
Thank you, sir.
Right. Thank you.
A huge thanks to Dr. Shweta for an absolutely captivating lecture. Your lecture provided a truly valuable and detailed perspective on the crucial ecological mechanism. Thank you, ma'am. May I request Professor Kotresha and Dr. Muhammad Nisa to present a token of appreciation to Dr. Shweta Subramaniam. We will now commence the oral presentations for Theme 9, Plant-Animal Interactions in Ecosystem Dynamics. I also invite Dr. Aparna Vatwe, IUCN SSC Western Ghats Plant Specialist Group to join the chair.
number 1 is already uploaded. Yeah. This is Bhavana.
Good afternoon all. Welcome to my presentation on the topic foraging behavior of Megachila conjuncta on Dendrolobium umbellatum. The plant-animal interaction or the plant-animal associations is a diverse range of relationship between plants and animals from mutually beneficial partnership to antagonistic conflicts. And here my study explores an interaction between Dendrolobium umbellatum and a leafcutter bee. The Dendrolobium umbellatum is an ornamental plant belonging to the family Fabaceae. It is also known as golden legume plant. And the leafcutter bee, they are solitary bees, belong to the family Megachilidae. It's a cosmopolitan family of bees. And a unique feature among these bees is the ability to cut and process the fresh plant leaves. And these bees are connected with this plant through their cutting behavior. They used to cut the leaves of Dendrolobium umbellatum. And these are my objectives of the study, systematic studies on the interaction between Dendrolobium umbellatum and the leafcutter bees, and the investigation of the nesting habits and foraging behavior, and the phytochemical analysis of Dendrolobium umbellatum leaves. And these are my materials and method. I selected 6 plots in the University of Calicut campus where the Dendrolobium umbellatum is grown, and observe the activity and presence of these bees in this area, and also observe their presence and activity in other plants in this area. In nesting site, they usually nest in pre-existing cavities. So as the difficulty in finding out their natural nest, I provided some artificial nests like bamboo stems, and also the identification and preservation of bees, and herbarium preparation and illustration of bees and the plant are done, and analyze the pollen grains and the leaf chemistry. And I also observed some similar patterns of cuts in some plants of Cassia fistula and Rosa chinensis. And this is the video showing their cutting activity. Moving to the result and discussion of the study, this is the morphological study of the plant. I observed 2 leafcutter bees in this field belong to Megachile conjuncta Smith, and they are about 1.5 centimeter in length. They have the strong 4-dendate cutting mandibles and a long proboscis for nectar collection. In the lack of pollen baskets, they have dense pubescence in their abdomen to collect the pollens, and their activity is observed in the field in the daytime between 11 a.m. to 1:30 p.m. and the pattern formed in the leaves by their cutting is a characteristic, and they used to cut the leaves in oval and round shape, and on landing on mature leaves, they began to cutting along the edges of the leaf. Their mandibles are anchored onto the leaf lamina and slice like a scissors. This process takes only 18 seconds, and after cutting, they grabs the leaf fragment by their leg and carry it to the nesting cavity. In nesting, they usually nest in pre-existing cavities. Their nests are sub-cylindrical in shape, composed of 4 to 5 brood cells. And in this first, they collect the oval leaf fragments and arrange them in an overlapping manner, forming a cup-like structure. After that, they onto it, they stack the round-shaped leaf fragments and forming the cap of the cup. After weaving the net with the oval-shaped reef fragments, they deposit a pollen mass and lay one egg on it, and the larvae feed upon this pollen mass. But they didn't observe collecting the pollen grains of these plants, so I analyzed the pollen grains. And this is the SEM images of the pollen grains collected from the Dendrolobium umbellatum plant and the collected from the nest. And also in GCMS analysis of leaves, 9 compounds are detected, and most are linked to insect attraction. And which is the conclusion of the study, Megachila constricta exhibit selective foraging behavior. They preferably choose mature leaves of the plant. And its visit to this plant only need to collect the leaf cuttings only, rather than mutualistic pollination. But the other hand, they have aid in collect pollen grains from other plants, may aid in the pollination of that plants. And these are my acknowledgement, and thank you.
Thank you. Any questions from audience?
So this you have observed in cultivated populations, isn't it?
Yes.
In your campus?
Yes, sir.
There are naturally occurring the Desmodium Dendrolobium umbellatum in, along the coastal area.
Yes,
This is a coastal area plant, basically.
It's an ornamental plant. It's the wild variety may contain this.
That's what I am trying to tell you. You have to make observations in the wild plants also,
Okay,
because this is a cultivar,
yes,
ornamental cultivar.
Yes.
So you make observations. And what is the role of these leaves? Only for nesting, or is there any other purpose?
Only for nesting.
Sure, I don't know. Why they choose? They are obligatory on this Dendrolobium, or they take the leaves of other plants too? But because you showed Cassia fistula is another plant where they cut the leaves. So what do they do with those leaves? In your analysis, because you analyze the nest.
Yes, sir.
So nest contains only Dendrolobium umbellatum leaves?
Only Dendrolobium umbellatum.
Then why do they cut the other plant species? No, you should look for those things. Because there may be a compound which is essential for the growth of the pupae and other things, particularly caterpillars, or egg development and all those things. So if you connect those things, it will be very useful. Thank you.
If there is no questions, thank you. Thank you. Next presenter, that is Chinmaya. Chinmayi.
Hello. Oh.
Good afternoon, everyone. I am Chinmay Goswami. I am recent master's graduate from ISER Bhopal, and today I will be talking about our study on floral constancy in Indian Himalayan bumblebees. The floral constancy is tendency of an individual pollinator to focus its foraging efforts on just one or a few types of flowers during a foraging trip, even when other equally rewarding floral resources are available. It is important to understand floral constancy because it increases conspecific pollen transfer, thus ensuring high reproductive success in plants. All the pioneering studies in floral constancies come from European region, while little is known in the Indian context, especially in biodiversity hotspots like Indian Himalayas. In the light of current climate change crisis and increase in anthropogenic disturbances, it is very important for us to understand how these landscapes are evolving and maintaining its diversity. One of the processes is pollination. Coming back to floral constancy is affected by multiple factors like floral rewards, floral functional traits, and floral community structure, in turn floral abundance and floral diversity. Floral abundance produces strong signal which reinforces learning. Thus, we expect with increasing floral abundance, constancy to increase. But floral diversity provides many choices which challenges bees' memory. One hypothesis is with increasing floral diversity, the floral constancy should increase. But some recent studies also hypothesize that it should decrease because bees also can optimally forage in these diverse habitats, exploring various resources. So to understand all this knowledge and to bridge the knowledge gap, we ask what is the effect of floral diversity and abundance on the floral constancy in Western Himalayan bumblebees. We chose 2 field sites in Uttarakhand, Mana Valley and Madmaheshwar Bugyal. This hosts seasonal herbaceous flowering communities. Some of them are listed here. And we observed 48 species across 23 plots from 2 sites. And bumblebees were major pollinators. Here we observed 2 bumblebee species, which we are currently identifying in the process of identification. To have a broader perspective, we integrated behavioral observations with pollen analysis, which tell us about the outcome of foraging behavior. Here we observed 171 foraging bouts across 21 plots and calculated constancy index, which ranges from 0 to 1, where value 1 being absolute constancy. Floral surveys were also conducted in the same plots for floral abundance and diversity analysis. We analyzed 40 pollen load samples, which we have already observed the foraging sequence for, and identified pollen grain from pollen reference library. Coming to the results, here in the first graph, as you can see for both the bumblebee species on both the sites, all the values are accumulated in the upper limit. That shows that Himalayan bumblebees are highly constant. It also shows for the bumblebee 1 species which was present on both the sites, the floral constancy varied across 2 sites. But when both the species co-occur together on the site 2, they exhibited similar floral constancy. It also gets reflected in the pollen load profile. Thus, we can say that floral community structure shapes constancy. To explore this further, I conducted GLMM analysis between floral diversity and constancy index, as well as floral diversity and pollen proportion. Here we see that as diversity increased, constancy is decreased, and thus dominance of one species is also decreasing pollen load. This tells us that diverse patches promote opportunistic foraging. Next, as we can expect that with increasing floral abundance, constancy should increase. This is exactly what the results are saying. With increasing abundance of flowering species, constancy on it increases. This resulted in significant increase in the proportion of pollen load. Thus, locally, the most abundant plant species increases constancy of bee on it. To summarize, in high diversity habitats, bees are switching more, thus reducing floral constancy and carrying more heterogeneous pollen profiles, which may increase heterospecific pollen transfer and reduce plant fitness. While highly abundant plant species, bees are foraging with more constancy. Thus, it may increase conspecific pollen transfer and increase plant fitness. This study also shows that pollen load analysis is a robust method to study floral constancy along with the behavioral observations. With this, I thank all the T-Lab members, people of Uttarakhand, my friends and family, and IIT 25 organizers, volunteers, and committee members for providing me this opportunity. Thank you.
Any one questions from audience? Sir, please.
You have used much of graphics.
Thank you.
But what about even for field work and lab work? You could have shown some of the pictures you have done the work in the field and things like that.
Oh, okay.
Instead of, completely it is a graphics, so it is better to avoid.
Okay.
You should use to enhance your presentation, but what did you do in the field? That will add value to your, whatever you say.
Okay.
All the best.
Thank you.
Thank you, Chinmay.
Okay, sure. Okay, sure. Thank you.
Next presenter, Devendra.
Will it? Good afternoon to one and all present here. I am Devendra Solanki from the Maharaja Sayajirao University of Baroda, and today I am going to present on the topic understanding pollination biology through pollinator activity and interaction patterns. So first I will start with the introduction. So pollination biology is best understood by examining how different insects interact with the flowering plants, and for that I have chosen Vitex nigundo that served as a focal species in my study, and I have observed a diverse community of 8 bee species, 7 butterfly species and 2 moth species. So this is my methodology. First is the field survey I have conducted. So I have observed pollinator behavior on the riverbank of Vishwamitri, and second is diversity documentation. I have recorded bees and butterfly species that are visiting on the Vitex nigundo. Third is the temporal analysis, that is I have tracked the timing of pollinators in a day and the visits, the number of visits, and the fourth one is the behavioral analysis. I have documented the behavior, like is it for the pollen collection or the nectar foraging activity. So first I'll start with the basics. I have put up an external morphology of bee and a butterfly. So their body is divided into a head, thorax and abdomen. That is the basic. And in bee, if you will see, the proboscis is very short. And in butterflies, the proboscis are comparatively very long. Because butterflies mainly feed on nectar, and bees have a special structure called as pollen baskets. But not all the species have pollen baskets. There are specific families and genera that have pollen baskets for collection of pollen grains. And you can see there are hairs on the body of a bee, and not every bee has those hairs. So this is specifically evolved for the collection of pollens and for the cross pollination. So here I have put up a table that the recorded bee species that I have observed. The majority of them belongs to the Apiidae family. There are 4 individuals named as Emegala zonata, Apis dorsata, Ceratinus magdula, and Thyrus historia. Megachalidae is the second family, and Halictridae, that is the third family. And I have put up there the feeding and foraging behavior, for what purpose each of the individual comes. And on the last, I have put up the special morphological features. Like I'll just show that this is, and here I have put up different colored the activity, for showing the activity in the entire day. For the orange color shows here the high activity. Blue color shows a moderate activity during the day, and the white color shows low or no activity during the day. So I have observed at certain intervals, like 8 to 10 a.m. I have observed in the morning, 12 to 2 a.m. I have observed in the afternoon, and in the evening 4 to 6. That is how I have divided the timings. So what I have observed is this blue banded bee, also known as Emegala zonata. This is one of the it has a very high activity all in the morning, afternoon, and evening. And the number of individuals that I have observed, there are on the Vitex, that is the most of this species. And this has a very special capability of, or a technique you can say, that is called buzzing ability, or buzz pollination you can say, or sonication. That is how when a bee visits a flower, it grasps the anthers of that of Vitex, if I say, and then the contraction of its thoracic muscles, it does the contraction, and high frequency vibrations are created with that, and that is how the pollen comes out from the anther, and it gets stick to the hairs of the bees, and that is how the cross pollination happens when it goes to the other flower. So the thoracic wing muscle specifically plays a role So the contraction it does, but without flying, that happens, the contraction. So this is a special ability of this bee. And the small carpenter bee, it is a very small sized bee that visits a very small flowers. Then the third one is a giant honeybee, that is also called as Apis dorsata. Apis dorsata has a very specific feature, that is corbiculae. Corbiculae, that is the pollen baskets they have in which they collect the pollens. And this cuckoo bee. Cuckoo bee doesn't have hairs on their body, so it mainly visits for the nectar purpose. And same for the sweat bee. And these are the other bee species that I have observed. These are the 3 species of leaf cutter bee. Leaf cutter bee only cuts the leaf of the vitex, and for the nectar for robbing the nectar they comes here. There is no such evidence as they are taking the pollens. And these are the butterfly species that I have observed. These are the photographs that I have put up. It is on the time intervals. You can see this mottled emigrant, common jay. They have the same mostly morning activity they show, the high morning activity, and then it decreases gradually. And evening they have a moderate activity. Afternoon it is very low activity. And here there are 2 moth species. You can see that in the evening they shows a moderate activity, but in the morning and afternoon they doesn't show that. It shows a very low activity. And all these butterflies and moths, they come on the vitex flower for just for the nectar purpose. And they might carry pollen on their proboscis, but that is a chance event. But majorly they come for the nectar. And these are the key takeaways. So family-wise distribution of butterflies I have put up. So Piridae family I have found the most members, and same for the bees. That Apiidae family I have found the most members. So this study, it highlights the importance of diverse pollinator communities that are visiting Vitex nigundo, and it demonstrates how bees and butterflies and moths collectively supports its reproductive biology. And this interaction, it enhances the mutual relationship between plants and pollinator system, and their role in maintaining the ecosystem stability. So conserving these pollinator species will help to support the reproductive biology of these plants. These are the references. Thank you.
Any one question from audience?
Yes.
In the structure you showed for bee and the butterfly.
Yes, sir.
No,
Yes,
not
sir.
required. Not required. You said the proboscis of butterfly is longer.
Yes, sir. Comparatively longer.
Comparatively.
Comparatively
But
longer.
here, if you see in your picture, you have not
That
stretched.
is, sir, actually the butterflies have rolled in the proboscis.
That's what.
And
You-
when they
this
visit.
is your structure, handwritten drawing, no?
Yes, sir.
Composed drawing. So you should stretch it and show that it is longer
Yes,
than.
sir, yes, sir. That I can do, sir.
Okay, thank you, Devendra.
Yes, sir.
Fine.
Thank you.
Next presenter, Purushottam.
Environmental conditions and evolutionary pressures.
Hello. Go to result.
Yes, sir.
Okay.
The objectives to study the pollen morphology characters of selected plant species in Vivekananda College campus. The materials methods is the study area of Ramakrishna Mission Vivekananda College at Chennai. That the mean rainfall of is approximately 1200 millimeter. The precipitations occurs due to the northeast monsoon in the.
Go to results.
Yes, sir.
Go to results.
The methods is the sample collection of pollen samples were collected in young buds of unopened flowers of plant species and stored in FAA fixators. The slide preparations of flowers were tagged in FAA preservatives to study the external morphology of plant pollen grains are acetolized using standard methods. Staining and mounting of the pollen grains are treated with acetic acid, stained with the safranin, and mounted with cover slip sealed with DPX prepared using the...
Don't read, right? Go to the this one, result.
Yes, sir. The NPC system of N represents the number of apertures, and P represents the position of pollen surface, and C represents the character apertures. The total number of plant species were recorded in 52 species and 48 genera and of 32 families. The herbs were collected in 47.1%, and shrubs were 19%, and the tree was 31%, and climbers were 2%. This is the visual representation of tabular column. We were collected of all the data. And here's the NPC system of numbers were collected in 7 types: monotrime, ditrime, and tetra, and tritrime. The position is 5 types: the zonotrime, dizona, anacata, and catas. We are represented the example slides. We were done with our manual methods, and the characters was recorded in 5 types: the borate, colpate, and leptoma species. And the shape was recorded in 4 types: spherical, elliptical, and angulars. And the size was recorded in largest pollen of Senna arculata, and smallest pollen in Typhonium trilobactam. The exant sculpture was recorded in 7 types, and the scrapped granulate, and every types of pollens is shown, and the exant thickness is, the largest one is Jatropha integrema, and the minimum is Cypress asperm. The colpi dimension is Ceteria verticillata is the lengthiest one, and the smallest one is Azadiractica indica. The pollen diameter is Azadiractica indica is the longest one, and the shortest polar diameter is Ficus bengalensis. As well as in the equatorial diameter, the longest one is Ceteria verticillate, and the shortest one is Jatropha integrema. The P ratio is measured of both the polar and equatorial diameters, which is the Nerium oleander is the maximum, and minimum is Erythrostis ambulensis.
Come to conclusion.
In this study, the different quantitative and qualitative characters were measured in the pollen grains morphology of exant ornamentations, and NPC system, size, shape, and all the parameters we have collected is 9 characters we have observed. These parameters can prove helpful species delimitations, thus showing potential taxonomical values, sir. Thank you.
Okay, one question.
Yes, sir.
Your college is how many acres?
It's around 4 to 5
acres.
Yes, sir.
So if you conduct there, so generally it is disturbed, totally it is disturbed.
Yes, sir.
Okay, then your result is not getting a good result.
Yes, sir.
Okay, that is the one. Open for any questions, 1 or 2 questions, please.
Yes, addition. I did the same studies 40 years ago in the same department, palynological studies of leguminaceae. You may find that my dissertation, MSc dissertation, in the library.
Of course.
And as he asked, it is those days itself, because of the disturbance, I had to use Madras city to collect the pollen grains of leguminaceae species. But I am really happy to see that from only lab-oriented thing, our college is doing field-oriented.
So
Thank you very much.
Actually, this is my preliminary work.
Yeah,
of
just 2 months, your professor was telling me, he came and met me.
my MSc project is also.
All the best.
Thanks.
Thank you. Then the last presenter is Vaishnavi.
Hello. Let me start. Good afternoon. My name is Vaishnavi. I'm presenting my research work on the topic trap size and prey composition of 2 coexisting endemic Eutralia species from laterite plateaus of northern Kerala. Utricularia is the largest genus among carnivorous plants, and suction traps or bladder in Utricularia are unique among carnivorous plants. And bladders catch microalgae, small aquatic invertebrates. Trap content has been used to define their diet, despite little is known about this prey spectrum of this genus. Hence, the present study compared trap content of two coexisting endemic terrestrial utricular species, Utricularia sicily and Sainthomia from the laterite plateaus of northern Kerala, India, and to determine whether these two coexisting species have developed distinct strategies to limit their competition over resources. And moving to objectives, to study the trap content of two coexisting species, to examine the relationship between size and trap content, to determine whether Utricularia species show any prey specificity, and to determine whether these two coexisting species have developed distinct strategies to limit their competition over resources. Why is the study relevant? Both species are endemic to northern Kerala and they possess short lifespan, and they show high habitat specificity and lack of information about the prey composition. This is the study area. Moving to the methodology, including 50 traps from each plants were collected and washed with the distilled water and opened with thin needle, and the trap content were observed under the common microscopy and photograph. Identification of microorganisms according to relevant literature and expertise, and Shannon diversity index was calculated to analyze the prey diversity in traps, and linear food selection index was calculated for each species in each location for understanding the preference in their diets. Moving to result and discussion. Utricularia Sainthomia and Sicily populations are grown in loamy sand soil, and they are usually grown in a acidic waterlogged soil, and these are the soil parameters. And Utricularia sicily is a rootless plant. The traps are basal in position and seen on phylloclade, stolon and rhizoid. Both external as well as internal glands are present. And Utricularia Sainthomia is only one species in the section Oligocysta having lateral trap, which are seen on phylloclades and stolon. Both external as well as internal glands are present. Moving to the biotic diversity, in sampling site 1, 8 different prey items were identified from 50 traps, and 25 traps contain trap organism, and the most common prey groups are Cyclopidae, Ostracoda, Herpeticoda, Nauplius larvae, and major algal species present in traps are Microstetias for Utricularia sicily. In case of Utricularia Sainthomia, 8 different prey items were identified, and 44 traps contain prey organisms, and the most common prey groups are Ostracoda, Cyclopidae, Herpeticoda, and the major algal species are Microstetia species, Ermosphaera species, and Clostridium species. In sampling site 2, for Sicily, 5 different prey items were identified, and 24 traps contain prey organisms and remaining were empty. And the most common prey groups are Cyclopidae and Ostracoda, and the major algal species are Cosmarium species and Ermosphaera species. For Sainthomia, 10 different prey items were identified from 50 traps, and 40 traps were contain prey organism. And the most common prey groups are Ostracoda, Elaphodella, and Cyclopidae, and the major algal species present are Cosmarium and Clostridium species. And the sampling site 3 show for Sicily, 4 different prey items were identified, and 20 traps contain prey organism, and remaining traps were empty. The most common prey groups were Ostracoda and Herpeticoda, and the major algal species present in here are Ermosphaera species. And in case of Sainthomia, 12 different type of prey organisms are identified, and 44 traps contain prey organisms. And the most common prey groups are Ostracoda, Elaphodella, and Herpeticoda, and the major algal species present in traps are Cosmarium species and Ermosphaera species. While analyzing the Shannon diversity index of prey diversity, Utricularia Sainthomia has an H index of 2.07, show that high prey diversity and capture a wide range of prey types with a relatively even distribution, and it indicates that they show generalist feeding behavior. For Utricularia sicily, H index of 1.71, and they show moderate diversity and capture several prey types and show intermediate ecological adaptation. For linear food selection index, sampling site 1 show that both species show strong preference for Ostracoda and Herpeticoda. For Utricularia sicily, they mainly preferred prey groups are Herpeticoda and Ostracoda, and for Sicily, it is Ostracoda. And sampling site 2, both species show strong preference for Ostracoda and Cyclopidae, and only 2 type of prey organisms were selected by Sicily and remaining were avoided. And in case of Sainthomia, Ostracoda, Cyclopidae, Elaphodella, and Parastenocaris are the important prey groups. And in case of sampling site 3, the prey preference focused on Herpeticoda and Ostracoda, and Utricularia sicily show moderate diet diversity, while Utricularia Sainthomia prefer Herpeticoda, Elaphodella, and Ostracoda, and smaller prey like Rotifera also exploited. And analyzing the relationship between trap size and content.
Come to conclusion.
strap size and content. The average size for Saint Tommy is 0.7 to 2.5, and the larger trap accommodate more prey organism. So I concluded that the biotic diversity inside the trap consists of varying zooplanktons and phytoplankton. Due to varying degree of digestion, identification where down to genus level was not possible for many organisms. And the most common prey groups are Cyclopidae, Elaphoidala, Herpeticoda, Nauplius larvae, and Ostracoda. Among these, Ostracoda and Herpeticoda play a critical role in the dietary composition of each species. And major algal species present are Microsteria species, Cosmarum, and Eremospora species. For Utricularia saintomia has the highest prey diversity, and Utricularia sicily show moderate diversity. And for Utricularia saintomia show generalist feeding behavior and a wide range of prey spectrum. For Sicily, it exhibits moderate diversity and show intermediate ecological adaptation. And the saintomia show higher LFSI exhibit stronger prey selectivity and broader prey utilization, indicating better prey availability and adaptive foraging efficiency compared to Sicily, which diet is narrow and reflecting selective trapping. So the larger trap potentially accommodate more prey organism. These are the references that I followed during the study, and the authors thank to Department of Botany, Kerala Forest Permission, CSI UGC, Alexander Novikov, and Elena Chatropad for the identification of zooplankton, Dr. Rajan for the identification of phytoplankton. Thank you.
Open for discussion. One question. Yeah. Have you observed any butterfly, moths, or bee are visiting the flower?
Yes, sir. Bees.
Okay.
Yes.
So
For Cecily, bees are observed because Cecily has largest flower compared to saintomia. Saintomia has only small sized flower.
One of your pictures had purple colored bladder. So
Bladder, yes, yes.
Is that a stain or the bladder
No,
itself
ma'am.
is
Actually, it is coloration by anthocyanin or pigmented.
Okay.
Yes. Yes, natural.
thank you, Vaishnavi.
Thank you, sir.
Thank you for all. So we are concluding this section. So overall it was very interesting presentations. Thank you for all.
Thank you, and it's interesting that you are trying for interdisciplinary studies. I hope there are many more in future. There were some papers who are in the recent, like they have started recently, but hopefully you will evolve good hypothesis, good research questions in future, and all the best, everybody.
Thank you for all. It's a conclusion, and very shortly, valedictory function will start, and don't move from the hall. Thank you.
With that, we officially conclude the oral presentations and technical sessions here in the Dr. APJ Abdul Kalam Auditorium for this conference. I thank all the participants for your wonderful presentations. May I request Dr. Rajesh KP, Assistant Professor, Department of Botany, Zamorins Guruvayurappan College, Calicut, to felicitate Professor Kotresha, Dr. Aparna Watwe, and Dr. Muhammad Nisa for graciously chairing this session. Sir, please.
So sorry.
Thank you all. The presentations in this auditorium are now finished. We are dispersing temporarily since the parallel sessions are still underway. We need everyone back here in the Dr. APJ Abdul Kalam Auditorium at 3:45 p.m. for the valedictory section after a quick tea break. Thank you.
It has been for me an amazing experience to be invited to visit, inaugurate, and tour the Devagiri College Library in its newly renovated incarnation. Student days have been to dozens of libraries around the world, but I've never had the pleasure and privilege of stepping into such a lovely library and being able to study. My congratulations to all the students who by luck or timing or desire or decision find themselves in Devagiri as this library comes into play.
സോളാർ വാങ്ങിച്ചു.
സോളാർ അതിന് കുറെ പൈസയാവില്ലേ?
ഉപ്പ ലോൺ എടുത്ത്
ഉപ്പേ
3000 ഉപ്പ ലോൺ എടുത്ത്.
അപ്പൊ പൈസ ആരാ അടയ്ക്കുക?
അതാണ് ഉപ്പ അടയ്ക്കുക.
അതിന് ഉപ്പാന്റെ അടുത്തിരുന്ന പൈസ
ഞാൻ കൂടുതലൊന്നും ചിന്തിക്കണ്ട. നമ്മളിപ്പോ കറണ്ട് ബില്ല് അടക്കണില്ല, ഗ്യാസിന് പൈസ കൊടുക്കണില്ല. ഇതിന്റെ ഒക്കെ പകുതി പൈസ മതി ലോൺ തിരിച്ചടക്കാൻ വേണ്ടിട്ട്. പിന്നെ ബാക്കി പൈസ എന്താ ചെയ്യുന്നത്? നിന്റെ കല്യാണത്തിന് വേണ്ടിട്ട് ഞങ്ങൾ ഫിക്സഡ് ഡെപ്പോസിറ്റ് ആക്കി.
കല്യാണം വേണ്ട.
ഉമ്മ പറഞ്ഞു വിചാരിച്ചിട്ട് സീരിയസ് ആവണ്ട. ഞങ്ങളെ നാളത്തെ ജീവിതത്തിന് വേണ്ടി സമ്പാദിച്ചിട്ട പൈസ
ഒരു ഓർബിറ്റ് മതി.
ഓർബിറ്റ്
അറിയോ?
എനിക്കറിയാലോ. ഞാൻ ഞാൻ സോഷ്യൽ മീഡിയയിലൊക്കെ കാണലുണ്ടല്ലോ.
എന്താ കാക്കോ, കുട്ടികൾക്ക് വരെ അറിയാം നമ്മൾ ഓർബിറ്റ്.
Orbit. Energize your future with solar power. Orbit. Energize your future with solar power.
very much.
It has been for me an amazing experience to be invited to visit, inaugurate, and tour the Devagiri College Library in its newly renovated incarnation. My student days have been to dozens of libraries around the world, but I've never had the pleasure and privilege of stepping into such a lovely library and being able to study. My congratulations to all the students who by luck or timing or desire or decision find themselves in Devagiri as this library comes into play.
നമ്മളിന്ന് വീട്ടില് സോളാർ വാങ്ങിച്ചു.
സോളാറോ? അതിന് കുറെ പൈസയല്ലേ?
ഉപ്പലോണെടുത്ത് ഉമ്മാന്റെ ഉപ്പലോണെടുത്ത്.
അപ്പൊ പൈസ ആരാ അടയ്ക്കുക?
അതാണ് ഉപ്പ അടയ്ക്കുക.
അതിന് ഉപ്പാന്റെ അടുത്തിരുന്ന പൈസ
കൂടുതലൊന്നും ചിന്തിക്കണ്ട. നമ്മളിപ്പോ കറണ്ട് ബില്ല് അടയ്ക്കണില്ല, ഗ്യാസിന് പൈസ കൊടുക്കണില്ല. ഇതിന്റെയൊക്കെ പകുതി പൈസ മതി ലോണ് തിരിച്ചടക്കാൻ വേണ്ടി. പിന്നെ ബാക്കി പൈസ എന്താ ചെയ്യുന്നത്? നിന്റെ കല്യാണത്തിന് വേണ്ടിയിട്ട് ഞങ്ങൾ ഫിക്സഡ് ഡെപ്പോസിറ്റ് ആയിരിക്കും.
ഉമ്മ പറഞ്ഞു വിചാരിച്ചിട്ട് സീരിയസ് ആവണ്ട. ഞങ്ങളെ നാളത്തെ ജീവിതത്തിന് വേണ്ടി സമ്പാദിച്ചിട്ട പൈസ
ഒരു ഓർബിറ്റ് മതി.
ഓർബിറ്റ്
അറിയോ?
എനിക്കറിയാലോ, ഞാൻ സോഷ്യൽ മീഡിയയിലൊക്കെ കാണലുണ്ടല്ലോ.
എന്താ കാക്കോ, കുട്ടികൾക്ക് വരെ അറിയാം നമ്മൾ ഓർബിറ്റ്.
Orbit. Energize your future with solar power. Orbit. Energize your future with solar power.
Hello. Hello.
Dear delegates, please occupy your seats in the auditorium. We are about to begin. Please occupy your seats in the auditorium. We are about to begin. Good evening, everyone. As the enriching academic deliberations of the 35th Annual Conference of the Indian Association for Angiosperm Taxonomy draw to a close, we now gather for the valedictory function, a moment to reflect, appreciate, and formally conclude this memorable scholarly journey that has brought together eminent taxonomists, researchers, and academicians from across the country.
This conference has stood as a vibrant platform for the exchange of ideas, the celebration of botanical scholarship, and the reaffirmation of our collective commitment to the study and conservation of angiosperm diversity. It has also strengthened the enduring bond between IAAT and St. Joseph's College Autonomous Devagiri, fostering intellectual dialogue rooted in scientific rigor and academic excellence. Let us now proceed with the valedictory session of this distinguished conference. May we humbly request the honorable dignitaries to please come up to the dais and take their seats. May we humbly request the honorable dignitaries to please come up to the dais and take their seats.
Thank you. To invoke divine blessings upon this concluding session, we begin with a prayer song. May I invite Ms. Rekha C. to lead us into prayer. Kindly rise.
दीनन दुख हारण देव संतन सुखदाय दीनन दुख हारण देव संतन सुखदाय अजामिल गीत व्याद अजामिल गीत व्याद तीन में कहो कौन व्याद पंजी हो पड़ पड़ावत गणिका उकावि दीनन दुख हारण देवा.
Thank you, Rekha, for that soulful rendition. To formally welcome the gathering and set the tone for the valedictory proceedings, may I now invite Dr. Dels P. Sebastian, General Convener, 35th IAAT Conference, to deliver the welcome address.
Respected Principal Dr. Biju Joseph, Dr. Kanad Das, Director, Botanical Survey of India, Distinguished President of IIT, Dr. D. Narasimhan, Honorable Secretary of IIT, Professor Santosh Nambi, Organizing Secretary, Dr. Manudev KM, distinguished delegates, esteemed resource persons, faculty members, and all respected participants. As we gather for the valedictory function of this important international seminar, we are reminded that this occasion is not merely an ending, but a call to greater responsibility. The core mission of this seminar and of IIT is to ensure that all existing species of angiosperms are identified, documented, and conserved. At a time when biodiversity is rapidly declining, this task stands as both a scientific responsibility and a moral duty. May the knowledge and insights gained through this seminar inspire continued research and meaningful action in the fields of plant taxonomy and conservation. It's my great pleasure to welcome you all to the valedictory session of this international seminar. First, I extend a warm welcome to our principal, Reverend Father Dr. Biju Joseph, CMI, whose inspiring leadership and unwavering support continue to strengthen the academic and research culture of St. Joseph's College, Devgiri. Your guidance has been instrumental in successful hosting of this prestigious international seminar. We are truly honored by your presence this afternoon. Welcome, Father. I now extend a cordial welcome to Dr. Kanad Das, Director, Botanical Survey of India, whose outstanding contributions to botanical research and national plant documentation have greatly strengthened scientific foundation in our country. He has discovered 165 new species of wild mushrooms in India, significantly enriching our understanding of fungal diversity. His presence at this valedictory function is a great source of motivation to all researchers gathered here. On behalf of everyone present, I warmly welcome you, sir. I now extend a heartfelt welcome to the distinguished President of IIT, Dr. D. Narasimhan. Your dedication to the advancement of taxonomic science continues to inspire the entire scientific community. Your remarkable energy and commitment are truly admirable. Even after a full day of intellectual intense sessions, you remained actively engaged in responsibilities of IIT. We feel deeply privileged to have such a dynamic and devoted leader guiding IIT. Welcome, sir. I also warmly welcome Honorable Secretary of IIT, Professor Santosh Nambi, who will be presenting the IIT awards today. Sir, your presence holds special significance as you approach retirement after a remarkable career. You are not only one of the finest secretaries of IIT has ever had, but also a visionary who helped shaping IIT into a globally recognized and well-structured organization. Your contributions to taxonomic field through discovery and description of several new species have left an indelible mark on Indian botany. It's a matter of great pride that you once served as professor at this college. We respectfully welcome you, sir. A special word of appreciation and welcome to our organizing secretary, Dr. Manudev KM. Your exceptional planning, coordination, and tireless leadership have been pivotal in transforming this seminar into a grand academic success. Every aspect of this international event reflects your dedication, vision, and organizational excellence. I also extend a warm welcome to Dr. Manudev KM. Now, I would like to welcome all distinguished delegates, scholars, researchers, and participants who have enriched this seminar with their valuable insights, discussions, and scholarly contributions. Your active involvement has truly made this seminar vibrant, meaningful, and impactful. Once again, I warmly welcome all of you to this valedictory function, and thank you for being part of this memorable academic journey. Thank you.
Thank you, sir, for your warm words of welcome. We now move on to the presidential address. It's our great privilege to invite Reverend Dr. Biju Joseph CMI, Principal, St. Joseph's College, Autonomous Devgiri, to share his valedictory reflections and after his presidential message marking the formal culmination of this prestigious academic congregation. Over to you, Father.
Respected Chief Guest of the Day, Dr. Kanath Das, Director, Botanical Survey of India, President, IIT, Dr. D. Narasimhan, Secretary, IIT, Professor Santosh Nambi, Head of the Department, Botany, St. Joseph's College, Devagiri, Dr. Delsby Sebastian, Organizing Secretary of this great event, Dr. Manadev KM, esteemed guest, respected teachers, dear researchers, and my dear friends. Good afternoon to all of you. It's my great honor to stand before you on the concluding day of this three-day international symposium and 35th annual conference of Indian Association of Angiosperm Taxonomy. I would like to presume with a sense of deep satisfaction that IIT annual conference and this international symposium hosted here in St. Joseph's College, Devagiri, has been conducted successfully, and it was up to the expectations of all who participated in it. Welcoming 404 delegates from 16 states across India and esteemed resource persons from 6 different countries has been both an honor and privilege for me as the principal of St. Joseph's College, Devagiri. Over the past 3 days, we have shared knowledge, ideas, and hopes for the future. Each day, we began with an inspiring keynote address, and the cultural night on the first day reminded us that the science and culture go hand in hand. Today, as we come to the end of this gathering, we can proudly say that these discussions were enriched all of us. The theme covered in this conference are highly relevant to the world we live in. We discussed topics like advances in angiosperm systematics because it helps us to understand plant relationship more clearly. DNA barcoding as it support accurate identification process. Floristic diversity and the incredible richness of plant world we live and we have to nurture. Ethnobotany and India's traditional knowledge, which reminded us that our ancestors were scientists in their own way. Biodiversity conservation. I think it is the responsibility we all share and a commitment we have to the future generation. Biodiversity simply means the variety of life around us. The plants, animals, insects, birds, fungus, and even microorganisms. Each one, big or small, plays an important role in keeping our life healthy. We depend on biodiversity every day, often without realizing it. Plants give food to us, oxygen, medicine, and raw materials. forests keep our climate stable. Animals help in pollination and maintaining balanced ecosystem. The air we breathe, the water we drink, and the soil that grows our food all depend upon healthy biodiversity. This is why we say that biodiversity conservation is not a choice, it is a necessity. In the end, the message is very clear. When we protect biodiversity, we protect ourselves. A healthy environment means healthy people and healthy future. All these topics discussed here shows that Angiosperm taxonomy is not only about naming plants, it's about understanding life, protecting environment, and building a sustainable future. This event is also special because it has been arranged in honor of the retirement of our respected professor, Professor Dr. Santosh Nambi from University of Calicut as a teacher. His dedication, hard work, and gentle leadership have been guiding all of us for many years. On behalf of everyone here, I express our deepest gratitude to him. We are sure that his contributions will continue to inspire many more generations yet to come. As we conclude, let us take home 3 simple ideas. Keep learning, because knowledge grows only when we remain curious. Protect nature, because nature protects us. Work together, because science advances through cooperation, not competition. As you have experienced in these 3 days, St. Joseph's College, Devagiri, often known as Devagiri College, a premier higher education institution in Kerala, has always lived by its noble motto, Pro Deo et Patria in Latin, that is, for God and country. It has completed 70 successful years of service with the vision to form leaders who are intellectually competent, spiritually mature, morally upright, and socially acceptable. This conference is yet another example of that humanistic vision of our visionary founding fathers. I would like to express with pride and conviction that Devagiri has always stood firmly for research excellence, knowledge creation, and the meaningful dissemination of ideas. Our institution remains deeply committed to nurture a vibrant academic culture, one that encourages inquiry, foster innovation, and support scholars in the pursuit of truth and understanding. Devagiri has constantly opened its doors to academic collaborations, intellectual gatherings, and opportunities for networking, believing that such engagement will strengthen both individual scholars and wider community around us. It is our enduring mission to provide a space where ideas converge, partnerships are formed, and new knowledge taken root. We will continue to support and celebrate initiatives that enrich research ecosystem, and we look forward to host many more such academic coming togethers like this in the coming years. As we conclude the enriching academic gathering, I sincerely hope that every participant, you all, found the sessions are insightful, the facilities are comfortable, and the arrangements, be it in travel, hospitality, or in accommodation, convenient and satisfactory. It is our earnest wish that your experience at Devagiri has been both meaningful and memorable. Thank you for all your active participation, your academic contributions, and the spirit of collaborations you brought to this conference in Devagiri. We look forward to welcoming you again and again to Devagiri. I wish to place on record my deepest appreciation to the Department of Botany of St. Joseph's College, Devagiri, for wonderfully hosting this international conference here in these days. Under the leadership of Dr. Delsby Sebastian, the respectful HOD of Botany Department, and Dr. Manudev KM, the organizing secretary, the event has been organized smoothly and effectively. I also remember the IAT office bearers and the team from Calicut University, Botany Department from Calicut University, and Malabar Botanical Garden for their constant support and cooperation. A big note of gratitude to the entire Devagiri team, teachers, staff, research scholars, volunteers, and students for their hard work and teamwork. Because of your collective effort, this conference has become a great support. Before I end, I once again thank the organizers, the speakers, and the delegates, and everyone who worked behind the success of this conference. You have made this conference a big success. Let us leave this hall with a renewed commitment to science, to society, and to the earth that sustain all of us. Thank you, and I wish you all a safe journey to home. Thank you.
Thank you, Father, for those kind words. It is our honor to invite Dr. Narasimhan, President, Indian Association for Angiosperm Taxonomy, to offer his insightful remarks and share his perspectives on the proceedings and the significance of this year's conference. Over to you, sir.
Thank you. As all of you would have felt it, this conference that is organized here in Devagiri is probably one of the best, or the best so far. On what parameters I say this? One thing, the efficiency of organization, right from the beginning, day one, till the end, and the digital mode of registration, digital mode of interacting, including your pass, everything is digitalized. So we are one step above than wasting printed passes. So that's another thing. We did not waste a paper. And the third thing is the way precisely it is done. Our schedules went mostly on time. We are not far behind the schedules. And everybody was talking to the time, so which is one of the important thing in a conference. Otherwise, I myself would have suffered in many conferences, some senior people talking for 1.5 hours, 2 hours, and nobody wants to stop them. But whereas here, I think the average age of IIT is coming down. It is coming down. Now I think average age probably is around 60, 65. Right? It's not 70, 70. Right? So that is one of the important reasons that we should understand, as we were discussing in the earlier meeting, having youngsters more in the organization, having youngsters more in the participation is very, very important to have a control over this. Otherwise, it's going to be very difficult to control elder people. Yes. I openly say that. I felt it. That's why I say that. Right. Okay. And what good lessons? This conference has taught us several good lessons. One thing, apart from the organization, as I said in the inaugural remarks, completely avoided plastics. You could have never seen a plastic tumbler or plastic cup anywhere. It's always reusable material, and that's why you see the venues very, very clean, very, very neat. And that's an important lesson also to be learned by the forthcoming organizer. It is very important. So to avoid plastics. We don't have paper cups. Even paper cup contains plastic line. So that's another very good message the conference has given to us to take it forward. The papers that were presented in the conference, I think far above the level of the other conferences so far I've attended. Definitely on par with international scenario. We have some international people here sitting. There may be some quality differences, but still, if you've attended our earlier conferences, it was still speaking on species-based enumeration, only those things. But now here you could have seen, many of them are talking about molecular taxonomy, trees. So all these things is a good change in the content. And people presented them boldly in the required time, and that is another success of the conference. Okay. So there are several good things that have happened in this conference. Another important thing in the conference about my remarks is, it's a very pleasant feeling to be here. And your students, your student volunteers, Father, your student volunteers are very neat, very good, and very polite. And guided us the places to where we had to go. They were with us. They took us. And that's an important thing. They never ditched us. So I enjoyed the support of your community, right? Not a student and staff community, is something very important for the success of the conference. Thank you. I think maybe I stop here. So thank you very much for giving us the venue. And one more important thing is, I've been hearing about Devagiri College for the past so many years. So I visited once for conducting a Viva. But that was not, I didn't probably go through the entire your system. But now I understand why Devagiri College is spoken outside. You have an excellent infrastructure. You have excellent staff, excellent sub-staff, excellent students. And the campus is maintained pick and pan. I don't think you will never see a campus like this. There may be a campus in Kerala, I don't know, but anywhere else in Tamil Nadu or other universities, you can never see a campus like this. That's an important thing. I know. With this, I can quote only one college in Tamil Nadu in Coimbatore. That is the women's college run by one of the management. Excellent facility. Every 1 hour, 2 hours, you can see them sweeping the floor, keeping the dust that is fallen and putting it aside. That's only one college. They have money power and human power, so they can maintain it. But this is one example how a community can help to make a college very good, very neat. And what appears when you enter into the college, it looks like some precious monument. It doesn't look like a college. Right? That's something great for that. You have maintained this all along so far, and I hope you will maintain it definitely in future also. That's the most important quality of the college. Why we are important, these things are important is when a student enters into the college, the first thing appears is the appearance and the neatness. When everything is good, student feels happy and the learning opens up. Teachers also, when they are put in a good setup, they can open up their mind, read more and contribute more and share more. And these things, and this is one of the important factors for the success of your college. So I think I stop my remarks here. Thank you so much, Father, for giving us a place to hold a meeting and giving us an opportunity to see the fantastic institution that you have built, and also giving us a nice experience of your place and of your students. Thank you so much.
Thank you, sir, for your words of appreciation and encouragement. It's a great privilege to invite Dr. Kanad Das, Director, Botanical Survey of India, to formally inaugurate the proceedings and deliver the inaugural address. Over to you, sir.
Very distinguished dignitaries on and off the dais, eminent scientists, professors, my fellow colleagues, respected teachers, esteemed members of IIT, faculties of the St. Joseph College, galaxy of eminent plant taxonomists sitting in front of me, and all the researchers present over here. Ladies and gentlemen, good evening and namaskar to all of you. I feel extremely privileged and honored to be here to address this august gathering. Although you know that I am not an expert of Angiosperm taxonomy, I feel happy to see you all in this meaningful platform. Thanks to the organizing committee, particularly Professor Nampi and the principal of this esteemed college, Father Dr. Biju Joseph. Probably you all are aware that the Botanical Survey of India is the premier institute of Government of India, which is focused on the exploration, characterization, identification, monitoring, documentation, discovery, and conservation of plant and fungal wealth of this country. This institute is already committed to produce the much needed flora of India in 32 volumes. And out of these 32 volumes, BSI has already published 26, and the rest 6 are in pipeline. In this line, BSI will be more focused to come out with the publications on monographic studies and revisionary studies of flowering plant, and probably involving the combined study of classical morphotaxonomy with multi-gene genealogy. And this organization also will put more efforts to publish flora of lower group of plants and fungi. I never say that we have sufficient plant taxonomies. No, not at all. Always there is a huge crunch. But indeed, we have a severe dearth of fungal taxonomies. Up to 2007, you know that I am blessed enough that today I have in front of me our former director, Dr. Sanjappa. I hope that sir will agree with me that up to 2007, we had only 3 scientists for the whole country who used to handle the immense diversity of fungi as well as lichenized fungi. Slowly, very slowly, the scenario is getting improved with the recruitment of a few fungal taxonomists like me. And presently, out of our 78 scientists in BSI, 8 scientists and 6 staff and scholars, research scholars, are working on fungi and lichenized fungi in different parts of India, which I can happily say is the all-time high on fungi and lichenized fungi for this national institute. Although the existing manpower is still significantly low on contrast to the present need, as we all know that the fungi, the kingdom fungi is the second largest kingdom after the animal kingdom, and 93% of the fungal kingdom is still unknown. So probably in coming years, BSI will be interested to recruit more scientists and scholars to strengthen its manpower on non-flowering plants and fungi as well. Apart from that, BSI will develop, as you know, that national red list of plants involving 55 core committees. And BSI will also undertake a very new assignment, that is plant-based wildlife health management. And recently, this work has been entrusted by our Ministry of Environment, Forest and Climate Change, Government of India, to us. More and more, NDF, that is non-detriment findings study, will also be undertaken by BSI scientists in coming years. So today, you know that we are from every corners of this country to attend this huge conference. And as Father already told, that purpose of this conference will be half fulfilled if we do not go for significant collaborations, intra-collaborations, inter-department, as well as inter-department collaborations. So with these few words, I congratulate the organizers of this conference of this international symposium for this grand success, and I look forward to see a meaningful collaboration with BSI as well in coming years. Thank you.
Thank you, sir. May I now request Reverend Dr. Biju Joseph CMI, Principal, St. Joseph's College, Autonomous Devgiri, to present a token of our appreciation and gratitude to Dr. Kanadas, Director, Botanical Survey of India.
Thank you. The Indian Association for Angiosperm Taxonomy now honors excellence in the field through the IAAT award presentation. May I invite Professor Santosh Nambi, Secretary, IAAT, to present the IAAT awards and felicitate the distinguished awardees whose contributions have significantly shaped the field of plant taxonomy.
Respected President of the day, Reverend Father Biju Joseph, Principal St. Joseph's College, Devagiri, Chief Guest, Dr. Kanad Das, Director, Botanical Survey of India, General Convener of this conference, Dr. Delsby Sebastian, President of IAT, Dr. D. Narasimhan, Organizing Secretary, Dr. K. Manudev. Good evening, everyone. I am so delighted to stand before you on the final day of our 3-day international conference and annual conference, 35th annual conference of the Indian Association for Angiosperm Taxonomy. Over the past 3 days, we have had a lot of discussions, especially focusing on 11 different themes, as well as we have different medal awards instituted by the Indian Association for Angiosperm Taxonomy. And when we analyze what about the outcome of this conference, I can say this is the best organized conference over the 35 years in academic point of view. Academic point of view means we have overall 11 keynote lectures by highly experienced presenters. We have 9 invited lectures also by highly experienced researchers, and more than 225 presentations by student researchers. This is a great number. And I have been going through most of these venues, and I have seen the presentations also over there. And all the student presenters, over the years we can see there is greater improvement in their presentation skills also. The way they're presenting, the content they're presenting, we can see that much of improvement over the years. So we have to thank the association. The students also have to thank the association for giving that platform for their presentation. And secondly, with respect to the organizational level, again, I can say this is the best organized one. From one point we consider in what way we give this organizational level. One, we consider what about the programming. What level the program is going on different. I think yesterday we have 4 different parallel venues. Today we have 5. And in all venues, the programs were meticulously arranged. There is no lagging in the presentations. And we have to thank all the judges also for maintaining accuracy, maintaining or asking questions, and also refining the presenters. So all the presentations were extraordinary, and also the scheduling of the programs was also very perfect. Similarly, there is no complaints or no apprehension about the food we have served there, the food venue, so neat, clean. And what about the venues also? Everywhere it is clean, neat. So in that level again, and I think there is no complaints regarding the accommodation also. Everything was perfect. So I use this opportunity to thank the entire college community, and also especially the management and our beloved principal, Father Biju Joseph. Only because of him we were able to get this platform for hosting the 35th annual conference of the association. And also especially thanks to our father for giving a inspiring, insightful message on plant diversity and also the significance of plant taxonomy as well. Thank you, Father. And one sentence about my student as well as the present organizing secretary, Dr. Manudev. So this big applause indicates how much love we are given to Dr. Manudev. He was my student for the degree as well as for the PG, and for both PG as well as degree as well as PG, he was first rank holder. And immediately he qualified the JRF, and at that time, the college has little bit, facilities are not much this much, facilities, but he chose to work under me, and he selected one of the very difficult plant group of Araceae. It is Aricema, you know, a lot of complicated, it's one of the difficult complex plant group. And he has a lot of publications, and because of his meticulous planning, only this level of conference we can have. So special congratulations to Dr. Manudev. And I know all these students as well as delegates are waiting for the announcement of the result of the medal lectures, the competition. The IIT has instituted 12 awards and 1 endowment lecture. 2 medals usually given to well-experienced researchers, and that has been decided by the Executive Council as well as the GB. Similarly, the endowment lecture also. While 10 awards are mainly focusing on the research students. 1 award we have yesterday given to Dr. Sandeep Gavade for the Professor A.K. Pandey Award for Revisionary Studies. And for the remaining 9 awards, there were competitions held yesterday, and there were tough competitions, and I congratulate all the judges for their critical evaluation of the medal award. May I, with your all permission, may I read the medal awards? Professor Santosh Nambi, IIT Young Scientist Award. It goes to Dr. Akhil M.K., Siddha Plant Garden, Central Council for Research in India, Tamil Nadu. I request our President, Narasimhan sir, to give away the medal and all dignitaries to join for the award giving ceremony. This award was instituted in 2023, sorry. There were the criteria. Initially, we have a shortlisting of the applications received by an expert committee, and then 3 presentations were allowed, and the one best is selected for the award. And I think all the presenters made excellent presentations during the previous day, and Dr. Akhil is selected for this award. Dr. A.K. Pradeep Young Researcher Award goes to Mr. Anishkar Froshwa Joy King of Madras Christian College. Congratulations, Joy. This award was also instituted in 2023 for the age group of below 28. And this year we have several researchers competing for that particular award. And again, the selection was very difficult for finding the best one. For the SM and MR Almeida Award in Plants Nomenclature, this goes to Mr. Ajay Mondal, BSI, Kolkata. So for the remaining awards, instead of the silver medal, a cash prize of rupees 2,000 and the certificate is given. And I request the Director, Botanical Survey of India, to hand over these awards. Professor R.S. Rao Award for the best paper in biodiversity conservation in Angiosperm systematics. This goes to Harida P. Bharathan, Calicut University. Professor K.S. Manilal Award for the best paper in floristics goes to Mr. Arshad K., University of Calicut. He has gone with some travel group, that's why, to some other places. Anyway, shall proceed with the next award. Professor T.R. Sahu Award for the best paper in medicinal plant systematics goes to Arshi Fatima, National Botanical Garden Research Institute, Lucknow. For S.R. Yadav Award for best paper presentation, best poster presentation, this goes to Ms. Drishya V.V., Government Brennan College, Thalassery. I'm also happy to share that Ms. Darshya got the Best Presentation Award in the Madrid Conference held in 2024. I request our principal to hand over the remaining awards. Father Anthony Mukkat, Professor K.S. Vanilal Award for the best paper in modern techniques in plant taxonomy goes to Miss Geetika Sukrami, Agarkar Research Institute, Pune. Professor M. Sabu Award for the best paper in Angiosperm taxonomy category Teachers and Scientists goes to Dr. Jackson T. Government Arts and Science College for Women, Malappuram. Now Arshad is here. I request Mr. Arshad to come over to the stage and receive the award from Father Principal. These are the award instituted by the Indian Association for Angiosperm Taxonomy, as well as there are 12 more awards instituted by the college and the alumni, I think so. Before going to the medal awards, instituted by, can you see? Yesterday, we have decided to, the EC as well as GB decided to felicitate some of our life members of the association by giving the fellowship. I may call the list of life members who have conferred with the Fiat degree. Ms. Danny Francis from Kozhikode. And I request our president to hand over the certificate. Mr. Arun Prashant R. Pune. Dr. Sujit Kumar Ramlal Prajapati. Is he here? Okay. Dr. Sudhi Kasana. I think she's not here. Mr. Nilesh Appasu Madhav, Raigad. Now we move on to the award giving ceremony of the endowment, the awards instituted by the college. And I request Dr. Tania to come on to stage, please. Please come on to stage, please.
Good evening, everybody. The award instituted by alumnus of St. Joseph's College, Devagiri. The first two awards, I would request the Director BSI to do the honors. Reverend Father Theodosius Memorial Award for Best Paper Presentation on the theme Advances in Angiosperm Systematics, instituted by Devagiri Alumni Research Foundation, DARF, is awarded to Nino Maria George, IISR Calicut. The next award is Reverend Father S.H. Anthony Memorial Award for Best Paper Presentation. On the theme, Molecular Phylogenetics and DNA Barcoding, instituted by Devagiri Alumni Research Foundation, is awarded to Alina Xavier, IISER, Bhopal. You can always, somebody is receiving on behalf of Alina, we can always give a clap for Alina Xavier. I now request the next two awards to be presented by the Principal, St. Joseph's College, Devagiri. The third award being Reverend Father Melanesius Memorial Award for Best Paper Presentation on the theme Floristic Diversity and Biogeography, instituted by Dr. Alfonso Vijaya, former Principal, St. Teresa's College, Ernakulam, awarded to Sunit Singh, University of Jammu. I think we can give a bigger round of applause to Sunit Singh. The next award is the Reverend Father Isidore Memorial Award for Best Paper Presentation on the theme Ethnobotany and Indian Traditional Knowledge, instituted by Dr. Alfonso Vijaya, former Principal, St. Teresa's College, Ernakulam, will be awarded to Gavankar Pranjali Mahendra, Goa University. I hope I pronounced it right. I now request the next two awards to be presented by the President IAAT, Dr. Narasimhan. Reverend Father Columbus Memorial Award for Best Paper Presentation on the theme Biodiversity Conservation, instituted by Dr. Alfonso Vijaya, former Principal, St. Teresa's College, Ernakulam, awarded to Reshmi S. of Botanical Survey of India, Coimbatore. Congratulations, Reshmi. The next award in the series, Reverend Father Ivan's Memorial Award for Best Paper Presentation on the theme Climate Change and Planned Adaptation. Instituted by Dr. C.J. Mani, former Head, Department of Botany, is awarded to Krishna Priya, MP, University of Calicut. I now request Professor Santosh Thampi to do the honors. Professor Joseph Thomas Memorial Award for Best Paper Presentation on the theme Digital Taxonomy and AI Applications in Botany, instituted by Dr. Aziz K., former Principal, PSMO College, to be awarded to Joby Paul, St. Thomas College, Thrissur, Kerala. I don't think he is here. The next award is the Reverend Father Joseph Paikada Memorial Award for Best Paper Presentation on the theme Economic Botany and Sustainable Utilization of Plant Resources, instituted by Dr. C.J. Mani, former Head Department of Botany, awarded to Thete KG, MVP Samaj College, Nasik. Thete KG. Sorry. Next award, Reverend Father Bennett Kurian Memorial Award for Best Paper Presentation on the theme Plant-Animal Interactions in Ecosystem Dynamics, instituted by Dr. C.J. Mani, former Head Department of Botany, awarded to Vaishnavi KP, University of Calicut. I now request Principal Father Dr. Biju Joseph to do the honors for the next awardees. Professor Matthew Tamarakard Memorial Award for Best Paper Presentation on the theme Phytochemical Studies and Bioactive Compounds, instituted by Dr. Aziz K., former Principal, PSMO College, to be awarded to Govind M.G., Jawaharlal Nehru Botanical TBGRI. Okay, JNTBGRI, sorry. Thiruvananthapuram, Palod. Govind M.G. I don't think he is here. We'll go on to the next award. Dr. Jose Meridas Memorial Award for Best Paper Presentation on the theme Microscopy in Taxonomy and Structural Botany, instituted by Dr. Aziz K., former Principal, PSMO College, awarded to Jagdish V. Dalvi, BSI, Pune. The last presentation is for the best poster on general themes. Reverend Father Matthew Chalil Award for Best Poster Presentation, instituted by Devagiri Alumni Research Foundation, awarded to Deepika Kumar of Siddham Medicinal Plant Garden, Mettur Dam, India. Deepika Kumar. Can we have all the awardees to come join for a quick photo session? Can all the awardees, all the team, IAT awardees, please, Deepika, stay here. Please, all the awardees, please join quickly for a quick photo before we move back on to the feedback session.
We can take the photos in 2 sets, the IIT medal in 1 set as well as the general awards sections second, that way.
Excuse me.
We will have the photo session in 2 sessions. The first segment will be dedicated to all the IAT awardees, and the second for the general theme awards.
Thank you and congratulations, dear winners. We now open the floor for a brief feedback session where selected participants may share their reflections and experiences of the conference, a valuable moment of recollective introspection and appreciation. The floor is now open for a feedback. Selected participants may share their reflections and experiences.
Good evening, distinguished guests on the dais, of the dais, delegates, and my dear students. Of course, I have to tell, I am not able to tell extra feedback what our secretary and president has told. Already they appraised how the organizing secretary and the organizers, how well they have done. It has been appraised by half of our work has been reduced by president and our secretary. Already they have given feedback. Of course, very good feedback. Manudev, one of the best conferences, the best word also they have been used. From 16 states and 6 different countries, participants have come and they have, as father has told, they have smoothly and effectively they have handled. Now, small problem will come to the next organizers. They have to also cope up with this level. They really utilize the modern technologies like digital everything. I think, I don't know in IBS they have done or not, but they kept a level that is everything, whatever modern technology is available, from the registration to everything, they have utilized the available recent technologies they have used. Even scanning of the barcodes, everything they have utilized. Now, Dr. Sweta Subramaniam has to also keep up the same level. She is having, yeah, really, from the day of, they have advertised that what they have first circular, they have uploaded from the day to the day before the conference begins, they were very active in the WhatsApp group. They were very, very active, and this is the first time even invitations they have sent to their individual WhatsApp and as well as to the email they have given. Really, it should be a appreciable one. Instead of separate one, they have, instead of group one, they have given importance to the each and every delegates and participants. They have given importance. Really, I appreciate Dr. Manudev as well as his team members. I really appreciate. Thank you very much, Dr. Manudev, for your wonderful work. Thank you very much.
Thank you. I may be repeating what already Nambi sir and Sampath sir said, but we should not be lazy to say such a wonderful organized seminar, sir. Myself Chetana Badekar, I am basically from Udupi, Karnataka, working under Jomi sir in Kerala. Last 13 years. I do have an experience of working 10 years with the CMI institution. As he said, they have good vision. So I envy CMI fathers. Next life I need to ask God, because such a vision is important for education institute. What we get a facility here, example library or the clean and tidiness, including honey bee. Have you seen honey hives are there in the campus? Such a wonderful effort. Honey hives have to sustain means we cannot order them. They decided to stay here. So we have to thank Devagiri management team and the students. Dedicated, they should owe biryani or some grand treatment. Because 1:13, night 1:15, yesterday message came, program message. And they work hard. I understand NCC is there. You are invested a lot on the disciplinary action. That is yielding this kind of wonderful result and forum for all Kozhikode and the surrounding people to educate. Thank you for hosting this organization and for the taxonomist, what IIT is giving this opportunity. Every taxonomist knows that how much modern fifth generation recognizes a taxonomy or the subject of botany. And this kind of ceremony reminds us there are taxonomists, we are still contributing, we will still flourish in the modern world. That is a kind of boost we are getting. It's very holistic when we feel for a taxonomist to attend such ceremonies, sir. Thank you for that organizing, and this is a wonderful 100% experience. If you have review, I will give 5 star. Thank you.
Good evening, everyone. Respected dignitaries on the dais, off the dais, ladies and gentlemen. It gives me an immense pleasure to say a few words about the 35th IIT conference held at St. Joseph College, Devagiri, in collaboration with Malabar Botanical Garden and Institute for Plant Science. The conference was wonderful, remarkable, and knowledgeable. They provided good food, good hospitality, and they invited eminent resource persons from different corners of India and abroad. It provides me a unique opportunity to exchange ideas, share the latest research developments, and explore innovative approaches in plant systematics. The first day session was the presidential address by Dr. D. Narasimhan and Dr. Matthew Dunn, Dr. Ajar Kuru, Michael Muller from Edinburgh, Deepthi from Sri Lanka, and Mashiro Kyoto from Japan. They ignited a lot, they motivated a lot, they inspired a lot. And also the culture activity was so mesmerizing. And the second day session was by Dr. Vinita Gowda. Madam also inspired a lot. And Santosh Nempi, the eminent personality of, and the backbone of this conference. A big hand to Dr. Santosh Nempi, the secretary and the main key of this conference. And also Ragharmiya, Costa Rica, they inspired a lot, motivated a lot. And the third day session was by Nana Sekaram. Sir also told about the flora of Madras in late 17th and early 18th centuries. They also inspired a lot. I thank all the pioneers of plant systematics of India for their inspiration. Dr. D. Narasimhan, President of IIT, and Dr. Sanjappa, the former Director of BSI, Dr. A.K. Pandey, Professor S.R. Yadav, INSA scientist, Dr. Santosh Nempi, Dr. Milind Sardesai, all the counselors. Lastly, I thank Dr. Biju John Valkada, the Chief Patron, and Biju K. Joseph Sir, Principal Sir, Treasurer, and the young and dynamic organizing secretary. A big hand to Manudev K.M. His commitment and dedication, and I also thank all the committee, students, scholars. Lastly, I thank all of this Joseph College. So very clean, systematically arranged on behalf of all participants and my own behalf. Thank you very much, sir, for giving me an opportunity. Thank you, and thanks a lot.
Thank you all for the lovely feedback. As we bring this valedictory function to a close, it is time to express our heartfelt gratitude to all those who made this conference a resounding success. May I invite Dr. Manudev K.M., Organizing Secretary, to deliver the word of thanks. Over to you, sir.
respected dignitaries on and off the dais, invited speakers, delegates, my colleagues, my dear students and friends. So, as we bring the 35th Annual Conference of Indian Association for Angiosperm Taxonomy to a meaningful conclusion, it is my privilege to propose the vote of thanks on behalf of the organizing committee. Over the past 3 days, we have witnessed vibrant scientific discussions, insightful keynote lectures, and enriching presentations. This Coral Jubilee Conference has truly been a celebration of scholarship and collaboration. First and foremost, I express my sincere gratitude to the Indian Association for Angiosperm Taxonomy for entrusting us with the responsibility of hosting this milestone conference at St. Joseph's College, Devagiri. And I would like to express my deepest gratitude to today's chief guest, Dr. Kanath Das, the Director of Botanical Survey of India, Kolkata, for coming over here in between his busy schedule. As I understand, he was in Delhi last day for attending another conference on mycology. Thank you, sir, for gracing this occasion and formally inaugurating the validity function. Thank you very much. My heartfelt thanks to the college management, Reverend Father Biju K. Isaac, CMI, the manager, and especially Dr. Father Biju Joseph, principal, who delivered the presidential address today, for Father Boni Agustin, the administrator, our vice principals, Father Antoenche, Father Sunil Jose, the director of our unaided section, Father Sunilam Antony, Dr. Vinish Piche, Dr. Sadish George, for their constant support, encouragement, and guidance throughout this journey. And a word of gratitude expresses my sincere thanks to Reverend Father Dr. Biju John Vellakada, CMI, the Provincial of St. Thomas Province, Kozhikode, for his support throughout the planning of this conference and gracing the inaugural function and delivering the presidential address. I am grateful to Dr. Delspi Sebastian, the head and the general convener of the event, for delivering the welcome address. My heartfelt thanks are also due to my colleagues for their constant support and encouragement throughout the planning of this conference. My heartfelt gratitude is due to Dr. P. Ravindran, Vice Chancellor, the University of Calicut, who inaugurated the conference and deliberated the inaugural address. I also place on record my deep appreciation to Dr. D. Narasimhan, the President of IAIT, for his presidential address during the inaugural session. And he was always with me with a supporting hand throughout the planning of this conference. He gave me insight when I am stumbled upon taking some big decisions regarding the structure of this conference. Thank you, sir. Thank you for your wonderful support. You know, Professor Santosh Nambi, the Secretary of IAIT, has been my guiding light throughout my journey. He is one of the reasons why I took this huge responsibility to organize this conference here, where he started his career as a teacher. His training only gave me the courage to hold such a big event in a venue where such events were never happened. We are also happy to inform you that our students of Professor Nambi have placed a request to IIT Executive Committee to institute a medal lecture or medal award in the name of Professor Santosh Nambi. Thank you, IIT, and Nambi sir, for all your support throughout. Thank you so much, sir. I also thank all the Executive Committee and the office bearers of IIT who are present here and who lent their helping hand when I needed them most. Thank you all. And also a special note of gratitude to Dr. N.S. Pradeep, the Director, Malabar Botanical Garden and Institute of Plant Sciences, and his wholehearted support and the support extended by Malabar Botanical Garden as the co-organizer. Thanks are also due to Dr. Manjula, Dr. Harish, Dr. Pooja Pushkaran for their timely helps in organizing this event. My special thanks to all invited speakers, keynote lecturers and international guests, especially Dr. Michael Muller, Dr. Masahira Kato, Dr. Deepthi Yakandawala, and Dr. Robert Moya Roque for enriching our conference with your valuable contributions. And I also take this opportunity to sincerely thank our sponsors, our funding agencies, Arisandhan National Research Foundation, Botanical Survey of India, National Biodiversity Authority, International Association for Plant Taxonomy, Council of Scientific and Industrial Research, Kerala State Biodiversity Board, Kerala State Council for Science, Technology and Education for their generous support for the successful organization of this event. And I also thank the Distinguished Alumni Association of St. Joseph's College, Devagiri, especially Dr. C.J. Mani, former head of the Department of Botany, Dr. Aziz K., former alumni and principal of PSMA College, Tirurangadi, Dr. Alfonso Vijaya, former principal of St. Teresa's College, Ernakulam, and Devagiri Alumni Research Foundation for their generous support to different awards for best paper presentations in general themes. I also thank our banking partners, Bank of Baroda and ICICI for their sponsorships, and also to our health partner, Aster Mims, Kozhikode, for deploying an ambulance and medical team throughout the conference days. Luckily, we didn't have to take the help from their team. And the service from Hotel Sana, Hotel Medco Mansion for their accommodation facilities are also greatly acknowledged. And a very special thanks to all our delegates, researchers, academicians, scientists, and students who have traveled from different parts of the country and abroad to participate in this important scientific gathering. Your presence enriches the spirit and purpose of this event. Thank you and all. I also express my deep appreciation to the teaching and non-teaching staff, members of the organizing committees, the technical teams, and all our volunteers. Your tireless efforts over the past several months have been the backbone of this event. Without your dedication and wholehearted commitment, this conference would not have been possible. The grand event is possible only because of the tireless efforts of these working committees. I take this moment to gratefully acknowledge the dedication of every member of these working committees. I will take little more time because the list is a little bit long. The first and important committee of a conference is the abstract committee, which was headed by Dr. Gio Moll and Dr. Jenny Shayapi, my student and research colleague, Jenny Shayapi, then Dr. Krishna Priya, who have done a meticulous work in preparing this abstract. And also we are thankful to Dr. Remya K. and Dr. Rachel Chon from Department of English, who made all the grammatical corrections. And I take this opportunity to thank all the committee members. And the registration committee, which was one of the important and one novel, which employed a novel technique, which was headed by Dr. Arunaksharan, and the committee was supported by Dr. Jiyamol KK, Dr. Krishna Priya, Ms. Vaishnavi KP, Ms. Nandana C, Mrs. Adira CK, Ms. Agnes Sona Jason, Ms. Hima PS, Ms. Chinmayi Goswami, and Ambiga I. Our co-conveners, Dr. Manoj Matthews, Dr. Sadish George, Dr. Binu Thomas, handled the hospitality committee, and who even took a share out of their time to even going to the airport to greet and receive the dignitaries and invited guests. Thanks are also due to the Venue and Event Management Committee, headed by Dr. Tania Francis, the Department of Chemistry, which was ably supported by Dr. Jisha Jacob, Dr. Saumya Varghese, Dr. Veena V, Ms. Nasiha CP, who meticulously planned each technical session and panel discussions without much delay. The committee was supported by our students and research scholars, Rashmi S. and our faculties like Anjana Matthew, Abhishek Mohan, research scholars like Lulu Mumtaz, Pilti Peter, Harishma, Adira, Shruti Mohan, Aisha Henna, Denjisha Das, Kartika Surendran, Archana Balakrishnan, and Navya CP. I also thank Dr. Rajesh KP, Dr. Sanoj E, Dr. Srichit from Samarins Guru Ayappan College, and Dr. Manju C. Nair from University of Calicut for their support in the conduct of scientific sessions. I also thank all the chairs and co-chairs who led the sessions on time without much delay. Thank you all. And one of the most important departments for a conference is travel and accommodation. Luckily, I am glad that I got the best conveners ever to head these committees. Dr. Srijit M. from Department of Chemistry for the Travel Committee, and Dr. Nidhin Jose from Commerce Department for Accommodation Committee. They were ably assisted by Mrs. Ashwati Ganga, research scholar from University of Calicut. She was also my student in Devagiri. The committee was ably supported by Dr. Shinoj K. from Kerala Varma College, Thrissur, Dr. Jayakrishnan T., Mr. Arun Prashant, then Mr. Arun A., Mr. Arshad, Mr. Abin Palat, Mr. Adar Senti, Fasil P., Vishnu V.S., Joman Chos, Dr. Sharmi George, Dr. Pooja Pushkaran, Dr. Reji Shipi, Dr. Manjula K.M., Mr. Vishnu, Mr. Krishnaraj, Mr. Muhammad Anis, Abhishek Thakur, and Muhammad Rabin. Thank you all. Thank you so much. A wonderful cultural eve was on the first day of the conference, which was planned by none other than our teachers from Malayalam department, Dr. Sarida Casey, and also ably assisted by Ms. Jyoti Lakshmi from Computer Science, again assisted by Anjana Matthew and Abhishek Mohan with our young talents, along with our young talents from Devagiri. Thank you one and all. The exhibition committee, we also had an exhibition in Hormes Auditorium. This committee was headed by Dr. Soumya S.L. from Department of Botany, assisted by Dr. Neena Mahesh, Neenu Maria George. I also place on record my gratitude to Malabar Botanical Garden and Institution for Plant Sciences, Botanical Survey of India Southern Circle, Center for Water Resources Development and Management, Hortus Malabaricus Botanical Garden and Research Institute for accepting our invitation to participate in the exhibition. Thanks are also due to our own team of young degree students who manage the Dev Shroom, a mushroom cultivation startup from our own department from St. Joseph's College, Devagiri. And also Phytony, the resin art studio from the Department of Botany. Actually, I'm not naming all the students because the list is very long. And regarding the food committee, I hope all of you enjoyed the food provided by the top taste team from Calicut. The committee was headed by Dr. Asha Matthew from Economics Department and also Dr. Pramod C. from University Calicut. He is one of our executive committee members of IIT. And the committee was ably supported by the members Arunima, Harida, Shifa, Saharatur Rabi, Josna, Nihara, Ananya, Devika Girish, Anugraha, Neha, Anchana Ramachandran. I also thank Dr. Josti Puttur also for his helps in initial planning of the arrangements. Then the most important committee, the Finance and Purchase Committee, which is headed by none other than our administrator, Father Boni Agustin, and the committee members, Office Superintendent Shaji AC, our accountant Dominic MV, Dr. Danny Francis, and I extend my sincere gratitude to all the committee members. And thanks are also due to Dr. Charlie Katakayam and Mr. Manu Anthony, Department of Business Management, for securing sponsorships for our event. Dr. Charlie Katakayam and Dr. Rachel John also headed the publicity committee, who was assisted by Ms. Swati K.S., Ms. Sridevi N.M., Dr. S.M.S., Ms. Rega C. Thanks to our media team, headed by Tijo K. George, Mr. Tijo K. George, Remo Benjamin, Adul Krishna, and Ms. Wahida Parveen. They ensured the smooth conduct of each session, online and offline, in a meticulous manner, without much delay. The team was supported by our technical committee members, Mr. Vijay E., Aravind Musafir, Abin Palat, Harish P.S., Arun A., Balakrishnan, Arun. As you all know, a separate conference website was made for this event. My own idea of a dedicated website was materialized by a team of developers from Scantech IT Solutions from Malappuram. Thanks to the entire team and also to Mr. Fahal Salam and Mr. Dilshad Keti, who assisted in solving all the technical issues related to the website. So they gave me tirelessly 24-hour service for the website. And also we had a housekeeping and parking committee, which is the reason why the campus is very clean and tidy, which was headed by Johnson EM and Janil, who ensured the campus tidy and clean with the supporting staff. I know each committee member has worked tirelessly day and night to ensure the smooth and successful conduct of this Coral Jubilee Conference. I sincerely thank all of you for your dedication and teamwork. And I also thank research scholars from Department of Botany, St. Joseph's College, University of Calicut for their unwavering support throughout the planning and execution of this event. And I also extend my heartfelt thanks to the research scholars from the Department of Botany, St. Joseph's College, Devagiri, for their timely help in all the planning and meticulous execution of this event. I have received help from various corners, my colleagues, my fellow colleagues from my department, my fellow colleagues from other department of the college, research scholars, my students. I cannot name everyone. If I missed any name, please bear with me. However, I cannot conclude this vote of thanks without mentioning a few names. They were my pillars of strength. They worked tirelessly. They worked even then they were not in their best of their health. They worked for the success of this event without even a complaint. From the bottom of my heart, I express my sincere gratitude to my students, Prasant MK, Vishnu VS. Please give them a grand applause. Who were my genies all through this event. You know, when I asked anything, they were ready to do all the works of conference. Then I wish to thank Dr. Krishna Priya, Dr. Janisha Epi, Lulu Mumtaz, Ashwati Ganga, her husband Arun A, my own dear MSc second year students, first year students, my student Dega C, Hasnath, and Mr. Don Thomas. I can't thank enough Don Thomas for who has made all the arrangements of the venue without even sleeping. All these conference days, he left the venue during 3 o'clock, 2 o'clock, or 3 o'clock. Thank you, Don. Thank you so much. And I would also like to extend my sincere thanks to Atul Krishna, who designed all the brochures and publicity materials. Mr. Tijo George for helping me with the media team. And also a special mention to one particular person, Arun Prasant from Pune University. He came here 1 week prior to this conference for only helping me. So thank you so much, Arun. Thank you. And also, I extend my thanks to his guide, Dr. Milind Sardesai, for allowing him to come over here and helping me. Thank you, sir. Again, a very special mention to my partner, Geomol KK, for her unwavering support throughout the planning of this event. She sacrificed a significant share of her family time to ensure the success of this conference. Without her dedication, this event would not have been possible. Thank you, dear. If I have missed anyone, kindly bear with me. Once again, I thank the college management for their wholehearted support for successful conduct of this event. Finally, I thank every participant for your cooperation, enthusiasm, and active involvement. Once again, my heartfelt gratitude to all. Thank you. I wish you a pleasant return journey and continued academic success. Thank you. Thank you, one and all. Thanks a lot.
Thank you, sir. With this, we formally conclude the valedictory function of the 35th Annual Conference of the Indian Association for Angiosperm Taxonomy. On behalf of the organizing committee and St. Joseph's College Autonomous Devagiri, we thank all dignitaries.
We should give a fitting appreciation to the secretary, organizing secretary, Manudev, and also his best half, Sujimol, in managing the entire conference, in doing the, I want to give a standing ovation. Please stand and, where is Manu? Where is Manu? Where is Manu? Come, Manu. Go there, go. Yeah. Who deserves? Okay. Thank you.
We wish you a safe journey home and look forward to welcoming you again at future AAT gatherings.